colleague will be showing a card with 2 minutes written on it, which indicates that you just have 2 minutes to wrap up. And we want this so that we have some time for some question and answers and further understanding of your work, of your body of work. I hope that works for you all. Yes. And second is that there might be some changes in the sequence. So I'll make an announcement. And so you all should be prepared. Otherwise, we'll largely follow the sequence of presenters that we have today. And please try to keep it very focused on the relevance of the subject. A template has been shared with you all to ensure that the right message comes across and you're also able to wrap up your work, summarize it in a good way. But if there are any further questions, I'm sure the esteemed jury members would be asking those questions or posing those questions to you. So thank you so much and all the very best. PG, if you want to add on something.
So good morning to all of you. I'm one of the juries, Sushmita here is the other one. Welcome to all of you. And I'm requesting all the presenters to come and sit in the front few rows. Okay. He's already given some basic rules, but firstly, apologies from our side to have to ask you to squeeze all your work in 10 minutes or less than that. I know that saying all that in a brief time is going to be a challenge for all of you, but look at it positively that you need to learn the art of communicating something quite complex in a very short period of time. We all know that today the attention span is only shrinking for everybody, right? So you need to imagine your presentation as like a YouTube Shorts video. So think of it that way and say what you want to say, get the gist of it across in about 7. When we say 7, maybe a minute or 2 we can accommodate, but largely aim for 7 so that you definitely finish in 8 or 9 minutes. When you speak, just be the 1 or 2 things that all of you need to emphasize, which we will look forward to, is to understand what problem you are trying to solve. Okay, so be very clear what is the problem you are trying to solve. In other words, what's the objective? What is the objective of your work? What is the objective it is trying to fulfill? The research topic or the topic that you're presenting, what is the purpose it's trying to fulfill? And then talk about what's unique about it and different about it and so on. And then the impact and the outcomes that you're looking at should come through clearly. This is what we want primarily, okay? And some of the technical details or how of it and so on, even if you rush through it a bit, it's okay. We'll take the details in the question answer if we want more details, okay? But be very clear on why you're doing this and what's the purpose and the rest of it you say in a very condensed form, okay? Is that clear broadly? Okay, thank you. So, best wishes to all of you.
So our first presenter for the day is Ms. Prerna Jadhav, who's a student of CEPT University. She will be presenting on eco-town planning, a sustainable approach to urban resilience in Ahmedabad. All the best, Prerna. There's a pointer kept on top. You can use that.
Good morning, everyone. I'm Ms. Prerna Jadhav. I'll be presenting town planning today. So, Ahmedabad is experiencing incremental growth in the built-up, and that is resulting into diminishing of the areas of water body. This is happening due to lack of planning consideration in DP and town planning schemes, along with CND waste being dumped is depleting the depth of the water bodies, and other waste also pollutes and degrades the aesthetic value and ecological value of the lakes and water bodies. Then later we come down to Ahmedabad is planning for its new development plan of 2041, and new water bodies are going to be added, and hence we need to protect the lakes. Why? Because lakes are an essential element and natural asset to the city, which provides microclimate, is a heat buffer, is a sponge to city, and slows the runoff. How do we do it? We do it through eco-town planning schemes, which essentially is to create a sustainable and resilient urban environment. The objectives of the project is to minimize the stormwater runoff, improve the aesthetical value of the water body, and enhance biodiversity. Also, reducing the reliance on traditional water infrastructure. How do we do it? We do it with the four principles of protect, delay, release, and capture. The elements of eco-TP schemes are categorized in three major factors at building level, street level, and the town planning level. To explain the project, three sites were strategically selected from urban to peri-urban, where the ladder of the project demonstrate the entire project from brownfield to greenfield, which goes from water to water plus plus rating, and each suggestions are categorized under DCR level, town planning level, and the DP level, where in DCR level certain guidelines are being provided, and when we come to the DP level, zoning and land use are provided for new retention ponds and to safeguard the existing water bodies. But then we come to the first case, which is Thaltej. This is the urban case, where currently the area of Thaltej is around 155 hectares, and the runoff capacity is 75% with its impermeable surfaces, and 25% is the permeable surface. And when we apply the three principles to the case, then the green coverage is boosted by 12%, and the runoff also, the impermeable surface also gets better by 2014, and it also acts as a heat buffer, and acts as a sponge to city, and protects the water body and area around it. Then we come to the next case, which is Makarba. This was strategically selected as it is also a historical site of historical importance, and could act as a city level park, where the entire site is 55 hectares, and after applying these three principles, the green cover would be boost to 16% from the existing 4%, and the runoff will also increase to 34 by 2041, and this scheme will also act as the heat buffer, sponge to the city, and a city level park for recreational to all. And then we come down to the last case, which is Sheila, which is outskirts of Ahmedabad, is going to be added in the new DP as a part of Ahmedabad city, where where all three principles are being applied here. As the development is yet to happen, and new retention pond areas could be reserved in this proposal, which will increase the green cover by 15%, and as well as improve the runoff capacity. Then to understand the funding mechanism and incentive of the entire project, few suggestions were made, like premium FSI for green buildings around 600 meters of buffer of the lake. Then betterment charges for the plot owner that utilizes the aesthetic view of the entire lake, and then stormwater retention credits. And the entire O&M would be based by CSR and PPT funding. That is how the entire land value captured of project was planned, green TDR was also proposed. After, at the end of the project, the city will be able to reduce the runoff by 20%, and the increased green cover will be almost by 15%. And the project is phased in 3 stages, where the current scenario is depleting of the water body. Then we come to short-term, medium-term, and long-term strategies, where each strategy could cater to water plus, and water plus plus, where all the suggestions which are planned are also a guided line to where exactly what suggestion could be made in the Act of Gujarat Town Planning and Urban Development Act, and in the DPTP and DCR, and who exactly would do it, AMC, like the urban municipal body of Ahmedabad, or the development body also is categorized. And then the entire, so Ahmedabad spends around 30 crores every year for flood mitigation. That could be resolved with this scheme. And the overall benefits are also categorized in 3: economical, social, and environmental, where the runoff is better to the city, air quality also improves, there's heat buffer. Then economic benefits are land value capture, you use betterment charges, etc., to channelize the economic benefits of it. Then general social benefits are the betterment of livability of the entire city. Thank you.
Okay, very good. I think excellent topic. Connecting town planning and urban planning to the idea of how do you promote water conservation and so on. But couple of observations. I mean, you didn't talk of, you only talked about green cover and reserving space for absorbing, but there are probably many more angles to what one may call an eco-town planning. That's the broad theme. For example, you didn't explore the idea of recirculating used water. Enough, right? That could be added to this water plus plus concept, right?
Yeah.
And similarly, general control on density. And then what's the strategy to make land available for these water bodies? I mean, you picked your examples where maybe some public land is already available. But what will you do in a land constraint scenario? I mean, Gujarat has taken the lead on land pooling, right? Whether that can be applied to this eco-town concept. So there are scope to, I felt that. What are your reactions to that?
So as the ladder goes from brownfield to greenfield, so the greenfield, which has the scope to have the detention ponds marked in the new TP schemes, are being demonstrated in the third case, where there's a potential to go to water plus plus. So I had taken the case of Sheila, where there is existing water body, but also as per the topography, new water bodies can also be planned. And coming to the reuse pointer, I have not explored that part. Since we were doing a blue-green infrastructure, we did not look into the sanitation factor of it.
Yeah. So it was good to hear your presentation. Thank you. One of the questions that I have is regarding, it's a plan right now and it's for 2041. But have you looked at how will it practically be implemented? Because there are lots of challenges with, these approaches, and if it has to be implemented in the plan of 2041, then what has to be done beforehand? So what is the thinking on those aspects? And also, you spoke about financing, but in reality, would that really work or not? So what are your thoughts on that?
So I had given suggestions, and what suggestions could go under what category was also there in the last slide, where the where things would have to be mentioned in the act itself, because act acts as a guideline to form the entire DP. And then after that, there will be guidelines in the DP as a guidance note. And along with the DP, there will also be a mention in the Town Planning Scheme Act, as well as the buffer guidelines and the building norms for green building norm will be included in the DCR for Gujarat. So that's how I wanted to materialize the entire project to make it a reality.
Any questions from the audience? Maybe one question we can take if anybody has any questions, further questions. No, so we'll move on to the next one. Yeah, sure. Absolutely. And I'll request if anyone has any burning questions, immediately after the jury members have asked their questions, posed their questions, please raise your hand so that we can wrap it up fast. Thank you. Thank you so much, Prerna. So may I invite our, can I have a round of applause for her? I would like to invite our next speaker, next presenter, Kayla Coppens, who's a PhD student from University of Geneva. She will be presenting on vermifiltration for domestic wastewater treatment, performance analysis of a full-scale treatment installation and evaluation of effluent reuse for irrigation. Over to you, Kayla. All the best.
Great, thanks. I hope this is going to work. Was this working or was it not working? It works, great. Great, so thank you, Sandhya, for that warm welcome. Maybe I can stand up here. So yeah, today I will be presenting vermifiltration for domestic wastewater treatment. This is the main project that I'm doing for my PhD with both the University of Geneva and EWAG in Switzerland. I also partnership with ANICO, which is an implementation partner, implementing nature-based sanitation solutions in Switzerland itself. Oh, maybe this one. Okay, sorry. So just to briefly explain what is vermifiltration for those who maybe don't know it. So it is a nature-based solution, which is why I can present at this conference. It uses earthworms and microorganisms to treat wastewater. And to also briefly mention the difference between vermicomposting and vermifiltration. So vermifiltration is really for wastewater, whereas vermicomposting is more of a dry source for either dry toilets, like with the tiger worm toilets, or for organic waste from kitchens. The advantages of vermifiltration are very similar to the advantages that we see for nature-based sanitations, which were so nicely discussed on the first day by Shri Harshvardhan. So I won't go into more detail, though just to highlight a few. Vermifiltration has a very high degradation of organic matter, though there's not any sludge production, so we don't actually have to empty the filter. And I think this is a really big advantage. Also something that came up that's not listed here, but that after listening to many presentations over the last 2 days, one advantage of this is, though one of the limitations is its large space requirements, this space can also be underground because the vermifilter actually worms do not like sunlight. So you can build this in a containment or underground in a basement, and I think that's something to mention. Bottlenecks to wider implementation. So there are some limitations, one being the sensitivity to temperature. This I will talk a bit more in the results. Low removal of nutrients and pathogens, as well as the large space requirements. Additionally to that, there's a lack of uniform design and operation. So when we look into the field, what is being done, there's many vertical flow, horizontal flow, different materials being used. So it's hard to know what is best and how to optimize. Also, there's many research focuses on lab scale. So when we look into the documentation, we have a lot of results on lab scale, but how does that scale up and how does it work in a full scale? This was also something discussed by Andreas Schmidt in the first day, that we're lacking long-term data. So this is some of the bottlenecks to implementation. So my research aims to look into these different limitations. There's 2 different phases, the full-scale performance. So I'm evaluating a full-scale vermifilter, and then looking into the lab, implementing lab scale to test different operation, organic loading, nitrogen loading, hydraulic loading, and how this impacts the performance. But today I will focus on the first full-scale performance. So to talk a bit more about that, I looked at a full-scale vermifilter in Geneva, in Switzerland. Here we see it's really in the urban center of Geneva. It was commissioned in January 2017. I studied it in the winter of 2022 and summer of 2023. Here's the building which it's implemented for. It's a housing cooperative with 38 apartment homes, so it's about 100 population equivalent and about it's more or less 7 cubic meters of water per day being treated. To talk a bit more about the study system. So here's a symptomatic schema. There's the black and the gray water, which are treated separately. The black water is treated by the black water vermifilter. Both the black water vermifilter and the gray water vermifilter have the same composition. It's 20 centimeters of compost where live the earthworms, followed by 20 centimeters of fine biochar and 50 centimeters of coarse biochar. Both of the biochars come from a wood source and are locally sourced. The gray water flows passively into a degreasing and settling tank. From there, the supernatant gray water is treated by 2 biochar filters, and everything sedimented on the bottom is pumped onto the gray water vermifilter. The effluent from both vermifilters and the gray water vermifilter, the gray water biochar filter, are treated by 2 post treatments. There's the first vertical flow mineral filter and the second horizontal flow mineral filter. And the points in yellow 1 to 9 are where I sampled. All of this water is then collected. The treated effluent is collected in a retention tank and used for flushing the toilet and watering the green space directly in the city center. So the operation conditions, I won't go into all of this, but this is actually already results because before my study, we didn't know what exactly was happening there. Just to note that there is the surface area between the black water and the gray water vermifilter is quite different, 44 square meters to less than 1. Also, only half of the black water vermifilter is fed at a time. Also, to note, just the hydraulic loading rate and the organic loading rate observed at this installation are much lower than what we see in the literature. So we could say that the filter is over-dimensioned if we compare to what has been done previously. So now just to get into the results, I have left the schema up there to give an idea in case if we forget. So the removal efficiency, there's the black water vermifilter and the gray water vermifilter. The black water is really points 1 to 3 in the sampling, and the gray water is 4 to 6. So this is what removal efficiency we saw. For the organics, BOD, COD, and the solids, TSS, we are really on the higher end of the removal efficiencies when compared to the literature. For total nitrogen and total phosphorus, it was much lower. Or was within the range observed in the literature, but not really, we would like to improve this, especially for the black water. Then I also compared the effluent water quality to discharge standards implemented in Europe. So here we see the effluent of the black water vermifilter, the gray water vermifilter, the effluent of the first vertical flow mineral filter, and then in the retention tank. So here in bold is when it complies to the standards, and we see that both the black water and the gray water vermifilter effluents do not really comply to the standards. So there is a need for post-treatment. Nonetheless, after the first mineral filter already, we have a sufficient quality for discharge. I also compared, as this conference is about circularity, I compared it to the irrigation standards. So I used the JRC. It's also a joint research center in Europe. So these are also European standards. This is not really a yes or a no. It's more there's different classes in irrigation classes. So there's A, B, C, which isn't here because none of the qualities are C, D, and unclassified. And what we can see is quite quickly the black water and gray water vermifilter are unclassified, so unusable for irrigation. And also the E. coli concentration is quite high, and this is the most limiting parameter. So it makes the RT, the retention tank water, a class D, which is quite limited in its use. If we were to add a disinfection step already after the first mineral filter, we would have a class B, which can be used for all crops with drip irrigation. Lastly, as I said a bit earlier, I looked at the difference between temperature. So I looked at it in winter and summer, and I saw that despite that in the literature, we see that the ideal temperature for vermifiltration is between 26 and 37 degrees Celsius. Even in the 5.9 degrees Celsius winter temperatures of Geneva, there was no significant difference in the effluent quality between summer and winter. So insights for optimization. Vermifiltration is optimal for wastewater with high organic and low hydraulic loads. With appropriate design and operation, vermifiltration can function in colder climates. This we think is mostly due to the fact that it's underground and there's this straw layer that we add in winter to insulate. Vermifiltration needs post-treatment, though we could eventually decrease the amount of post-treatment that we see at this vermifilter in Switzerland. That notably, like the second mineral filter could be removed, which represents 34% of the volume. Oh, sorry, we also think that urine separation would increase the removal efficiency of nitrogen. So we would suggest this, and the addition of a disinfection step would greatly improve the installation and the usability of it in agriculture. So that's all. Here are some pictures. We see the terrace from which, like, this is what it looks like, and it's really underneath this terrace is where the dairy filter exists. Yeah, thank you so much for your attention. This one.
Thank you for the presentation, Kayla. It was really interesting. So in vermifilter, what we have always seen is that, it's very, very sensitive to the microclimate or the microenvironment that the worms are growing in. And there are many projects in India that have failed because, initially when the people who have worked with it are still there, it's working. But when you leave it to the community or it doesn't work that well, and it's only because the microenvironment is not being managed. So keeping that in mind, how do you see this system surviving those problems that that are inevitable?
Yeah, so it's a good question. It's actually something I'm hoping to discover more well in India, because I would like to talk with more practitioners in India using vermifiltration, because from our experience in Switzerland is there's not much that we do. There's not so much maintenance. They add straw every now and then, and this is really done by the community living in this building. So there's not really professionals coming in. It's just it's very simple maintenance actually, and it's been running since 2017 with no problems. Like the earthworms are always there, the water quality is very good. So it's actually something I would like to better understand, and I wonder if this is a design. Also, the context is very different. Context is something that we also talked a lot about during this conference. It's much warmer here, so maybe it dries out much faster. Maybe the different type. Yeah, I think this is something to be explored, and it's something I hope to do during my trip in India, is to talk with practitioners and to better understand and maybe help them improve their system so that it is more resilient to these changes and can be maintained more easily. Thank you.
Yeah, so you're aware of that Innokua project that was done in India?
Yes, I wasn't able to visit it, but yeah.
Right. So, I mean, that's our experience at CDD. So we are familiar with vermifiltration as an idea. You've been in touch with Prime Move in India, that they do some tiger biofilters or something. Tiger worms. Anyway, you were talking about your interest in India, so I mentioned that.
Yeah, thank you.
But one of my initial observations on the technology is that it's quite robust in that sense, notwithstanding what Sushmita said about worms dying when you don't take care of them. In terms of general resilience to the load variations and so on. But I've always had a concern on cost and area requirements. And so can you give the numbers on what is the per KL, what's the area requirement for this vermifilter?
Yeah, so per person, what we have in this vermifilter is 0.5 square meters surface area per person. But this, I think, is also, like I said, it could probably be because of this 34% removal, like we could actually decrease this size, and I would actually say we could go down to 0.3 square meters of surface area.
When you said per person, it's per 0.1 liter KL?
So this is the problem currently. It was designed really based on, because there wasn't much data on, okay, how much water, much, this wasn't
You
known.
said 40 homes, right?
38 apartments, yeah, plus there's some apartments. So this is something.
Did you say 7 MLD or something?
Yes, 7 cubic meters per day. But so for example,
KLD.
yeah, so these things, so the answers to these questions is what I really hope to do by the end of my PhD, and to have kind of a better guideline of, based on which type of water we have, how we should design the filter, because I think it's really also the organic and the hydraulic load is really important when designing. And I think based on this, if we have a high organic and low hydraulic load, we can actually make it quite small. So these things I would like to.
Yeah, so I think that's going to be the the critical factor according to me, the cost as well as the area required.
Yeah, and the
If
cost.
we can do it in, even comparable to something like PWATs or some other technologies, which are still area intensive, it's great scope, particularly in India with warmer climates. I think it only does better if I'm not
Yeah,
wrong.
no, definitely.
Yeah.
Great, thank you for the comments.
But on the removal efficiency, I see a number which says, post the vermi filters, you're talking about, output POD is 98.
So this, the effluent quality was 98 and the removal efficiency was 82%. So
Right.
the left-hand side.
But it's after removing 82%, it was 98.
Yes, after removal, we had
So
a
it's
concentration.
300, 400 is the original number,
Mhm,
or even higher it looks like.
it's a bit
Okay.
higher, yeah.
And what is this mineral filter you're referring to?
So the mineral filter, it's it's 80 centimeters tall. And it's layers of gravel and sand that's in decreasing diameter.
That seems to be doing a great job from bringing it from 98 to 9. Is that right?
Yes, definitely. And I think that's where we really see the need for this first post-treatment step, but then the second, the horizontal flow mineral filter is maybe less necessary. But the first one I think is a very good combination to put together. I also would suggest that I've been talking with some people around here, and maybe having a planted filter as a post-treatment might also really improve the nutrient removal. So there's some kind of combination.
Sort
to
of
play
my
with.
takeaway from this slide is vertical flow mineral filter is doing a great job.
Yes, but I think the Blackwater vermi filter is also doing a great job, just needs a bit more. I think, because I think the worms play a really important role. Like for us, this first layer is really the solid liquid separation, and the solids stay there. And so we also see here, for example, the TSS removal efficiencies. The standard deviation is really low. So this removal of solids is really high and it's very consistent. And I think this is something also to take away, that we have a really high solids removal and no need to desludge. So that's a big advantage of this vermi filter.
Yep.
Just quickly about this filter material that you're using, how often does it need to be replaced?
So this is a very good question, and this is a pilot, right? So it's been there since 2017, and we haven't replaced it since 2017, but it's something that we will see. So when we first originally implemented the system, we said 10 years. We're coming up on that 10 years, but we will see. But up until now, there's no signs of clogging, and it seems to be the hydraulic flow is still going well.
Does the inflow change the quality of the inflow, or is it quite same throughout? Because that would maybe also determine, because in India, that's a problem, that your inflow quality varies so much that your performance gets affected. And also the verbs will get affected.
Yeah, so I mean, I took this out. I had a slide to shorten it up. I took it out, so I really looked at the difference between the gray water and the black water. And the difference in, for example, pH is huge. The gray water influence is around 7.5 and the black water is around 9. And same thing for electric conductivity. It was about 10 times higher in the black water vermi filter than the gray water vermi filter, but there was no significant impact of that change on the performance of the vermi filter. Of course, this is within a range of, like I didn't check extremes, but it seems with this filter, I think because it's also over-dimensioned, it's quite robust and resilient to daily fluctuations.
Sorry, I'm just getting clarity on these numbers. When you say MF1, you're referring to?
The mineral filter 1, so it's the first vertical flow. So it's really.
And this is at the output.
Yes,
Okay.
so this is kind of the sample spot 7, so it's really coming out of the vertical flow mineral filter, and then RT is really the retention takes sample
Right.
spot 9.
And what were the influent values?
The influent values? Oh, I don't remember.
DOD.
I have it in a table somewhere, but I can't say, I don't remember exactly.
No, because the COD 331 also looks quite high. That's why I was asking. What influence COD could have been approximately how?
Yeah, the influence, I think it was around, it was quite high.
1,000?
Yeah, over 1,000.
Over
And
1,000.
one reason why is
And
like
this is a residential complex.
it's residential, but they actually have, it's also very different to the context in India because we use a lot of water in Switzerland. But so maybe it's a bit more dilute, but in comparison to the wastewater that we would see in Switzerland normally, this water was much more charged because this building uses less water because they have a lot of economical like shower heads and like different devices. So they use less water, which is good. But that means that the incoming load is actually, the concentration is higher. And this is one thing that we're looking at in Switzerland. Like, is it fair to talk in concentrations or should we talk in loads? Because in the end, the load is the same, but the concentration is higher just because we're diluting with more water. So there's this saying like, is dilution the solution to pollution? No, not so much. So how can, like, we're actually probably doing much better here. And I compared it to the centralized wastewater treatment plants in Switzerland, and it is performing much better.
It looks like from the numbers, it's 2000 COD, normally influent, yeah.
Yeah.
It's quite a lot, yeah.
Great. Maybe we have to, I see Sandhya pushing us out.
Thank you so much, Kayla. That was indeed a very interesting topic for all of us. And you can make that out with the number of questions you posed. Yes, you can get in touch with her offline. So I would like to invite our next presenter, which is Mr. Santosh Garakalli Siddhaya, who is a technical expert wastewater with Boda South Asia. He will be presenting on nature-based wastewater treatment for resilient communities in the Himalayan region, a demonstration project at the district police line in Leh. Over to you, Santosh. Good luck.
Thank you, Sandhya. Okay. Thank you, Sandhya. I'll be taking you all through this demonstration project that we did in Leh, Union Territory of Ladakh. So this presentation will have about 4 parts to it. Why does this go? Yeah, 4 parts to it. Start with some introduction, bit of methodology, and discussion on the results, and end with a conclusion. So this is the latest map of Ladakh. So there you see the red dot there, which is Leh, which is about, it's a capital city. It is a touristic spot and also a small town. It's about 10,000 feet above the mean sea level. It's basically a hilly terrain. We call it cold desert because it's most part of the year it is cold and it is humid. It has extreme temperatures during winter, that is roughly from November to end of February. Temperatures go as low as minus 30 degrees Celsius. Any water on the surface gets frozen. Even the water up to 1.2 meters below ground level gets frozen during winter. So this is district police line, which is in Leh, which is present south of Leh boundary. So it is just next to the Indus River. So about 7 acres campus where about 500 people are there. So there's a police quarters and there's also barrack and office. So yeah, the practice was they were depending on septic tanks and soak pits, which used to get frozen during winter. And sometimes they're also not able to comfortably use the wash facilities during winter. So what we proposed was to convey the wastewater to the lowest possible point in this location and treat it using the DWATS approach. So classic DWATS approach with settler, anaerobic backfilled reactor, and a planted gravel filter was adopted. What's different in this location is to ensure this DWATS function throughout the year, even during these three to 4 months of harsh winter. So we adopted some adaptation strategies to this. So this is the master plan of this project. So the lowest point was to the southwest of this location, and outside the boundary is where the Indus River flows. So all the wastewater was conveyed through a sewer system, and a location was identified to pointer doesn't work. Sorry. So yeah, location was identified and wastewater treatment was done. So here the catch was to adopt some final treatment strategies. That is, so we know in Leh the water freezes. Anything which is above the surface freezes, right? So during winter, we had a strategy of using a solar-powered aeration system, and during summers we would continue using planted river filter as the final treatment system, and pressure sand carbon filter would continue being there. So how did we even do this? So the treatment system would function as it is throughout the year. During summer, only during winter, the water which has to be pumped from the final treated water tank to the planted river filter would not happen, and a solar powered aeration system would come into the place, and After the aeration, sand carbon filter, water would be either, and again, we cannot reuse the water during the winter, so water would just percolate down through soak pit after the treatment. So what did we do differently here? So we insulated all the exposed pipe that comes down the building, down the police quarters building, and then we also have a seasonal adaptability of using blanket river filter and aeration system during winter. So these systems, the pumps and the sand carbon pumps for the sand carbon filter was also powered through solar panels. So yeah, we could demonstrate this project now successfully in Leh. Now that Leh municipality has a new rule. Leh is a touristic town, so there is a lot of hotels and resorts around in the boundary. So now Leh municipality says that any hotel which has more than 20 units of room or even a restaurant should have their own treatment system. So now after we have demonstrated this particular approach for treating wastewater, some of these hotels also have approached us for adopting this treatment system in Leh. So some of the takeaways. So this is the first full-scale DWATS approach in Leh. It has sustained 2 winters already. Water has not frozen, and people in the police quarters could use the wash facility during winters. There's already a demand from district police line in Kargil, so they've asked us our support for having one of these systems in Kargil district police line. So what is the bottom line is we can contextualize these nature-based solutions to some of these adaptation, climate resilience and adaptation. We are also the reuse can really foster green infrastructure and community well-being. And we can really showcase some of synergy between the technology and ecology for urban resilience and adaptation. So, yeah, that's my thank you.
Thanks, Santosh. Just few questions. So the
Yeah.
first question that I have is, the main problem here was that during winter, the existing septic tank and soak pit would be frozen.
Yes.
So was there any way that you thought about while before starting this implementation of DWATS is whether this can be made to work, the existing system can be made to work in winter? So that's my first question. And the second question is, you said it's been working for 2 years now. So how is the performance during summer and during winter? What is the difference? And what is being done with the treated water?
Yeah. So there were several septic tanks and soak pits around. Actually, to make them work would be equally challenging, and there was no common community septic tanks. So they were already finding it challenging to use the wash facility during winters. So we wanted to bring everything at one place so that and insulate them so that everything works well and fine. But we did not really think about insulating the pipes and just using the septic tank. They were also having this challenge of accessing some of these septic tanks for desludging during regular throughout the year. So that was also one of the challenge where they felt they want one treatment system at one location. So we went ahead having this as one of the approaches. Regarding the performance, we did not really test the wastewater because we did not have budget and we had other constraints. But visually, the water was it was of course smelling septic, but it was not colorless for sure. It was in color. This year we are planning to run some experiment, send the samples to Delhi and get it tested. But it is treating to a certain extent. I mean, visual appearance, it seems to be working and it is treated. Our first achievement in this project is that it has already, the water has not frozen in winter and people are able to use the wash facilities during winter. That's our first achievement, which is first objective met. So this year we'll run some tests and see how well it performs. We have 7-acre campus, so we intend to reuse the treated wastewater for the green spaces in the campus, and that was one of the other objective which actually the district police line wanted to have. They don't have scarcity of water, but I think the management is an issue, so they wanted to reuse the treated wastewater. That was another objective with this project.
Yeah, how much KL?
It is 30,000 liters, 30
30
KL.
KL.
Yeah.
Okay. How much did it cost?
It costed about 40 lakh rupees for the treatment system, close to 60 lakh rupees for sewer line, which is about 600 meters length overall.
It's who funded it?
It was district police department, autonomous body.
It's a 1 crore project.
Yeah, one.
Okay. And now one of the objectives that were met, you said was the toilets did continue to work.
Yes.
Can you attribute that mainly to the insulation of the pipes?
Yes, mainly insulation of
It was not
pipes.
anything to do with the DWAT system, right?
Also, septic tanks and soak pits would choke. Choke as in freeze, and they were also not able to flush the toilets. And they were only relying on dry toilets during winter. Now they're able to use flush toilets.
And mainly because you.
Yeah, there is a
replaced-
place where water can go, get stagnated, and get treated.
And that's because you have insulated the pipes.
Yeah, insulated the pipes. That is one of the reasons.
Primary reason?
Sorry.
Is that
Primary reason, and also one thing that I missed was the deep frost line is 1.2 meters. So our DWAT system is below that deep frost line. So
but septic
also-
tanks are above them.
Septic tanks are next to the building, and yeah, not really. Yeah, it's above that. And they were freezing. They were not covered clear properly and things like that. So yeah.
And I saw a greenhouse kind of thing.
Yes, that is to protect the sand and carbon filter.
In the winter, that greenhouse keeps it warm, is it?
Yes, it is a local solution. They call it Trombe wall, which keeps inside that room. It is quite warm even during winters.
Okay. And no quality data, as you said.
No quality data yet, but visually it seems to be working.
But you did say it's a little pale in this little smell.
Yes. After anaerobic filter, it is like that. After aeration, again there is color, but smell would go off after aeration.
Okay, and after the PGF?
PGF, we haven't had a chance to completely use the PGF until now. We will use it this year, and we're expecting that the color
And aeration is happening in a closed tank.
closed tank.
Okay.
So the cost is high because generally in lay it is always 1.5 to 2x because of the area weightage. Everything is expensive in lay, so the cost is equally. Yeah. So, okay, thank you everybody.
Thank you so much, Santosh. May I now invite our next presenter, a slight change. I'd like to call upon my colleague Meghna P, Program Engineer in CDD, who will be presenting on evaluating the effluent quality from fecal sludge treatment plants, performance assessment study in India. Over to you, Meghna.
Good morning, all. So I'll be presenting on the fecal sludge treatment plants monitoring, basically a monitoring study. Thank you. So we know there is a rapid increase in the population growth. When there is a population growth, obviously the fecal sludge generation will obviously be more, and due to that that is where our fecal sludge treatment plants comes into picture. And how important it is to design a fecal sludge treatment plant and to construct it. It is that important to monitor the fecal sludge treatment plant, similar just like giving birth to a child and taking care of it. So under this background, we have conducted a study for evaluating the fecal sludge treatment plants effluent in order to improve their treatment efficiency and the system reliability.
So our specific objectives of the study were to facilitate the process of effluent quality monitoring of all 4 FSTPs in Uttar Pradesh, Madhya Pradesh, Chhattisgarh, and to analyze the data for the load received at these FSTPs. And the next one was to improve the operation and maintenance strategy for these FSTPs. The study area was like Kali Bilod, which is in the Madhya Pradesh, and Ameti, which is in Uttar Pradesh, Kumari Patora, which is in Chhattisgarh, and the capacities are as mentioned. So the activities carried out for this study was like site visit. This study was done for 10 cycles of sampling. So the initial sampling was done by the CDD members. CDD member visited each and every FSTP, then conducted a training on how to do the sampling and all, and then gave some inputs on operation and maintenance also. After that, later on, all the sampling was done by the field coordinators, and the samples were analyzed, and the results were analyzed. So the details of the sites are as follows. First one is Ameti, which is in Uttar Pradesh. The capacity of the plant is 3 KLD, and the utilization capacity of the plant is 70%. The treatment process is screening chamber. It also includes anaerobic stabilization reactor, planted drying beds, integrated settler anaerobic filter, and also planted gravel filter along with the collection tank. Next one is Kali Bilod, which is in Madhya Pradesh. Capacity is similar to the Amiti, and utilization capacity here is 60%. Treatment process here is screening chamber, planted drying beds, planted gravel filter, and polishing pond. And the other one is Patora, which is of 9 KLW, relatively a lesser capacity. The utilization capacity here was greater than 100%, which is overloaded actually. And the treatment process include screening chamber, planted drying beds, integrated settler and anaerobic filter, and polishing planted gravel filter and a polishing pond. And Kumari FSTP, which is of 6 KLD. Utilization capacity here was very low, which was 20%. And this also had the same treatment process. So when it comes to results and discussion, all the 10 cycles of analysis data was interpreted, and then we got this the results. So the pH of all the sites, equivalent of all the sites, site pH was within the MOEF standards. And when it comes to TSS, as I already told, Patora FSTP, which is already overloaded, it has higher TSS. And when for Patora FSTP, TSS is very high, and also if we see BOD of Patora FSTP, it is also high, which also tells that higher due to the overloading of the FSTP, treatment efficiency is not being that efficient. Next, when it comes to nutrients, TN and TP, as we know, anaerobic process, it is less efficient in removing the nutrients. Although FSTPs had comparatively high nutrient values, TN and TPs, and fecal coliforms, in all the FSTPs, fecal coliforms were less than MOEF standard. So the challenges for doing all these study was like ensuring the sampling, follow up the sampling protocols by the field coordinators or the plant operators, and then receiving the data from the plant operators. And after the analysis also, there were few outliers from the labs analyzing that, and also the availability of the lab, proper accredited lab for the study. And the other main concern was irregularity of the loads. Many a times FSTP doesn't get proper loads, which due to which the sampling gets delayed, and proper interpretations will not be possible. So when it comes to conclusion, for Amiti FSTP, ASR was effective in digesting the sludge and also reducing the fecal coliforms. And the lower values, if we see all the 4 sites, one common observation was PDB was very efficient in reducing the organic matter and the total suspended solids. And then Patora FSTP, which was overloaded, and all TSS, BOD, all the parameters were at higher end. And next, the Kali Bilod FSTP. There was good reduction in the organic matter and also, okay, but the total phosphorus among all the sites, it was very high. And Kumari FSTP, since there was less loading, like plant was underloaded, treatment efficiency was okay, but not up to the mark. And there were few elevated values in the parameters were observed. Thank you.
Thanks, Meghna. Just few questions regarding the four systems. So I think three of the systems are very similar from the design perspective,
Yes.
and only one of them has got PDV and PGF.
One-
The others have got anaerobic filter,
Yes.
integrated settler, everything. So does that make a difference in the performance?
No, ma'am. So if you influent whatever which was receiving at the Kali below FSTP was comparatively having the lesser concentration than all these FSTPs.
So in Kumhari, which is underloaded, the system which is
Yes.
underloaded, so you still see elevated values of the parameters.
Hmm.
So what is the reason for that?
This might be due to the improper availability of organic matter for the microbes to degrade it.
So what would be the takeaway from this comparison that you have done? Because if we are looking at scaling up and implementing such systems in many other places, so what have we learned from here so that, you know, when we are implementing again in different places, what would be the design modifications? What would be the implementation or operational modifications that need to be taken care of?
Okay, when it comes to design modifications and all, that is actually our way forward, ma'am. We are looking into it, what can be actually done. And when it comes to design modifications, I think, according to me, this is a very less data which is available for us. We have to still explore few other FSTPs and also according to the region and the geographical locations. And then do the study and then do the modifications in our designs.
How many months did it take?
So we have done it for 1 year, total 10 cycles of sampling.
Okay. Can I see all the four processes once more?
Yes, sir.
This is the only one which has stabilization reactor,
Yes.
right? And loading capacity 70%, 30%, okay. And only in Kali below you didn't have the settler, you didn't have the DWATs.
Yes.
Cleaning chamber, planted drying buds and PGF. Okay, next. These two are identical,
Yes.
right? 100%. Okay. So Patora was obviously high in all the three. Among the remaining three, which was the most efficient?
Most efficient was Amethi, sir.
Can I go there? 70% utilization. Okay, for the capacity of the system of 3 KLD means it's an influent capacity.
Yes,
right?
influent capacity.
Would you have an idea for every kiloliter of influent, what's the kiloliter of effluent you get?
Actually, we consider 3% of solids and 95 to 97% of
There's no other evaporation or any other thing happening when it passes through the.
Yes, sir,
PDB.
there is evaporation factor.
So do we know how much effluent we actually get? For every 3 KL, do we get 2 KL or more than 2 KL?
More than 2 KLs.
That's what we think. We didn't measure it, right?
Yes, sir.
Okay. Did you also look at, while doing the sampling, did you take the outlet of the PGF as the main sample?
Yes, sir, outlet of the PG.
Is that the only sample you took?
Yeah, inlet, PDP outlet and the PGF outlets.
PDP outlet you took?
Yes, sir, PDP outlet we have taken.
Okay. Did you present the data on PDP outlet?
No, sir, I didn't.
Okay. Was there any observation on how much removal happened after the PDP outlet?
So after the PDP, it was nearly 90% of removal, sir.
At PDP?
Yes, sir.
So,
Outlet of the PDP.
So the rest of it was not at all doing any further treatment, correct?
It is doing, sir. The rest other 10%, whichever is left over, because all the solids it retains on the bed itself, so we do get so much of efficiencies.
But that would have been a useful analysis to see what was the outlet percentage removal at PDB outlet, and what's the percentage removal entirely after that, because you're spending a lot of money for this Bettler aerobic reactor PGF, right? Whether it's adding corresponding level of treatment would have been good to see.
Yes, sir. I can just tell the range in between which the PDB outlets was.
Yeah.
So the BOD was between 150 to 100.
Okay,
And TSS was what between 150, 200 to 150.
okay. PDB outlet is giving you 150 to 100.
Yes, sir.
I thought it'd be less than that. 150.
No, it
It's
is.
100 plus BOD.
It is like I've considered the higher one, sir.
Because when it comes out of the PGF, you're talking about everything less than 30.
Yes.
Then you're getting good removal at both stages.
Yes, sir.
That's what it means.
Yes, sir.
But yeah, it would have been good to characterize the influent while giving us all the results. You have not done that, no?
I have done that, sir, but due to time restriction, I've just put down the.
So what was the
slides.
influent values? You said some of them were diluted and all of that.
Not diluted, sir. Especially the Kali pilot sample, it was influent values are very low. Not it was between BOD values was between 1,000 to 2,000. Usually we get in rest of the sites it was nearly 5,000. In only in Kali pilot it was.
What was the objective of this exercise? Was it to see whether all of these processes are meeting the norms? Or was it to see which of these processes are delivering better?
Actually, the objective was to monitor the FSTP, sir. Whether the effluent is meeting the standard or.
That's all.
Yes, sir.
You are not trying to relatively compare the efficiency of different systems.
No, sir, not actually. We just wanted to check the effluent quality of all the FSTPs.
So it was a limited objective.
Yes.
Okay.
Thank you.
Can we have a round of applause for? Now I'd like to invite our next presenter, Ms. Girija Ramakrishna, who's research scholar in IISc. Her topic will be fecal sludge quality criteria to inform a regulatory framework for safe application in India, a comprehensive review of global regulations. Over to you, Girija. Good luck.
A very good morning to everyone. I'm Girija. I'm the research scholar at Indian Institute of Science. I'm also associated with CDD India. CDD stands for Consortium for Diverse Dissemination. So now I'll present a comprehensive review on worldwide global regulations and standards that are existing for sludge-based inputs. So you can see the sanitation coverage mostly relies on on-site sanitation systems. And there are already enough evidences to say that the sludge that is generated from these on-site systems are rich in nutrients and organic matter. Hence, these can be used back in the system. But in India, especially in most of the developing regions, we don't have specific quality guidelines which will actually help in promoting the application of this fecal sludge in agriculture and for different applications. So, currently, we also relying on existing guidelines, which are given in the global level. There is very specific quality guidelines. Now, in the Global South and in India, we cannot apply directly the guidelines which are given by the global north specific to sewage sludge because the characteristics are different. Sewage sludge, there are chances of industrial effluents mixing, and it is not a direct domestic waste where we see the pathogen contamination is less compared to fecal sludge. And now recently we have also seen that fecal sludge is again contaminated with recent emerging contaminants like the pharmaceutical products, personal grade products, and cleaning agents. These are comparatively less in sewage sludge. Hence, there is a need to develop a comprehensive quality criteria which is applicable to India and most of the developing regions, which will help and promote the application of fecal sludge for different purposes. But in the interest of time, I'll only talk about, I'll limit myself to agricultural applications. So the objective of this complete study and the review was to compile and develop a comprehensive quality criteria for thick-slice application in agriculture. So what we did was we did a detailed literature review of the regulations and guidelines that are existing worldwide. We included from the peer-reviewed journals, the institutions, national and international bodies, and our focus was on the parameters which are very much related to soil applications. The relatives like the physical parameters, chemical parameters, mainly on essential plant nutrient parameters, and then the heavy metals and emerging contaminants. And then what we did the descriptive statistics of the concentration limits given by different bodies to understand what is the limits, but what is the range, permissible limits given for different parameters. And then developed a comprehensive quality parameters. I mean, this is how we have actually we have actually compiled around 35 countries data on different parameters. So if you look at the evolution, of quality guidelines over time across different countries, like from 1971 to 2019, it is across different parameters, categories, like I've given the index. The big one is heavy metals. The focus is mainly on heavy metals. The early regulations also from 1970s, it is mostly the focus was on regulating the heavy metal contamination in sludge-based inputs. And then if you move further, it is then the broad spectrum of parameters is increasing. They're adding pathogens, which is green in color, and the physiochemical parameters. And physiochemical parameters are important for if you want to use thick-slice in agriculture for soil parameters. And then moving further, we have emerging contaminants. So that's all. So there is, with time, what we say is because there is an increase in awareness of environmental health and there is scientific advancement, we can see there is an increase in broad spectrum of parameters, but still the focus was mainly on heavy metals. So if you look at the quality parameter, the concentration levels, what we have done is for different categories, for here it is for heavy metals. What is the frequency of appearance of this particular heavy metal and which concentration range? If you see that, this was mainly to understand which parameter has high focus. So for example, in case of arsenic, in case of arsenic, if you see the top the left corner, so arsenic and the mercury, the permissible limits are comparatively lower. It is between all are in mg per kg. So if you see arsenic and mercury, they are between hundreds. And then if you then go to other parameters like zinc and copper, then the parameter range is in thousands. So which means because arsenic and mercury are highly toxic, so the permissible limits are very low. But because zinc and carbon are plant essential nutrients, it is fine hence they are in thousands. Yeah. So and when it comes to pathogen limits, this is the fecal coliforms. We found a broad variations in terms of fecal coliform. It was varying from thousands to millions. However, it might be because the fecal coliform in itself is not risk. It is not a pathogen. It's a broad spectrum of pathogens, and hence it is just to see whether the particular sludge is contaminated or not. Then again, the coliforms have the E. coli had limited. E. coli is less in thousands. It is within thousands, and helminthes had highly restricted. It was between 0 to 4 numbers, X per gram numbers, because it is a pathogen of concern. And then when it comes to emerging contaminants, you see the frequency is low. The number of parameter frequency is low. And because it is only in the recent times we started adding the parameters of emerging contaminants. And hence this is also maybe due to the lack of extensive risk assessment studies to see how these parameters are affecting my soil and affecting the plants. And hence we recommend some future studies to understand what are the risks of these emerging contaminants on soil and plant. And this is how we have come up with the comprehensive quality criteria. Now currently we only have fertilizer control order giving some parameters which are for using compounds which are made from wet waste and nothing from the human feces. So that's why we categorize the physical parameter relevant to moisture and bulk density, which will affect soil structure and texture, and then the chemical parameters, mainly the major nutrients, secondary macronutrients, micronutrients, which are the essential nutrients for plants, and then the heavy metals and the pathogens and the emerging contaminants. And drawing from all those national and international benchmarks, we have given the concentration level, what should be the limit for application of soil if you want to do it in India. This will be the initial start to actually further develop on the quality parameters. So, I mean, like I was mentioning, the agriculture use is the one which is well regulated compared to different applications, and the focus is mainly on heavy metals, and hence there's a need to further study on the emerging contaminants. And then, yeah, I mean, we also propose to actually understand the traditional heavy metals, how, like, for example, I was mentioning serious loads is actually a risk for heavy metals. But when it comes to peakus load, the focus should be on emerging contaminants. Like how WHO has given multi-barrier approach for using wastewater in agriculture, the same thing we need to have for peakus loads, because for a country like India, we cannot have stringent limits. We should have different levels of interventions to avoid the risk. And then we also recommend to have market development assistance to use of peakus sludge in agriculture, like how you have for organic other compost, and similarly quality criteria for different applications. Yeah, that's it from my side. Thank you so much. Yeah.
Thanks, Girija, for this discussing this topic here, because I think this is very relevant to the sector. If we are looking at nature-based solutions and we don't have any performance criteria, then to scale up, this is a big hurdle that we have to cross. So keeping that in mind, I mean, I would say that we in India especially, we have been working for so many years on nature-based systems, but we still are struggling with standards, and how do we now that fecal sludge has come into the play, how do we define the standards? So I think this is a very good study to initiate the process. But from your study, you have come up with certain recommendations. But do you think that I mean, there's a need for so much more research? So do you think it is realistic to, think of standards in the next 5 years, or it's going to take much longer than that we'll get the standards? And maybe should we come up with guidelines first and then move to standards in a phased manner? What would you think of as a good strategy to ensure that we are still taking care of not polluting the environment through these various systems, but move in a phased manner forward? So what would your strategy be for something like that?
Okay, I mean, that's a very relevant question. Thank you for asking that. So what I would say, that was the very objective of the study. So because like you were mentioning, we cannot invest or we cannot afford so much of time to actually do all those risk assessment studies and all that. So that from there we started. So we wanted to actually first compile what is already available. There are already n number of studies conducted. So first we will compare all that, so that now at least we are ready with the quality criteria that we have phrased. And okay, these are the quality criteria which are actually very specific to application in agriculture. And this is the limit that different organizations and regulatory bodies have already given. So we have this limits, this range is already there. This is the output of the study. So from here we start. This is what the recommendation. So I mean, now at least we know that this is the range that the permission limit should be. What is still needed, and I mean, we have not done your study, but would recommend it for future studies to say whether these permissible limits. I mean, in most of the cases, what I personally feel is like we know, like the coliforms thing, fecal coliform is not a pathogen. There is no risk. What we have seen in our other studies also, we have seen fecal coliforms E. coli in farm and manure also in other organics also. Wet waste also we have seen, but why it is only because it is human feces, there is a concern, there is a blockage of mind. So I mean, for the things we know, we need to create evidences. I mean, science, the research has become like that we have to create evidences and so no, it is safe. Okay, so I think the strategy to answer your question, strategy, we have to start from here. We have the comprehensive list of parameters. From here we start, and then we have to create evidence specific to Indian context. Again, all these are global. I mean, like I was saying, it is all serious sludge quality guidance. We don't have nothing from India and even from the global south side also. So based on that, we may not need so much stringent guidelines, maybe standards for us for global south. Like we have seen, I mean, just to add in COVID, if you've seen, so they said the global south, which are less sanitation, with less sanitation practices were what to say, they're less prone to COVID because our immunity system is different from what the global north is there. So India, specific to Indian context, we need to create evidences to say this is the limit for India. I think I answered your question. Yeah, okay.
No, I'm also trying to get to that, the whole purpose of this research. I think I got that clarification as you answered this question. The entire country evolution that you presented were all guidelines for issued by different countries in different years.
Yes.
Mainly for fecal sludge applications.
Mainly for sewage sludge.
Sewage sludge.
Sewage sludge, yes.
So, how does that compare with other applications? There are other
yes, sir.
non-sewage sludge applications like
non-agricultural applications.
Agricultural applications they would be called what, fertilizer application or?
So there are different applications like they directly do landfill applications. That is one category. And there's one category they say for energy production, but nothing much have been done on energy production. There is a land application, they say. They don't say specifically land application. There's one category.
For agricultural application.
This
See,
is
this serves
specific
the purpose of manure or something, right?
if you want to use fecal sludge for
It's
application in
largely like
agriculture.
manure.
Yes, yeah.
So is there any general rules for manure application for agriculture? General guideline of what all the guidelines the manure you apply should meet, irrespective of what the type of manure it is.
There is nothing general, but then there is specific, like for example, the fertilizer control order gives the guidelines, and that is very specific to the organic compost where the feedstock is wet waste, the yard waste. There is nothing general.
So the guidelines are very specific to the source of
yes,
the fertilizer.
Yes.
So if it is wet waste, there's certain guidelines. If it's sewage, there's another set of guidelines. If it's an inorganic fertilizer, it's another set of guidelines.
Yes.
Have you done a comparison of all these guidelines to see whether finally all of these are serving the same purpose, right? It's going as fertilizer into production of food.
Yes,
right?
yeah.
So if the idea is worry on heavy metals, is heavy metals restricted on all types of input manure?
On all type of input manure, okay. So what we have is.
Or is there a special concern in only sewage sludge?
Okay. So yes, so we have this organic compost regulations, which is from wet waste, and we have this sewage sludge. So if you do the comparisons, in both the cases, heavy metals are monitored. In both the cases, heavy metals.
They're all comparable.
Okay, so our FCO standards are more stringent than the US EPS standards. Actually, the Indian FCO standards comparable.
I'm asking whether the organic compost standards and the sewage sludge standards, are they consistent with each other?
So the organic compost standards which are prescribed in India are more stringent than the sewage sludge standards.
Prescribed in India?
Yes, I mean organic compost standards are more stringent than the sewage sludge standards.
In India?
That is global, sir. We don't have sewage sludge
standards.
So yeah.
So globally, the organic sludge standards in India are more stringent than global sewage
sludge standards. I mean,
that's what you mean.
Yes.
So with all this focus on heavy metals, what does it take to remove heavy metals?
What does it take to remove?
What does it take to remove heavy metals?
What does it take to remove heavy metals? Okay. So if I, like from the fecal sludge perspective, if I have to answer, like there are different methods where we with the first in fecal sludge in our previous studies also we have seen there are no severe heavy metal contamination mostly actually because it is sewage sludge. maybe because of that only, they have actually focused more on heavy metals because it is getting in, contaminated, most of the industrial effluents and all that, and hence the heavy metals are precipitated in this sludge. But this case is not so for here, fecal sludge. That concern is not there. If it is there also, there are methods in composting. I mean, there are specific species of microbes and specific chemicals. Natural geolite is one thing which will actually, there are processes like precipitation, absorption, adsorption using chemicals and microbes, which will actually help in immobilizing the form of the heavy metals. It is mostly, we cannot completely eliminate, but we can actually change the form of the, making it immobile from mobile form. So those processes are still there.
Are there heavy metals in pesticides?
Yes, yes, sir.
Any comparison done on how the pesticide regulation of heavy metals and ultimately we are trying to protect
Correct.
contaminants getting into our food, right?
Yes.
So have you looked for consistency in this between other inputs like pesticides and is there some kind of I'm trying to understand the overall purpose of doing this.
Yes. So comparison between pesticides.
Yeah, the regulations that govern pesticides and the regulations that govern to make sure that the heavy metal that comes in due to pesticides is probably far higher than what comes
Yes,
from.
I also come from the same school of thoughts, but yeah. So yeah, there are no regulations which actually says like, okay, I mean, they say there is a limit in application of concentrations. So you have to apply this concentration level pesticides and all that. That is where our concern is also, like there are no regulations which say, but there are specific pesticides which are actually banned that they should not be used. And again, though, because after some studies which says, okay, those are leading to cancer and other vital organ dysfunction and all that, but there are no specific things which says, okay, you should not apply specific pesticides and all that, yeah.
And broadly, will you say there are two categories? One is the heavy metal concentration, the other is all about coliforms and pathogenic material.
Yes.
Where broadly, they're trying to remove these two things.
Yeah, broadly, and yes.
As far as non-living inorganic stuff
Yes,
is concerned. And pathogens when it comes to organic.
Yes, and the emerging contaminants recently emerging.
Which are also in the range in the category of heavy metals now.
So they are different. They are different, sir. Like so heavy
microplastics.
All this microplastic, the chemicals which are found in cleaning agents. These are the recent concerns, especially in fecal sludge, not in severe sludge, because we are using all these cleaning agent, pharmaceutical products, personal care products. The chemicals from these, I think currently there are studies on this also, are a concern in case of fecal sludge application. Yeah.
Okay.
I mean, just to add one more thing, in our review, like so it is always like that, we are only concerning on heavy metals, like all these regulations also, they are not talking about heavy metals is their concerns, only the risk they are talking, but the benefits, like if I have to apply in, my entire focus is if we have to apply in soil, apply to soil, then there are other things like the physical parameters. What is the pH? What is the bulk density? What should be the electrical conductivity? Those things are not the focus of other guidelines. So what we are also proposing is whenever we say if it is specific to soil application, so look at the parameters which will affect the soil. So those are the things we have actually finalized in our comprehensive quality criteria.
I'm also coming from one, I'll be a last comment, sorry about it. See, ultimately we are all moving towards organic farming, correct?
Yes.
And we are applying farmyard manure, as you said, which is goat manure and cow manure and all of that. They all contain certain level of coliforms and worms and all of that, right?
Yeah.
And we encourage that. And so if law is trying to minimize all some of those things in trying to protect, what's the relevance of this whole thing, right? Is a question mark, right?
That's why we want to, I mean, that's why, like, so this concern is there. It is not a concern, I don't want to say a concern. Coliform is there, E. coli is there, it is there everywhere. It is there in farm and manure, it is there in human faces. But when we talk about human faces, they always say, okay, whether it is meeting WHO guidelines. But we don't ask the same questions to farm and manure.
Did you draw one of those conclusions saying it should not be like this for India?
I
didn't hear it when you said it.
In my other study, that
in
is.
this
Okay, so.
Was that a takeaway?
Takeaway to say that.
Did you highlight a takeaway which said that it is all too stringent, we don't need this for India? Something like that I didn't hear you say. Correct, but is that what you're saying?
That I think here I cannot make the statement in my, because I have to then compare form and manure and other things. So,
Behind the stage, you can make this statement.
no, I'm saying it's with this study that is not enough to make the statement,
Oh.
but I can do it in other study where I have evidences to say that your form and, see, your form and manure also has numbers and your human feces also has numbers, so you.
Why do you keep these two studies separate? Anyway,
Because I
thank
have
you.
not analyzed form and manure here, sir. So,
Okay, I will stop you. Thank you. Okay.
thank you so much, thank you.
Further discussion, detailed discussion. Can I invite the next presenter, Mr. Nikhilesh Kumar?
Hello, am I audible?
Raghav, can you please confirm?
Hello.
Otherwise, we can move on to the next presentation from Meghna, and then we can invite Nikhilesh Kumar.
Can you hear us?
There's another presentation now, second one. Meghna, maybe then we'll just change. The same Meghna, but a different paper. So I'd like to welcome Meghna back again for her second paper, which is titled Evaluating the Effluent Quality from Fecal Sludge Treatment Plants, Performance Assessment Study in India. Sorry, I just missed that. The second one is Evaluating the Phosphorus Removal Efficiency of Different Plant Species in Constructed Wetlands. The gentleman behind, you are being a little too loud. So please, can you please tone it down? And if there's any discussion, I would request if you could go out and finish the discussion. Thank you. Over to you, Meghna. Good luck.
Once again, good morning to all. Okay. Yeah. Now the global focus is on the sustainable wastewater management. So we always approach some nature-based solution for the treatment purpose. And in such treatment like DWATs offer a innovative, cost-effective alternatives for the conventional treatment plants. So the problems which are faced due to this DWATs is like nutrient to meet the nutrient discharge standards. In order to meet the nutrient discharge standards, this system has to be bit enhanced or improvised to meet the nutrient discharge standards. So, as you know, nutrients, phosphorus and nitrogen can't be much effectively removed through anaerobic processes. So, CDD India has conducted a study from the effluent coming out from the DVATs to remove the nutrients from the wastewater. So, this study investigates the effectiveness of vertical filter and wood chip wetland with a vetiver in removing the organic pollutants and nutrients from the DVATs effluent. So this study was done in two phases, which is in one study was like conducting the literature review on the plants which can be used for the this kind of treatment systems, and the other one was the use of alternative filter media. In the first phase, we have identified few plants through a literature review, and the use of plants in the wetlands are like it can uptake the nutrients, it acts as a natural filter, it provides oxygen, it oxygenates the system, and then it breaks down the pollutants, it boosts the microbial activity of the system, and also like everyone likes the aesthetical appearance, it gives that good appearance to the system. And so in order to select these plants, we have to consider a few things which have to be incorporated. So the factors which are affecting the efficiency of these plants are the plant species, especially the plant. When it comes to plant species, the indigenous species are have to be selected, and hydraulic loading rate, how much the load has to be given to the plants, all this has to be considered, and the nutrient flow concentration, how much density of the plants to be provided in a particular system, and forms of nutrients of the wastewater coming in. For the selection of these plants, there are few criteria to be considered. Few are like tolerance of waterlogging, the root structure of the plant, how it can adapt to that system, it would be better if it is the native species, and also climatic stability and nutrient uptake capacity of the plant, and also the aesthetic considerations. So these was the comprehensive literature review which was done for selection of the plants. Vetiver grass, common reeds, Indian shoot, broadleaf cattail, water parsley, tall reed, narrow leaf cattle. These plants were shortlisted based on the literature review, and based on the HRT, type of root and length of the root. We have based on the basically based on HRT, we have considered two plants, which is vetiver grass and Typha latifolia for our study. And we have done a small experiment by putting the plants into the water and then analyzing the water for like 1 week. So after 1 week of study, vetiver has vetiver has reduced the phosphorus content to from 51 milligram per liter to 6.2 milligram per liter, and Typha from 34.2 to again it actually Typha started leaching out. So the phosphorus content from the Typha water was little high. So this was the first phase for the selection of plants, and the next was for the filter media. So the filter media, from the filter media selected was like as I told earlier, vertical filter and a wood chip filter. In the vertical filter, there was a usual conventional material like gravel, sand, and biochar. And in the other one, wood chip wetland, the system was prepared by putting a wood chips into the system and then planting the vetiver plants. Okay, so the results were like this. The system was wood chip filter, vertical filter, and overall efficiency was monitored. When I will discuss the results in the next. And it was also done for different feeding patterns, like feeding it for 10 minutes and resting the system for 15 minutes, 1 hour feeding and 1 hour resting, 45 minutes feeding and 90 minutes resting. And also it was done for different capacities, feeding of 100 liters, 400 liters, 600 liters, and 1000 liters. And so after the stabilization, after the stabilization, the removal efficiency was like 80% for nitrogen and 30% for phosphorus. And we can see the effectiveness of plants in the system there in the graph. Plants had effectiveness on all the parameters, but phosphorus was very low. By all this study, we have arrived to a optimal operation condition, which is of 45 minutes feeding and 90 minutes rest, and average organic loading of 0.22 and average nitrogen loading of 0.07 and average hydraulic loading of 0.47 for vertical filter, and for wood chip filter it is 0.24 for organic loading, nitrogen loading of 0.17 and hydraulic loading of 1.22. These are the final average results of the study which was conducted. So as we are speaking for nutrients, wood chip filter was very effective in removing the nitrogen from the wastewater, but phosphorus it was just 32%. And the plant growth in the system was monitored for 1 month, which was the growth was up to 85 centimeters. And also after the study, the plants were removed from the system, and biomass was analyzed for the PV concentration. It was not there was no much difference in between the control plant and the treated plant samples. Conclusion. So the optimal, as we discussed, as I said, the optimal feeding condition was 45 minutes and 90 minutes rest for the hydraulic loading of 475 liters per day capacity, and dilution factor of 7:30. Vertical and the feeding feeding rate of 3 liter per minute. And the maximum removal efficiency, when we take BOD, COD, everything was very efficient, like 98%, 87%, and 80% of BOD. But phosphorus was comparatively less. Yeah. And it was observed that the stabilization period of 2 to 3 months was required to achieve this efficient capacity. Thank you.
Thanks, Meghna. Was this analysis done just once, or has it been repeated over time to just see if your conclusions or your results, are they still the same, or are they changing with seasons?
No, it was just done once. It was done in the period of 3 months. It was a very small period study.
And so the samples were, how many samples were you analyzed? The same aspects. How many times was repeated? Just once, or was it like at least 30 samples?
No, the 5 number of samples were analyzed to arrive at these results, ma'am. For 1 week, we used to analyze at least 3 to 4 samples for arriving for this.
So, I mean, your paper says it's talking about phosphorus removal. So, in the conclusions, what would you say makes phosphorus removal effective, and through which species?
So plants, according to literature review, we thought of this plant would be better for our study. But once we analyzed it, it has very low phosphorus removing efficiency. Might be we have to try for few other plants.
Sorry, same question, I'm just repeating. Can you state your objective of the study?
Yes, sir. So objective of the study was to find out the plants which were much efficient in removing the phosphorus from the wastewater.
The conclusion was plants are not very effective in removing phosphorus.
Plants are effective, sir, but it again, depending on the condition of the filter media and the wastewater, it is varying. If we see that study which we have done.
Madam, in one line you tell me, what was your conclusion?
So plants are effective in removing the phosphorus, but proper plant according.
That's not what you've written. Go back to the previous slide. Previous. Somewhere you had summarized the role of plant. Okay, if you look at this, for example, nitrogen, phosphorus, there is no difference at all between without plants and with plants.
There is very less efficient.
Correct.
Yeah.
In fact, one of them is showing without plants is better.
That, but for total phosphorus, it is with plants, it is better than.
Whatever. I mean, can't even make out the difference, kind of thing. And that's what you've written somewhere. Saw that
Yeah.
line?
Yes, sir. Yes.
Can you show that line where your conclusions line? Up to, here. Plants played minimum role.
Yeah.
So why are you hesitating to state it when I ask you?
No, sir. But this plant, when it this doesn't depend only on the plants, is what I was trying to tell.
No. So the objective of the study is to find out which plant.
Yes, sir.
And the conclusion is plants are generally not very critical.
It has very minimal role.
That's what. So state it.
Yeah.
Because you are hesitating to state that. I don't know why. Okay. Because if that's what came out of your study, then let's accept that, no? Because you're saying, no, that's not what you're saying. Plans have a role to play, but it also depends on the
But-
media. Why do you want to elaborate that? Okay, so you found that the media actually plays a greater role. You got good removal overall.
Yes, sir.
Correct?
Yeah.
And possibly it's because of the rest of the setup, not so much the plants.
Yes, sir.
So I think that leads to Sushmita's question. In the rest of the setup, what actually was the most effective component according to you that helped remove phosphorus? Because the overall levels came down. In that you showed that it significantly removed both nitrogen and phosphorus.
Yeah.
So what, according to you, played a big role in removing the nitrogen and phosphorus?
The wood chip filter played a main important role in removing,
Okay. The wood chip is a horizontal or vertical?
or vertical filters. Not
Wood chip
horizontal.
was a vertical.
Yes.
Are you sure?
Yes, sir.
Can you go back to your drawing? Hold on. Okay, both are vertical. Okay.
Yes, sir.
There is no horizontal. All right. What's the depth of the wood chip filter?
Actually,
Gravel, freeboard, gravel, okay. Did you get a breakup between that, what did you call the first one, the vertical filter and the wood
Yes.
chip filter, where the removal happened?
wood chip was higher, sir, when
Where is the
vertical.
wood chip? This one?
This is middle one is chip.
PP. Can't make out what's showing. Okay, not clear what it is showing, these graphs. Removal efficiency, okay,
Removal
percent. It's only 30%.
Yes, sir.
And this is actually 35-40. Correct?
Yes, sir.
So even the vertical filter is effective, no?
Both are effective, sir. But when it comes to nitrogen, wood chip filter has very good efficiency.
Nitrogen.
Yes.
That I can see, yes. Since the focus is on phosphorus,
Yes.
your presentation focuses on phosphorus.
Phosphorus.
I was looking at that number. Okay. The phosphorus, this seems more effective. Huh?
Yes, sir.
Okay. Fine. All right. Thank you.
Thank you.
Thank you, Meghna. So apparently Mr. Nikhilesh Kumar had some personal emergency and that's why he could not make it. But we have his co-author, Mr. Pradeep Yella, on the call, and he'll present it online. Mr. Yella, I would request you to time yourself for 7 minutes for presenting so that we have
Sure.
some time for discussion and question and answers. Thank you.
Sure, thank you. Can you hear me?
Many
Can you please confirm? Hello, can you please confirm you can hear me? Hello? Can you hear me, please? Can you hear me?
We can't hear you, Mr. Yella. You might need to check your audio system.
Amrita, can you check, please? Amrita?
Sir, I can hear you. Even I can hear you.
Yeah,
Yes, I can hear you. I think
I hope some issue with
No, I'm afraid you're not audible. Can you just
others
check
can
your
hear.
audio system, your speaker system from your end?
Others can hear. Amrita, can you call her, please?
Darshan, any issues from our end?
yes, I'm calling you.
Should we give it some time and take a break and come back? Would you be okay with that, Mr. Yella? We'll take a 15 minutes break because we are due for a coffee break.
Yeah.
Oh, sorry, great. Sorry about that. Coffee break will need to wait for another 15 minutes.
Okay. So can you hear us?
Now you're audible, loud and clear.
Thank you. Let me share my screen. I hope my screen is visible.
Yes, it's visible. You can go on.
Yeah. Sorry about Nikhilesh not able to present here. My name is Pradeep Pyalla. I head the water delivery vertical here in Vasar Labs. So in today's presentation, I would like to cover about digital solutions which we have built for climate resilient water security platforms, which were like established and deployed at a large scale, be it at a country level, state level, so on and so forth, or a river basin level. So I'll just give a brief introduction about who we are. So again, we are from Vasa Labs, an MIT alumnus funded company. Primarily, we deploy solutions with the use of AI, remote sensing, climate to address critical problems in the sectors of water, energy, disaster, agriculture, and smart cities. So over the last 10 years, we have built integrated digital water management system for city water distribution for around 8 cities, irrigation project monitoring systems, digital twins, so on and so forth, and deployed solutions at 6 country level project systems, 17 state and river basin level systems, and more than 40 like Fortune 500 clients. We were working on the solutions for water,
You
agri,
keep
and
your 7 minutes limit, please remember, just
yeah,
focus
yeah,
on the.
yes, yes, yes. So all
Yeah,
our solutions are built
talk
on a
about the objectives and conclusions, please,
sure,
quickly.
sure, sure. Then let me come to the case study which I was talking about. One of the state implementation, Andhra Pradesh Water Resource Information and Management System. So what we have done, this particular system was launched in the year 2017. So what we have done, we have, if you look at any water related information, information is available with various stakeholding departments in silos. So what we have done is we have brought all the information together into a one unified platform called Andhra Pradesh Water Resource Information Management System, which brings data related to weather stations, reservoirs, groundwater observation wells, piezometers, around 38,000 mine irrigation water bodies we are tracking using satellite data, 600 plus soil moisture sensors. All this information were integrated on a real-time mode to bring a visibility of what is the amount of water available across the state on a real-time basis at any given point of time. So how we have achieved this, we have integrated satellite data, sensors, drone, mobile application, various predictive and experimental data together to build this platform. So anybody can access this platform just hitting on AP Volumes in Google, and you'll be able to access. It's a open data public portal. The main objectives of the system is to bring one authoritative water related information across the state, and also to bring comprehensive visibility for about 90% of water resources data across the state. It helps in water planning and water management, be it a flood management, drought prediction, or water use efficiency tracking. This platform is giving advisories to government officials on a real-time basis. It is open portal. It has access to research institutions, general public, so that stakeholders can contribute onto the platform, and also they can take advisories back, and also helping in various decision making processes. So couple of modules which we have deployed under this platform is village level water budgeting. In case of Andhra Pradesh, we have around 17,334 villages. Across these 17,334 villages, since we have built all the information together, be it the rainfall, soil moisture, land use, land cover, cropping pattern in the system, we are running a village level water budgeting to understand what are the supply side and demand side water availability or water demand we have on a particular village, and we are assessing whether that particular village is in surplus category or deficit category. And if the village is on the surplus category, so and but it has some demand to be met, we are giving them on the supply side interventions on how to improve the recharge, how to like capture more water, more excess runoff within the village itself. And if the village is in the deficit category and it doesn't have any excess water available, system is also guiding the users in terms of what kind of demand interventions they need to do, like how to optimize crop, how to prioritize water allocation across different needs across agriculture, domestic livestock and industry, so on and so forth. So this particular model has been deployed for all 17,334 villages in the state. Then the other thing, one of the other module is on interbasin transfer. You might have heard there is an interlinking system between River Godavari and River Krishna, but there is a need to decision support in terms of when to lift water from River Godavari to bring it to River Krishna, and it also need to look at what is the inflow forecast, what is the catchment site analysis within Krishna River basin. So understand what is the right time, what quantity of water to be lifted. So we have built a decision support system to optimize this interbasin lift scheme to give a lead time of 4 to 48 hours for safer dam operations. It has also brought in on an annual basis 10% savings in pumping cost. If you look at 10%, it is almost equivalent to 25 to 30 crore rupees in terms of power saving. And this particular system is also helping in stabilizing 1.3 million acres of irrigation command area under Prakasam Krishna Delta system in Andhra Pradesh. So this is one of the decision support tool which was deployed in Andhra Pradesh Water Resource Information Management System, and this is completely automated and runs on a real-time basis every day. Then we have one more module deployed called water conservation planning. What it does is it will system will predict, will look into in a particular watershed, what is the slope, land use, land cover, soil texture, geology, geomorphology, and it automates various rules of which water conservation structures we need to build, what are the right location, what are the various rules to build. It looks into all the weightages and gives a master plan at village levels. In my previous slide, I
Should
spoke
close
about
in 2 minutes.
water budgeting. In the
Close in
current
1 minute.
slide, sorry.
Please close in 1 minute.
Yeah. So again, we have irrigation management as a portal as well. So across last 7 years, system is operational, and if you look at the benefits it has given is around 17,000 village level water budgeting plans were given. 970 megawatt of energy was saved using the system, and 1.4 million water conservation structures are planned, and scientific planning based conservation activities are happening, and 7 lakh acres of irrigation command area is being stabilized by the system, and it has also improved 23% increase in the crop yield in the state by using the system. And again, it's an operational system functioning from last 7 years, and this system is leading the way forward in terms of 7 other states have also started their journey in building water resource information and management systems. Yeah. That's it. And again, on the way forward, now the system is also working on 2.0 with the vision of 2047 to bring water security, and it also looking at climate change aspects, micro irrigation aspects, and also dam health analysis are also coming forward with the vision 2047 for this system. Thank you.
Thank you, Mr. Pradeep. Question.
So as this presentation was under the heading of nature-based solutions, so I wanted to ask you that how is this tool specifically addressing nature-based solutions?
So one of the solution is on the flood site management, right, for interbasin transfer. It is looking into the aspects of weather as a phenomenon, and also to improve to manage flood risk during monsoon or extreme climate scenarios, helping them to manage water resources better, and also to mitigate the effect of flooding is one of the important aspect. And also, when you look at your conservation planning and other aspects, it is also helping you in terms of better crop coverage and other aspects. Did that answer your question?
This is in partnership with the AP government, that this is under, you have some MOU or something, right?
Yes, yes. This is under partnership with AP government. Last 9 years, we are associated with government of AP, not just government of AP. We are now associated with government of Telangana, Odisha, Tamil Nadu, River Control Authority of Narmada, and we are working for government of Saudi and Africa as well. Similar solutions with
And
their own
Wasser
objectives.
Labs is a for-profit company? Wasser
Yes,
Lab, the
yes,
for-profit.
yes, yes,
Okay, so the government is paying you for all this information system.
yes. Government is paying us. Yeah.
All right, thank you.
Any further questions of the jury? Okay, thank you so much, Mr. Yella.
Thank you.
And now we can have a brief coffee break and let us please reconvene in the next 15 minutes. Thank you. Coffee is being served outside the auditorium.
Hello? Hello? Am I audible? Hello? 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 Am I audible? I'm trying, ma'am. Okay, okay, thanks. Purika? Hello? Am I audible now? Okay, okay. It's clear? Okay, thanks. Okay, okay. ഇത് ആദ്യം ചോദിക്കണേ
So I request our next presenter, Mr. Baira Reddy HV, engineer intern from CDD India, to make his presentation. His topic is enhancing the quality of fecal sludge based inputs through nature based solutions for sustainable agriculture. Good luck.
Myself, Baira Reddy from India. So let us start. So everyone is speaking about FSTP treatment of FS, but what next? You have treated your FS, you are using your effluent in for the landscaping for such other agriculture purposes. What about the fecal sludge which is coming out of it? The sludge has higher pathogen content from previous studies. So we will go further. So in today's condition, agricultural decline is happening in due to various different factors. In earlier stages, in say my grandfather was doing agriculture, might be loss of crop would be due to flooding, either drought or pesticides attack. But today, all with along that, one more thing was chemical fertilizer. Excessive use of chemical fertilizers will lead to agricultural decline. And if there is a problem, there might be a solution. Solution will be a nature-based approach. That nature-based approach is treating FS was one thing. After FS, sludge is coming out. Sludge can be reused as a compost in the agriculture field, so that your compost quality increases using the FS, and also your plant growth will also increase. That will be you'll come to know in the next slides. So, and yeah. PROM, phosphate-rich organic manure. This will be the main objective of this study, focusing PROM. And there is a depletion of phosphorus. There is a study saying by the year of 2095, phosphorus will be an extinct thing because it's a non-renewable resource. So again, without phosphorus, nutrient balance is improper. From a study, you can see the end part, availability of phosphorus. It says 20% of phosphorus is in the human excreta. So keeping that as a point, we have started our study. This is the study area. We have conducted our study in Devanali FSTP. Our main objective was to enhance the fecal sludge compost using different substrates, and also to analyze the final quality and safety of that compost. So this is the methodology. First, we have set up 4 treatments. One was initially just fecal sludge. We have to check initial input of fecal sludge, whether it is safe to directly use in agriculture, or we have to add on some substrates to increase its strength and to make it as a better fertilizer. And second was municipal solid waste. This acts a major role in our project. Third one was co-composting. We have just added that FS and municipal solid waste. And fourth one was, as I said, PROM, enriching FS with different substrates. Next, we have collected the sample collection from market waste. Municipal wet waste was collected from market, and FS from Devanali FSTP. And laboratory analysis are done for 4 different parameters. One is physiochemical, nutrient content, heavy metals, and pathogen content. We have analyzed these with FCO standards and EPA guidelines. So this is the treatment technology. Initially, if you see this photo, the sludge is directly taken from the sludge drying beds, from the GHST beds, and directly analyzed in the laboratory. Second is co-composting of FS, second is municipal wet waste alone. We have done this in a bin composters. Just to scale it up, we have done in a bin composter, not in a windrow composting. Co-composting is done as windrow composting, and production of phosphate-rich organic manure includes, as I said, different other substances was initially dried fecal sludge, municipal solid waste, rock phosphate we have used, and poultry manure, also phosphate solubilizing microbe. Because as we are adding rock phosphate as a direct input, that should be solubilized, or else again it will affect the plant growth. For the reason we have used the phosphate solubilizing microbe, Trichoderma viridae, and I have given the ratio as 1:2:1:2 kgs of rock phosphate and 25 grams of phosphate solubilizing microbe. There might be a question why the ratio. This was arrived from the literature review. It's not my own opinion. These were the results and discussions once the composting is done in 4 different technologies. So this was the input characteristics. As I said, we have used FS, poultry manure, and municipal wet waste, all the, if I say, just as FS is a higher pH, have to balance the pH. What will I do? Is a question. We went for co-composting. I'll show the results of the output next. You'll get to know the output results. Then MSW has high organic carbon. And when it comes to nutrient content, FS has highest phosphorus. High phosphorus also might sometimes lead to crop yield decrease and also soil acidification few times. And also there was high heavy metal and pathogen contamination. Pathogen contamination was in fecal sludge. This was a treatment, final output of 4 different treatments. We have compared with FCO. All the different parameters was analyzed with FCO and helminthics, and all the pathogens were analyzed with EPA results. When it comes to treatment, one was direct FS application, as I said in the input characteristic. Treatment 2 was 60-day compost of municipal wet waste. Treatment 3 was composting of fecal sludge with municipal wet waste for 60 days using vidro composting, and treatment 4 was PROM, phosphate-rich organic manure, with different substrate, as I stated earlier. So when you compare all these 4 treatments, the better results and the balanced nutrient was shown in the phosphate PROM, and also heavy metal contamination was very low in PROM, and pathogens were well below the EPA limits. These were the graphs of the same results. So to summarize and to conclude, we have, as I said, we have analyzed 4 different technologies. PROM improved the CS2N ratio because, as I said, total organic carbon was very high in municipal wet waste, and also adding microbial decomposition. FS contributed high phosphorus content and organic carbon, while poultry manure showed all balanced nutrient content and also minimizing the heavy metal concentration. So when I compare all these 4 treatments, PROM was the superior, outperforming all the 3. It was the best suitable compost for agriculture, was my conclusion. And I would thank GIZ team and Town Municipality Office of Devanahalli for helping us in this study. That's it. Thank you.
Thank you for your presentation. So it's good to see the results, but I would like to understand how many samples did you analyze?
It's an ongoing project. So we have done 1 phase of study. We are yet to do other phases. That was just for 1 phase analysis. We have analyzed one compost, like for treatment 1, we have analyzed for 1 phase, 2 or for 1, all of 1.
So you've taken samples 1 time,
yes,
and
1 time.
analyzed.
Yeah.
Have you done like literature review or looked at similar studies that have been done by various organizations since fecal sludge management started in, say, 2015 onwards?
Yes, ma'am. We have analyzed, we have done literature review before starting this project, but many studies focused on just composting fecal sludge with municipal wet waste, neither adding nor without adding any other substrates. Just they are adding the municipal wet waste with fecal sludge. But studies have done for the phosphate-rich organic manure, but not focusing on the fecal sludge. This was our gap. So we thought, as human excrete has 28% of phosphorus content in that, why to go with other, like they have done analysis, per my knowledge, they have done for rice husk, wet waste again, but not for the fecal sludge. This was a new technology, new thing, what I can say.
So even at CDD, we have not studied this before.
PROM was not studied.
PROM was not studied.
Co-composting was done. Just to compare with PROM, co-composting was also included in this study.
Okay. Again, comparing it to the FCO and EPA, this seems to be working well, but
yes.
Do you think that it is a cost-effective solution?
Yeah, co-composting is done in a windrow, while this PROM was done in a bin composting. I can say it can be directly installed in the household level, so that you need not go to your place, say for my FSTP to do the composting. This was ideally done in a 200-liter bin. I don't have pictures again. I would have shown the pictures. That was done in a oil container bins. If you seen, we have done in that, and the results were amazing in that. If you can scale up, if that is working, I guess it will be scale up in a higher ratio.
Yeah, you're adding, you said some 2 kg of what is that?
Rock phosphate.
Rock phosphate with some bacteria, 25
Yeah,
grams.
25 grams of trichoderma viridae.
What is this? This is in how many kgs of fecal
20.
manure? Fecal and co-composted manure.
Yes.
To that you're adding 2 kg.
Yes.
In how many kgs of?
200 kgs of total compost.
Okay.
Say if I say 50 kgs of fecal sludge I have taken, 100 kgs of municipal solid waste, and 50 kgs of poultry manure, 2 kgs of rock phosphate, and just 25 grams of PSM.
Mixed poultry manure also.
Yes, to increase the nitrogen content.
Right, and when you said fecal sludge itself has some 2.3.
2 point, yeah.
What is it? How do
Phosphorus.
grams per? What is it?
Milligrams.
Milligrams per?
Sorry, it's a percentage.
2.3%.
Yeah.
And you said that itself is high.
Yeah, FS was high.
So why do you want to enrich it further with?
See, FS is having higher phosphorus content, but it has also higher pathogen content. After reduce the pathogen content and also have the same balanced ratio of nutrient content.
So how is the pathogen content coming down through what process?
By co-composting.
Correct. So why do you want to add that 2 kg of rock phosphate? That's my question.
To increase again, phosphorus content will reduce. I'll show you one more recent thing. In co-composting, we didn't have rock phosphate, but co-composting has lesser phosphorus content when compared to PROM.
I know, but you said whatever is there in fecal sludge alone is more than required.
Yes, while co-composting, it decreases gradually because of combining with municipal solid waste. Ratio decreases.
But you didn't give that number, I think. Can you show those numbers? This one. The T3 is your co-composting, right? It gives you 2. 2 is good, I thought.
Yes.
So why do you need to add rock phosphate? Why do you need to go to T4? T3 is also good.
T3 is also good, and T4 has 0.58% higher than T3. But this is a first scale study. We are also analyzing for future. We have to check again. There might be an increase, also decrease. I can't directly say there will be an increase.
No, but it's too good.
It is higher than the T3. I can say it's too good. Matlab, there's a
two, when I say is the number too good, it's not TWO too good.
Yeah, it's good.
So
it is.
You really need to take 2 to 2.5 is the question.
It has to be increased some more because it is going to extend in future days. There is a FCO PROM guidelines. In PROM guidelines, it says PROM guidelines says it should be of 10%. But it's not reaching 10%. We are
10% out of, so 200 should become 20.
Not,
you take
not
200 kg of manure, it should contain 2% is 2, right? 2 kg, okay.
2.
So you said how many percent? You said 10%.
Yes.
10% will be 20 now of 200 kg.
Yeah.
This 2 should go to 20?
Not 20.
So this 2%.
2%.
Should go to 10%. Or desirable phosphorus is 10%.
If your PROM says should be of 10%, because in 2095, as I said.
So when you add inorganic fertilizers, typically what's aimed to take it to what percent in the soil? Okay. Okay, you're saying this 2 is not good enough.
I'm not saying it's good enough. I can say it can be improved better.
Okay. Okay.
Because it can be directly used.
So again, the question is, with the current fertilizers which are available, how does it compare cost-wise to, use the fertilizer from PROM and the one like urea, which farmers usually use?
Yes.
So because that's really cheap and subsidized. So why would they want to go to PROM? Is it comparable, the cost, or is it not?
I'm not that financial background person, so I'll get
from a scalability perspective, that is something that we need to consider.
Yes, yes.
Because if it is too expensive PROM, then nobody would want to use that.
No, in present in Devanandi, they are selling compost for a low price around 5 rupees to 7 rupees per kg. If I make it 10 rupees per kg, also it will be a good, when I compare my input cost and my output revenue, it would be better, I guess. Because I missed one point to say. Co-composting has 21%, 50% reduction of the input weight, but prom is just very less. Like if I input of 200 kgs, I'll get almost 150 kgs of compost. So in that way, again, I can generate my revenue.
I guess including that aspect in your study will, include the scalability possibilities, the cost component. And as you rightly said, the quantity of compost produced.
Yeah.
So I think if you include that, that would really improve the quality of study.
Yes, ma'am, I'll take this point. Thank you. Any more questions? Thank you.
Thank you, Vinay, for the presentation. Sorry, thank you, Baira, for the presentation. I'm so sorry. So I'll invite the next presenter, Vinay P, who's also an engineer intern with CDD India, and he'll be presenting on best management practices for fecal sludge application in agriculture.
Hello, good afternoon, everyone. My name is Vinay. Today I'm going to make a presentation on this best management practice for fecal sludge to use in agriculture. Let's begin. Okay, we know that fecal sludge management is an essential for environmental and our public health also. So let's focus on our current scenario in agriculture. We are now soil degradation is due to nutrient loss. As per the study says, the rate of soil loss in India is around 16 hectares per year, 16 ton per hectare per year. This is because of mainly over dependent on the chemical fertilizer and overuse of that chemical fertilizer. And now here with this solution as a fecal sludge, we can use the fecal sludge as the solution for this issue because the fecal sludge is rich in nutrients such as nitrogen, phosphorus, and potassium. So this will help to close the nutrient loop through the agricultural use. And also the fecal sludge, as you know, we have a risk of using the raw FS directly to the agricultural feed. So it has some pathogen contamination and heavy metals accumulation in it within the soil. And we know nowadays emerging contaminants, which is pharmaceutical and personal care products, which will also cause acts as a contamination in agricultural. So for that, we need a management practices to tackle these issues. So today we'll focus on this management practices to tackle those issues. These are some pictures. So this is the methodology which we adopted in our study. So first we reviewed all the literature reviews which are focusing on the fecal sludge, and we review some of the guidelines from FAO, WHO, and IMMI. So from this review, we found out the research gap, as we can see. So this research gap is the possible risk of how fecal sludge application. What is the possible risk of it is? And the most of the reviews were confirmed to treatment technologies, and there is some limited knowledge on the best management practices, like what are the practices which we can easily adopt in our field, and there is some need for those management measures. And as we know, first management measure is like from treatment. So these are the existing treatment technologies which we already have. And these are some nature-based treatment technologies. We have PDBs and UPDBs, and for thermal treatment we have pyrolysis, and in mechanical treatment we have screw press. And for further treat that sludge, we have solar drying beds, vermicomposting units, and co-composting process to treat that sludge in further in better way. And another management practice is like adopting suitable crops like industrial crop and fruits and perennial crops, which will these crops, especially this crop, will not directly get into contact in fecal sludge because these crops will as industrial crops we directly will not consume these crops, and fruit trees this will grow above the field, so it will not get directly contact with the fecal sludge. So the management practices like application methods. So as per the IWMI guidelines, we have to add like 5 to 25 metric tons per hectare. So, and also we have the time of application. It should be within the 3 months of application of harvesting for turf, like grass crops. And safety measures. We have safety measures for consumers and farmers. For consumers, we have to peel the wrapper of the vegetable and all. We need to wash the vegetable or fruits before we consuming it. And for farmers, while applying in the field, we need to wear the safety mask and gloves for handling the AFS. And some of the recommendations are, as we know, nature-based treatment systems and crop planning exercise based on soil characteristics and application methods as same, and the application timings when we are going to apply this AFS directly into the field. And some future, this is the look forward, like future work needs to be done, FS quality guidelines, some for with respect to Indian guidelines. And yes. Thanks.
Thank you, William. The next presenter would be Mr. Samrat Gupta from Water for People India. And he'll be presenting on circular economy for sustainable fecal sludge management in rural India.
Hello.
Okay, we have someone from.
So this is Jhilam, and me and my colleague Alok Srivastav, we will be presenting on behalf of Water for People India. So
Sure.
shall we share the PPT here?
Yes, you can share the screen.
Okay, just how to share the screen first, no?
His co-authors are presenting. Can you please repeat your name? I just didn't catch that.
Yeah, this is Jhilam Sarkar, and I'll be presenting along with Alok Srivastava.
Okay. Go on, Jeevan, but please ensure you maintain a time limit of 7 minutes for your presentation.
Yeah. Hello, everyone. This is Jhilam Sarkar, and along with Alok Srivastav, I'll be presenting about a case study of Water for People India's FSM initiatives on circular economy for sustainable fecal sludge management in rural India. So, as we know that fecal sludge management in rural India faces critical challenges like the high cost, large capacity FSTPs are often unsustainable because of the inconsistent and insufficient procurement of fecal sludge, which leads to underutilization of the facilities. And because without a steady supply, the plants struggle to operate properly, and which leads them to financially and operationally unsustainable, leads them to be financially and operationally unsustainable. Along with that, lack of skilled personnel and proper infrastructure also adds up to it. And lack of awareness and market acceptance also fails to generate the demand for the right products from the treated sludge. And also, there is no compulsion by the authorities for safe disposal and of the fecal sludge, which leads to unsafe disposal. So, WFP India is focusing on developing a financially viable, low cost, low capacity FSTP model tailored for the rural areas, which would help us to overcome the financially unsustainable FSTPs to deal with this thing. Now, our aim here is to reduce the public funding by engaging the private sector, the local government, and the communities. We believe that we can proceed excuse me, we believe that we can proceed with our circular economy approach to produce fecal sludge byproducts and generate a market demand for them through the local farmers, the FPOs, and the SHGs. The operation of such low-cost FSTPs will lead to fecal sludge management solutions both sustainable and ideally profitable. To make this hypothesis a reality, Water for People India has built two low-cost and low-capacity FSTPs, one in West Bengal, which is operated and maintained by the local Gram Panchayat, and the other one in Muzaffarpur, Bihar, which is operated by a local entrepreneur, making it the first private entrepreneur-led modular FSTP in the country. Now, we are basically following the Tiger biofilter method for our facilities. This approach seeks to address the gaps in the sanitation value chain by actively involving the informal sanitation workers, the pit emptiers, and the community members, by educating them, by training them, by developing their skills on sanitation practices, and generating awareness about the FSM processes and the benefits of the byproducts that we receive from these FSTPs. Along with that, we have also inculcated a reverse tipping fee mechanism, which incentivizes the pit emptiers to directly transport the raw fecal sludge to the facilities instead of restoring it informally, restoring the informal dumping procedure. And also, the basic thing is we are trying to transform the fecal sludge in our facility into nutrient-rich compost, solid compost, which we are calling Sona Khad, and a liquid soil enhancer, which we are calling Sona Taral. And we are trying to develop the market strategy through these FPOs, through the SHGs, through the local communities, by creating the demand and trying to sell the products by inculcating some methods and trying to overcome the socio-cultural barriers. Now I would like to request Alok to explain the methodology.
So the process we are following for treatment of fecal sludge begins with the screening of raw sludge we are receiving at our facilities. After that, after screening process, the treated sludge is transferred to the anaerobic digestion chambers, where the anaerobic digestion occurs. Further, the anaerobically digested sludge is transferred to TBF bed, that is Tiger biofiltration bed, where microbes and earthworm further decomposes it to produce nutrient-rich Sona Khad and Sona Taral. The Sona Khad is solid organic soil enhancer and Sona Taral is liquid organic soil enhancers. We have also tested the raw sewage, treated sewage, and the vermicompost at different phases, and we have found that the parameters are indicating towards a positive movement while testing. Like we have got a significant differences of COD and BOD levels in raw sewage and treated sewage, which confirms that this can be utilized for further vermicomposting and it will not affect the health of worms we are utilizing in the process. The vermicompost produced here is also rich in nutrients and is a chemical-free product, which has a potential to enhance the soil's health by improving its microbial count and microbial growth in long terms. It is making it eco-friendly and better alternative than a synthetic fertilizers. If we see about the financial stability, since we are in a pilot phase and in beginning, we have till now produced around 500 kgs of Sona Khad and around 170 liters of liquid soil enhancer, which is Sona Taral. And we have distributed and also sold it in our initial phase. We have distributed it for trial purposes to local farmers and HSG groups. And after that, we have
Please close in next 2 minutes. Thank you.
Yeah, sure.
Okay. And we have already generated a revenue of around 8,000, and we have an anticipation that if we keep on if our facility works for 200 days a year, even, then we can also produce around 69 tons of Sona Khad, which is solid soil enhancer, and around 1,40,000 liter of Sona Taral, which is the liquid soil enhancer. And and by selling these products, we can generate a revenue which will be sufficient enough to cover our operation and maintenance cost, and thus reducing the external fundings. For our support, we have just incorporated a small video for the evidence.
Can you conclude that, please, because the audio is also not very clear.
So here we interviewed a farmer. So here our team has interviewed a farmer by supplying them the products for trial purposes, and we have also get a demand for more products. So by this we can say that the demand is going to increase in future, and it will support our initiative.
So coming to the conclusion, our key interventions include the reverse tipping fee mechanism that we talked about, the market development strategies we are following by incorporating the FPOs, by incorporating the local farmers, and also the SHGs. We are trying to build up public-private partnerships through the local entrepreneurs and the local government. We are trying to establish a climate resilient and sustainable approach. And if we see to the scalability, once this is successful, it will be replicable in other rural and semi-urban areas as well. And we can thus have a financially sustainable market linkages. So further studies can be done based on that. That's all from our side. Thank you so much.
Team Water for People, over to the jury.
For how long has how long have these two units been functioning?
One has been functioning for 1 year, and the other one has just started, it has just been started with the trial phase.
And again, so how does it compare to the cost of producing the Sona Khad and Sona, whatever it's called? Sorry. How does it compare to the fertilizers available in the market?
Like we have the fertilizers available in market, already it is discussed by our friends that the chemical fertilizers are subsidized and easily available, but our main intervention is to educate the farmers and make them realize that their product based on the organic manures will be of more value, and they can we are also helping them to market it as the organically grown products. And the part which which I think you are concerned about is our raw material is the fecal sludge, which ultimately the households have to empty.
We don't have a cost.
So we don't have a costing on that. We are just investing in the reverse tipping fee to the pit emptiers, and we are maintaining a continuous flow of incoming fecal sludge.
So for the plant that has been working for 1 year, how cost effective has the entire performance of the system along with the sale of the products? How does it compare?
So the one working for the past 1 year has been very efficient because like we told that we have already sold around 8,000 rupees of product, which and this is enough, first of all, for the maintenance and operational purpose of the plant, and also the local entrepreneurs are taking care of the operations, so there is no other extra cost on that. So we have been able to maintain the facility properly without much of thinking of much of investments on that part.
Sorry, so this private sector run thing has been operating for 1 year.
Yes.
And what is it? We have sold 8,000 rupees worth of something, you said.
Yes, we have sold the byproducts worth 8,000 that we have generated through the plant.
Only 8,000 rupees.
Yeah. Till now, we have sold of around 8,000 rupees. So
in whatever 6 months, 1 year.
Yeah, last 6 months, because it took some time to brand and market the product, and we have also supplied some free samples to the people we have engaged with.
So can you tell what is your price of these two products you're selling? One is
Like for Sona Khad, we are trying to sell it for 12 rupees per kg, and for this Sona Taral, we are selling it for 10 rupees per liter if they are in small packaging. And further, we have planned to reduce our rate by 1 or 2 rupees if they are buying in for bulk, like 5 kg, 10 kg, or 20 kg
at
bags.
this price based on your cost of. So this reverse tipping fee is people who bring fecal sludge to your
Yes.
to the site will get paid some money.
Yes.
Yes.
How much are you paying as tipping fee? As
Pardon, sir?
reverse. How much are you paying as reverse tipping fee?
Like it depends on the pit emptiers who are bringing the sludge. If they are bringing it from nearby area, then we can offer them 100 to 200 rupees or something. Or if they are coming from very much far area, lot like area, it is 5 to 10 kilometers. If they are coming from, we are giving them 100 to 200 rupees, because they are also getting the emptying fee from the households now.
So what's the highest you're paying?
Highest we have paid around 300
300
for
rupees.
around 15 kilometers.
300 rupees per
Sorry, sir.
per truckload per KL. What is it? 300 rupees
Per truck.
per truckload.
Yes, per vehicle we are paying it. The vehicle contains around 3,000 to 2,500 liters.
Okay. So 100 rupees per KL approximately.
You can say.
Okay. And using Tiger biofilter technology, you said.
Yes.
So with these prices, 12 rupees and 10 rupees, and a tipping fee of 100 rupees per KL, you've done your economic analysis.
Sir, we are still in pilot phase, so we have.
Research studies are going on right now.
Actually, we are providing.
I'm asking whether you've done your economic analysis, saying if, let's say, what's the capacity of this plant?
2 KLD.
2 KL. So full 2 KL load comes per day, then what kind of, whether you will earn money, have you estimated that? Is all I'm asking.
So yes, we will be earning
At
money.
12 rupees per kg of output, solid, and 10 rupees per kg for the liquid, and 10 rupees per liter of liquid, and paying 100 rupees per KL for the sludge that you buy, and given the cost of operating a Tiger biofilter technology, have you done your feasibility study to say this will result in profits for the private sector guy?
Yes, it will surely reserve the profit.
Sorry?
Yes, it will reserve the profit.
Okay. Including the capital investment or without including the capital investment?
No, including the capital investment.
And it'll pay back in how many years?
Around 12 years.
12 years.
Yes.
Okay. And this private sector guy who's come on board is aware of all these economics.
Yes, he is aware.
What
Yes,
of
actually, he has
you
only,
subscribe?
sir, actually, he has only provided his land for the making facility.
The development.
And who's operating? What of people?
Yeah, Water for People is monitoring it. He is he is in charge of the operation and maintenance over there. We are
He's
supervising and
not only
monitoring.
just provided the land, he's also operating and maintaining.
Yes.
Fine. All right. Thank you.
Thank you so much.
Thank you, team, for your presentation. So I'd like to now invite our next presenter, Mr. Migashem, who is a student in Indian Institute of Engineering, Science and Technology, Shibpur. He'll be presenting on implementation of nature-based solutions to mitigate the effect of urbanization on blue infrastructure, a case study of Chennai. Good luck, Migashem.
Hi. Good afternoon, everyone. Myself, Mikash. I'm an architect and an urban planning student. My topic is about implementation of nature-based solutions to mitigate the effects of urbanization on blue infrastructure, a case of Chennai. There are some terms in my research topic itself. The effects of urbanization. What are the effects of urbanization? What is a blue infrastructure, which I'm going to talk about? And what is the nature-based solution, which I'm going to get implemented? Yes, this is the major context. I'm going to go through it. Introduction, we are going to see an aim and objective and methodologies, study area, which I've delineated it, and the framework and analysis which I have done, and the conclusion part, how the nature-based solution can be implemented and it can be approached further. Yes, what is the need of the study? Why the nature-based solution should be implemented for the effects of urbanization, which I'm speaking of? As we can see from the data sets, in 1893, Chennai has nearly 60 water bodies and with an area of around 12.6 square kilometers. Now, in 2017, around 8 years back, it has been reduced to 28 water bodies, and the water body has been decreased to the size of 3.2 square kilometers, which has already lost 75% of water bodies. We have lot more problems to cater of. We have the increasing population which is coming in, and we have to give the water supply to them. How we are going to cater these things exactly? I'm just a data sets to show how the population is increasing. In GCC means Greater Chennai Corporation, and the CMA means Chennai Metropolitan Area. And the last graph, as you can see, this is the time gap between the floods, which has been decreasing in such a way that which is more alarming. For in 2005 to it has happened next in 2008. After that, it has been reducing every year, 2 years. But now it is happening in every year. It is a regular thing that we are seeing of. And the second, what my thesis is objective of? The main objective is to implement nature-based solution to cater the effects of urbanization, which I'm speaking. The three main objectives. First is what I'm going to do. I'm delineated my study area. I'm going to map all the blue infrastructure it has, the water bodies it has, and I'm going to give a framework to justify the study that I've done, and some index method, which are the most vulnerable indicators. I have found out some indicators, and there are some indexes that I've derived, and what are the nature-based solution mitigation strategies which I can provide of. And these are the major effects of urbanization. Yes, there are a lot more effects of urbanization, but I am going to limit myself with urban flooding, wetland destruction, depletion of groundwater, and dumping of solid waste, etc. And next is my detailed methodology. I'm not going to deep into it. As I said, I have 3 objectives. I'm going to split my objectives in such a way that each objective has a definite path, how it can be done. For example, mapping, I'm done a survey, I'm doing a GIS mapping. For that, what are the outputs I'm getting, and how the blue infrastructure vulnerability index, which I'm saying of, can be done. And this is my study area. As everyone knows, the Chennai, that was a total CMA area. Can I get a pointer? Yeah. Thank you. This is the total. This is the total CMA area. This is the total CMA area. This is the GCC area. This is the study boundary which I'm talking of. Why this is this area I'm considering? It has a lot of eco-sensitive zones. For example, Pallikarna area. As you can see here, this is the Pallikarna area which I was saying of. This is the dump yard, which is located opposite to the Pallikarna area, and it has been decreasing. It has been increasing from 2014 to 2024. The dump yard has been encroaching the Pallikarna area, and it has causing several impacts also. To give you a detailed understanding of the study, as you can see, this is the higher altitude of higher. It is in an elevated position where GCC area, where the center of the GCC area, where these are the 2 side blowing points. Majorly, the water flows from the higher point to the lower point. But as you can see from this map, the blue color shows the dump yard, which is going to block the nature-based drainage channel that Chennai already has, and the dump yard is further increasing. There is a last one tip here, which is the existing natural drainage channel, which is going to get encroached by the dump yard, which I am showing off. After that, what will happen? Already Chennai is getting flooded. The dump yard is going to cover the existing natural drainage channel, and the higher altitude will also going to get flooded, and the lower altitude is already getting flooded. Yes. Next, what is the framework I'm saying of? I've said vulnerability index. What are the vulnerability that the blue infrastructure has? There are dump yard, there are encroachment. I'm trying to give a quantitative data so that we can find out which should be taken care immediately, and what are the things that we should go on further. Which has I've done a primary survey regarding this, and I identified some major vulnerability factors and rank it off. And coming to the conclusion part, as from the study I can I can say that the dump yard, which is causing the major problems, underground water depletion and the quality of the water also. How the nature-based solution that I'm suggesting can be helpful. For example, if you see the encroachment or in the dump yard, we can introduce some repair and buffer where it can be stopped. For every indicators which I found, I'm suggesting a nature-based solution for a local area planning approach, which is a lab, but it is considering the regional level perspective. For example, as I said, the natural drainage connection it has, how it is getting drained. But as we come to the panchayat or local ward level, what they're basically doing there, if I'm saying the nature-based solution, they are implementing some greenery space or a park or a surrounding, which completely does not have any connection with the regional basis perspective. They are only focusing on local area planning. Yes, that's it. Sure. Thank you. Sorry, it's completely an urban planning section.
So you fundamentally use the word blue infrastructure to refer to water bodies.
Well, yeah, just because it also considers of natural drain it has. So I think the water body term does not cater with the drains it has. So I thought.
So when you talk about the area reduction.
Yes, sir.
Did you include the reduction in drains also? Do you take the size of drains?
Not exactly, but it is a further, I'm dealing with it. I'll include it.
Because you fundamentally only talked about reduction in how many square. That's all water body, right?
Yeah.
Okay. So can you repeat your conclusion?
Yes, sir. For example, I was with CMDA. I was an intern there. What they are doing basically, they are approaching in a local area planning approach, but it should not be done for every for my study area. GCC is a regional based approach. So for if you are doing a local based planning, consider the regional based approach and include it in your study perspective. That is majorly concluding it, and that's why I proposed my nature based solution on ward basis. For example, if you can see, the ignorance of natural drainage flow it has, but it can be done via a sponge park, or it can be included ward-wise solutions, local area planning approach. So we can cater with it.
I think your case study of Chennai basically says don't dump the solid waste. That's all.
But they are dumping it, yeah.
Correct. Yeah. But what is the nature-based solution there?
For example, there is a bioremediation we can suggest of. But it is a very
they chose the wrong location. That's all right.
Basically, we have started it, but it's in wrong location.
It's, yeah, I mean, it's not a technology or method.
No.
Right?
Yeah.
So in terms of, I don't know, when you say nature-based approach, I can see what you mean to say that there was no consideration of the drainage pattern while locating the solid waste management.
Yeah.
That's the only place where they got land, so they chose it.
Yeah.
So the nature-based approach is to respect the
nature
while trying to locate solid waste dump yards and things like that. That's what you mean.
Yeah.
and the local area plan should be embedded in the regional scale plan. That's the point of view. Which I guess it is, right? Usually.
But yeah, but due to some, actually, to be frank, there are some ward-based criteria that they are ignoring of. There is a GCC, there is a CMA, there is a CMDA boundary impact that they are ignoring of. There should be an agency which can hold, consider this and approach in such a way.
Okay.
Yes.
Okay. Question. Thank you.
Yes, thanks, Migash. So the next paper is from a team from IIT BHU Varanasi. Ms. Harsimran Kaur, and along with her team members, co-authors are Mr. Ravneesh and Ms. Kshama Gupta. So on their behalf, Mr. Ravneesh would be presenting on this next paper, which is titled Reimagining the Nature of Blue-Green in Cities, a Multidisciplinary Ecosystem-Based Approach Towards Water Secure and Flood-Resistant Cities, a case study from Varanasi. Over to you.
Yeah, good afternoon, everybody. I hope I'm audible.
Yes, you're audible, and one request is to please time yourself for the next 7 minutes. Thank you.
Okay. Good afternoon, everybody. This is Ravneesh. I am a research scholar in IIT BHU, and currently I am studying on the application of nature-based solution towards flood-resilient cities. So in this study, we will be talking about an ecosystem-based approach towards water secure and flood-resilient cities, taking the city of Varanasi as our case example. Now for a city, so here we will be talking about city-wide application of nature-based solutions. So for a city-wide application of nature-based solutions towards effective water management, we must first gain an understanding of how water flows in a natural landscape and how, due to urbanization, this flow of water changes. To begin with, it will be beneficial if we can imagine the hydrological cycle in a natural landscape vis-a-vis an urban landscape. So when I say a natural landscape, it's a scenery which is shaped primarily by nature, featuring elements like mountains, rivers, forests, diverse wildlife with a very minimal human intervention. While on the other hand, an urban landscape is a built environment, which is dominated by human-made structures like buildings, roads, and infrastructure, often interspersed between green and blue spaces to provide a natural feeling towards in a city setting. Now, talking about the hydrological cycle, in a natural landscape, water moves continuously from the surface of the earth to the atmosphere and back again. So in a way, it is a cyclic process that ensures the movement of water between the various spheres of the earth. And this process of a global water cycle, it can be understood, further well understood with the basic physical processes like transpiration, evaporation, condensation, precipitation, infiltration, percolation, and surface water runoffs. Now, parallelly, climate change is evidently changing almost every stage in the global water cycle. For example, with the rising air temperatures, they are causing more water to evaporate, and more evaporation is leading to extreme weather events such as droughts and flooding. So when we say that the cities, primarily cities, they are more prone to climate changes such as flooding and droughts, here we are implying that the natural hydrological cycle in the city that is severely impaired. So what is the reason behind this? So the main reason is that due to the burgeoning population, in order to accommodate this population, more and more surface is needed for providing the infrastructure. And this generally comes at the cost of natural urban and blue-green spaces being driven away from the cities. So the replacing of natural land cover by the impervious surfaces, such as roads and plazas, parking lots, and buildings, it decreases the city's capacity to absorb water. And in the event of rainfall, it becomes more susceptible to the climate change fluctuations, which leads to flooding. So according to a UN report, UN Water in 2020, it was stated that water is the medium through which nature and human societies will experience most of the impacts of climate change. So in this study, we are trying to understand that how water flows in the urban landscape, number one, then derive the gap in the various processes of the water cycle, secondly, and if we can reinstate the natural water cycle back in the cities by mimicking these processes through nature-based solutions. So towards this, we have taken the city of Varanasi as a case example. The city of Varanasi derives its name from the Varuna River and the Asi River, which flows through the city before finally merging into the Ganga River. And the city and Varanasi lies on the western bank of the Ganga at an altitude of 77 meters above sea level. On the right-hand side, we see an ancient water body and forest tract map, which was prepared by James Prinsep in the year, and a Britisher in the year 1822. So we can see that how water was an integral part of the urban landscape of Varanasi. So the city had vast tracts of forest and interspersed with and dotted with inland water management system of ponds such as kunds, pokhras, and talabs. Now, these ponds, they acted as water reservoirs for the various activities of the city, and they were linked and they were sited in a way that it follows the natural topography and the drainage of the city at that time. And in the event of rainfall, these ponds, which was linked by the natural streams, the water used to flow from one pond to the next, and the excess used to drain into the river Ganga. Now, this ancient network of blue-green systems in the city of Varanasi, they provided many ecological services. But with population growth and rapid urbanization, these blue-green networks, they slowly diminished with time.
Sorry, Ms. Ravneesh, another 2 minutes, if you can wrap up. Thank you.
Learn more faster, please. Thank you.
Okay, now we have derived, using SWOT hydrological modeling, various in a remote using remote sensing and GIS-based environment in a SWOT hydrological modeling. We were able to derive a runoff map. Now, in this study, we are trying to do two things. Number one is how much water is available. And the second thing, how much space is available so that we can implement the nature-based solutions for urban flood resilience. Now, here we see that we have three maps here, but one is the slope map, land cover map, and hydrological soil group map. These all three maps are very important because number one, slope is a very critical factor, and the degree of slope will dictate that which nature-based solution will be implemented where. For example, if I say that I have implement permeable pavements or bias walls in a slope less than 5%, 4% is required, and no greater than 15% slope, these practices can generally not be adopted. So we have categorized the map based on that. Land cover map, here we can see that in the inner city core, more than 46% of the area is built up, and the most of the city in the inner core city is a densely populated map. And based on this, we will derive our nature-based solutions. In the hydrological soil group, we will see that there are two types of soil belonging to hydrological group C and D, and both of these soils are highly susceptible to vast runoff. So when we overlaid these maps in a SWOT hydrological map in modeling, in a model, and we were able to derive the runoff. Now here I have further used the Varuna River watershed and the Asi River watershed and derived the runoff zones in these areas. So here we can see that the inner city core area is more susceptible to the high volume of runoff in the event of a rainfall. And the less runoff areas are mostly at the outer city core area where we have agricultural fields and the barren surfaces. Okay, now to derive a BGI network map, so we further needs three things. One is I have already told about that there is a watershed map. So we have Varuna River and Asi River watershed here. And the first sub-watersheds were derived in these watershed maps, and then a road network map. Why I'm saying road network map? Because it is a part of a green infrastructure. And if we overlay a blue-green infrastructure parallel to the road networks running in the city, we will be able to derive a BGI network map for better implementation of the nature-based solutions. And here we have done to further understand that how NBS actually works at a meso scale in the city, we have also tried to identify few areas by overlaying these road BGI network map, the stream, the water network map. So we, in the upstream and the downstream areas, we have identified few areas where these interventions can be implemented. Now, here there is a Google Earth. So here, so this is actually on the Varuna River watershed. So here we see that there is a major tributary of the Varuna River that is flowing through the city on one hand side, and there is a road network that is cutting across this thing. So this area lies in the medium flow runoff zone. And so number one things that we have to take into consideration is that we see the natural profile of the stream that is flowing through the city. Now this water, in the event of the rainfall, this due to major dumping that's happening in the stream, dumping of solid waste, fecal waste, and all that, major eutrophication has happened. And so the stream is no more able to contain the water that flows into it in the event of rainfall. And when it overflows, it floods the nearby areas. So the nearby, the land cover is basically an agricultural and agriculture zones and some built up zones. And in the future, these agriculture parcels will also give away to a built up zones. So more runoff will be generated in this area. The first thing what we have to do for a nature-based solution is that we first have to protect the edge of
Can you please close out soon? Thank you.
I just need 1 minute. So we first need to protect the edge of this river. So by protecting, a buffer will be created and some natural dikes will be created through vegetation wherever it is possible. By protecting the edge, then when we come to the part where it is intersecting between the river and the road, a culvert has to be created so that to maintain that connection between the stream throughout the length of the city. Then thirdly, a nature-based solutions will be proposed along the edge of the, now depending upon that, as I said, depending on how much water we have and how much surface we have, we can decide whether we can do it along the entire length or we can do it in parcels. So that when the stream with overflow, these parcels can actually contain the excess water. So this is how we can implement the nature-based solutions by studying the city in general, by the hydrology of the city in general. To conclude the study, now we have generally used secondary sources for our study, but as we say, the finer the details, the more accurately we will be able to propose these solutions. So if we have a finer DEM map or a soil map and land cover map, these solutions will become more accurate. And then we should also when we say ecosystem services approach, there are a wide range of ecosystem services that these nature-based solutions provide. So we can further use our study for other services such as urban heat island effects and all. So this is how I conclude my study. Thank you. If we have any questions. Hello?
Yeah, thank you, Mr. Manish.
Run out of time, we'll skip the question.
Okay, thank you very much for your presentation. So thank you. Our last presentation before lunch would be Ms. Anusha from who's a project assistant with Wash Institute. Her topic is on planning strategies for blue-green infrastructure for mitigating urban flood and sustainable water management, a case of Chennai. Good luck, Ms. Anusha.
Myself, Anusha, I'm just now going to present regarding the planning strategies for blue-green infrastructure in the case of Chennai for the stormwater management and the flood mitigation. And so this actually I'm representing my thesis, which is based on that. So Chennai, when we are talking about Chennai actually receives higher intensity rainfall during the month of November, October, and December. And the main reason for that is that due to the cyclones in northeast monsoons, also one of the main reason, and storm surges also. And when when these are the climate related incidents which is happening. But apart from that, man-made disasters also one of the main reason, and the encroachment of water bodies and the canal, I mean the siltation in the water bodies, and the green spaces has been much more reduced from the past 1990 to the current 2020. Almost like 40% of overall green spaces has been reduced. And then considering that, when we are looking on the overall approach, like micro level approach, like based on this downstream, we are much focusing on it, but we have, in my analysis, I have focused on this upstream level approaches also for that planning. So considering that for 10 to 15% of the major basin which lies on the CMDA, the Coastal Basin, River Basin, Aranya, and Kuvam Basin and Kovalam Basin. These are the 5 major basins which falls within the CMDA limit, but remaining 85% which falls outside the CMDA limit. So we have to give an approach and proposal based on the basin level for this flood management. So macro level approach is more important. So these basins which all falls under this 2 states, which Andhra Pradesh and Tamil Nadu together, and the 5 districts which falls under is the Chittoor district, Nellore district, and Tiruvallur district, and Tiruvarur and Kanchipuram district. So getting to the next one. So these are the major annual rainfall incident which falls from 1990 to 2020. We can see that average annual rainfall has been reduced. But when we are focusing on the northeast monsoon rainfall, we can see that the intensity of the rainfall has been increased, and in southwest, intensity has been increased towards the coastal areas, and in southwest monsoon, the intensity has been high in the inland areas, in the overall delineated area, we can see it. So when we, why we are comparing with the water bodies and the rainfall is that almost like each basin, when I'm talking about the Coastal Basin, it has almost like 270 tanks in the delineated areas. In Adyar Basin, it has almost like 40 tanks in overall. So each basin has tank, but now it is being encroached, and the siltation is also one of the main reasons. So the water retention capacities and the holding capacity has been much more reduced. When we are comparing with the cyclones, which is happening from 2015, the major cyclones which has happened, so we can see that it has been forced to release the major almost like 8,000 cubic feet per second from the Chambarambakkam lake has been forced to release because the capacity has been much more reduced. Same it happened in 2023 also in December. So in from my analysis, it's like rainfall and the surface water bodies and the rivers, they are all interlinked together. So we have to manage in such a way that we can prevent this upcoming urban flooding. So this is overall macro level approach in terms of like policy landscape which is existing now. Even BGM planning is already there in master plan, but the approach should be in 2 state level. Like we have to consider in a not in a small boundary level, but it should be like a basin level approach that should be implemented in the further thing. So state action plan on climate change should be implemented in such a way that joint committee action should also be there in the state level in order to mitigate this flooding and encroachment of rivers and water bodies and everything. And green space should be in improved states. So again, the nature-based solutions, the ecosystem, I mean restorations and rejuvenation. So these are the methodology for BGM implementation for the policy level and program level and implementation level. The formation of joint force and legislative protection and blue-green infrastructure master plan should be implemented in the regional level, and the program level, it should be the capacity building should be there, and implementation level, it should be like based on community level engagement should be there also. from the top to bottom, we have to engage all stakeholders to be there, and GS monitoring also, that for this monitoring, it should be enhanced. And conservation laws should also be there. And so when you are focusing on much on evolution of Chennai, getting into a micro level, so from the Sangam literature to the till now, from Chennai basically depends on the water tanks, because in summers they are facing water issues, water scarcity, and in northeast monsoon, due to this siltation and everything, they are facing this urban flooding also. So nowadays, I like from 1970 to 2015, due to the encroachment of water bodies and everything, and 2000, in that time, IT sector, the boom has been there, and most of the lands have been converted into built-up space. And 2015, the major flooding happened. So in LLC, we can see that the time from 2000 to 2010, how the build-up has been increased and the change detection analysis has been done. So in the vegetation, we can see almost like 40% has been reduced, and water bodies has been reduced to 10%. So in the blue-green infrastructure, the excessive intensity of rainfall in shorter duration is also one of the main reasons for the flooding, because the canals and water bodies act as a natural stormwater drainage. Sorry, just 1 minute, I'll give a conclusion. So the current grey infrastructure, which is now it's almost like for stormwater discharge is 31.9 mm per hour. But the thing is that as per guidelines, it should be like minimum 68 mm per hour. So again, we have to focus both on blue and green as well as grey infrastructure. This is a maximum intensity of rain in shorter duration from 1970 to 2020. Maximum precipitation in 1 hour. We can see that the cyclones years which matches with the maximum intensity precipitation 1 hour from 1990 to 2020. The major cyclone incident coincident with this. And these map shows the flood from at a written period of 5 years, how it will be like. 29.1% of Greater Chennai Corporation will be risk. At 100 years, it will be like 56.5% of Greater Chennai Corporation will be risk. So again, the planning should be putting all the dots together, which actually leads to this urban flooding. So one is that encroachment is directly leads to encroachment, inadequate infrastructure, it all leads to the urban flooding. And green cover loss, that also one of the main reasons. So the aspect should be in a such a way that it should be from top to bottom and should enhance all stakeholders together in terms of NBS solutions. So this is the existing scenario and the NBS proposal.
You completed?
Yes.
Okay. Thank you. I know you ran out of time. Like you wanted to say everything that you did, could have focused a little more on just the main points. But I'll give you a chance to explain what are the 3 or 4 planning strategies for blue-green infrastructure, for mitigating urban flood and sustainable water management for Chennai. What are the 3 or 4 planning strategies? How would you say it in your own words?
Sir, I will say that I'm not going into much more into technologies, but I'm focusing more on a planning level and policy level. But I will say that.
Hold on. Don't talk too much. Just say what are the 4 planning strategies?
Sir, we have to look on BGA implementation in the next master plan.
And what do you mean by that?
Sir, actually, nowadays we don't know the existing, like it's not related to environmental thing. It's more focused on like the residential or other planning.
I know. So what do you mean when you say we should do BGI implementation?
Sir, we know that what is the existing condition and what we can do further for that. Maybe the approaches towards will be like from macro level approaches to micro level approaches, and what terms we have to be, whether it is a long-term implementation or short-term implementation, and what all the stakeholders should be involved.
Can you give an example? What do you mean by BGI implementation?
Sir, actually in BGI.
That's your first planning strategy, that we should implement more BGI.
Yes, sir.
Is that right?
Yes, sir.
What exactly is that?
Sir, for example, in CMD, if I'm telling, so the water bodies, which is this, nearby water bodies, it should be like a buffer space should be created in terms of.
So what if a water body is already surrounded by residences, then what happens?
Sir, actually, the thing is that during this flooding times, so these encroachment of lakes and everything is happening, and the people are, dumping their.
Encroachment happens not during flooding time.
No. Actually, I'm telling, during flooding time, what happened? So majorly this, the solid waste, normal.
No, we know what happens. I know how flooding happens. I'm asking, what is the strategy you're recommending? You said implement more BGI.
Yes, sir.
Or can we start again? What are the 3 or 4 strategies you're suggesting? Start with the first one.
Sir, the strategies which I'm focusing on is that the encroachment should not be there near the water bodies. And
What's
the
the
riparian buffer.
first strategy? I thought you said implement more BGI.
No, encroachment should not be there near the water bodies, and buffer space should be
What if
created.
it should not be there? If it is already there, what do you do?
So
remove encroachments is one of your strategy.
No, sir.
Then?
We can enhance the trees and spaces, which is, even if it is a minute pocket spaces which is present there, and we can do it then.
It's part of the encroachment approach, or it's a new strategy you're mentioning?
The new strategies which I mentioned,
Okay,
because
so-
we can't remove all
So
the.
what's the first strategy you would like to mention? What is the first point? When I say give me 4 planning strategies, what's your first item?
So this is the one, and next one is that.
Which one? Which is the one?
The encroachment.
Remove encroachments.
No, encroachment on water body should be, it should be prevented, and we have to increase the BGI which is near to that area, and riparian buffers should be there, and small level micro parks, and that should be considered while planning also. And even if it is a wasteland, we should improve that BGI in that areas. So even if it is considered the wasteland.
Okay, fine. I won't trouble you more. See, I just have one feedback. Since you're doing your PhD, all right?
No, I'm not doing.
You said this is my thesis. Or
This
something.
is my thesis in master.
Masters, okay. One is to gather a lot of information and be very thorough with the background, okay? But that itself cannot be the output of a study. You should try to, it's very comprehensive. Your understanding is comprehensive. It's a little, what I can say, the theory of flood management, okay? But how do you come up with recommendations which take into account the current realities and practicalities of existing situation? This is how it should be, this is how it is, this is how it should be, this is how we lost it, this is what is going wrong. The diagnosis is clear. The understanding of the problem, the diagnosis is very clear. But when you make recommendations, it should be rooted not in theory, but rooted in the actual context of Chennai. And it should be more than just saying we should have more trees or we should have more blue-green infrastructure. We know all this, right? So there is, but how is the question when you don't have that space? So your strategy should sort of get into the actual reality of the situation and make recommendations. Then only it has more value. That's all I'm saying. Otherwise, good. For your masters, it's good because it will show you understand the subject. But when you get into the field, where if you're not able to even apply one of these strategies, then it's a problem, right? Because of the realities of on the ground. So it'll be good for you to probe that even now. Even though it's more of a college stage now, but probe that even more. The reality of the practical issues. That'll be helpful. Okay, but otherwise it's very comprehensive. Effort is very good. I can see that. You're thorough and you've gone into details and all of that. But try to make it more connected to the real world.
Yes, sir. I think I should in recommendation level I should look on much more detail.
Is it end of your study or you're in the middle of it?
No, actually I have completed it, but I looked on several levels. This stormwater management is just, it's a part of it for me. So when I'm enhancing it, so I think I should work much more on that in detail, because the main thing for me is a sustainable urban water management in thesis. Then for stormwater management, it's a part of it. So for this, I have just enhance it. So,
Yeah, okay, thanks. You have something to say? Thank you.
Okay, thank you, Anusha, for that. And we'll have a lunch break now. So let us reconvene at 2 p.m. Yeah, give ample time. Thank you, everyone. Lunch is being served outside. We had first planned that you will get 80 of them, so it can take the rest. So that's one more. Please, 15 numbers in Fifteen to 21%. That's a bad.
That's it. Otherwise, the PhD Yes.
Welcome back, everyone. I hope all of you have finished your lunch and post-lunch session. So I hope it was quite engaging and interactive. To start off with the next session, which is on roadmap towards sustainable management of groundwater resources, I would like to invite our first presenter, Ms. Gracie Hepzibah David, who's Assistant Professor Acharya's NRV School of Architecture. Her topic is Learning from Ancient Water Structure Design, Case of Sanodia, Rajasthan, India, a Sustainable Approach. Look forward to this interesting topic.
Good afternoon, all of you. Sorry for after lunch. I think most of you would be lethargic. I am Gracie David, and I have my co-author with me, architect Sana Parveen, and we are working on this paper called Learning from Ancient Water Structures, the case of Sanodia, Rajasthan. The water scarcity in Rajasthan is a multifaceted issue, as most of us, we had seen yesterday's presentation also, and we are focusing on the arid region. The broader socio-economic challenges faced are the major issues, along with poverty and overall well-being also. This presentation is kind of an interdisciplinary approach. It not only focuses on a certain discipline, but also covers a varied disciplines. This study examines the interplay between the traditional water systems, the social relations, and power dynamics. This is the focus of our study. For the case study, as you all know, I've taken Rajasthan as the focus study, and the district which I have focused or highlighted is Nagaur. This study was done from February of 2002, where there is a belt also known as Nagaur belt, and all these villages, almost 21 villages, have been affected by fluoride contaminated water. And the hydro, it's not any of the external sources, but because of the hydrogeology of this area. The left map highlights the fluoride distribution in the groundwater. And as you can see, Nagaur, Jodhpur, Churu, and Jaipur, these are the 4 areas which are also known as Nagaur belt, is the highest. It contains more than 20 ppm in the groundwater. And on the right side, if you can see the yellow map, the Nagaur district is been highlighted in the gray, in the red highlight. It's shown the drought frequency of this area, which is also 1 in 4 years. And we started studying this region because most of these processes have been mentioned that in the other areas of Rajasthan and even Gujarat, where it is arid, the water harvesting structures work very well. But in this Nagaur belt, because of the fluoride contamination, that was a major challenge that we were handling. Now, Rajasthan's water types, as many of the literatures also mentioned, is 3 types of water, that is Palar Pani, rainwater, Patal Pani, that is groundwater, and Rajani Pani, which is also capillary water. So these are the 3 water sources that have been highlighted. This is a research framework that we were following. And so the major problem statement that we identified was a limited understanding in the transition of water systems which underwent over time. Whatever we were studying, we came across one major concern is that all these water systems were isolated as being studied as a robotic study, isolated from the people, isolated from the communities, and isolated from the social power dynamics that have been influencing the transition. So that is a major gap which we identified in the studies that have been till now. There is not a proper mapping of what transitions were happening on these water systems. Basically, also in correlation or influenced by the hierarchies and the power plays. So that is something which was majorly missing. And so we started exploring it. Of course, there's a lot to do in this particular study. Now to study why it is significant, as I already mentioned, this region is fluoride contaminated, and therefore the primary viable source of water has to be a safe drinking water, and it has to be something which comes from the community. And I'll go to the next slide. Yeah, I'll come to what the community brought, but before castes which exist in this village. The common berry is the only one which can be accessed by all the people or the travelers who do not come under any of these caste system. The others are all basically very limited to the particular caste. So we also started mapping them, and so this is how we mapped it. And then what we understood through, so basically my understanding is that we wanted to understand how designs are influenced by the social and the power play of the people. And we can see that the common berry and Brahman berry is larger than all the other three berries that you see, the Nayak berry, Balai berry and the Raigar berry. So what is the reason of Brahman berry being larger? Because obviously the Brahmins who held a lot of power, and the common berry also because common berries were mainly constructed for trade reasons, and obviously the businessmen or the people who held a lot of money were also the people of interest. And so these are the issues that we were handling. The analysis part holds two major levels: the micro level and the macro level and the micro level. At macro level, we were understanding how across diverse zones, examining relationships between evolving state society dynamics, shifts in power, and how the water structures have been influenced. Now, how does this berry work? So, as I mentioned, the three different types of, just give me 1 minute. These are the three different types of the rainwater, the capillary water, as well as the groundwater. All of this can be filtered out through this slow processing of filtration and gets conserved into the berry systems. Now, the water in the berry is fluoride. It does not have the dangerous levels of fluoride that was mentioned earlier, and so it is safe drinking water. So hence, ecologically, these water systems are very well designed, but at the same time, socially, they are non-exclusive. And even today, as I was getting to know that some of these berries are degraded. But two of these berries are still functional. But one of them, the Nayak berry, nobody of the Nayak community are still residing in the village. And hence the Nayak berry, nobody is able to touch or even access water. So that is a major concern. And the major problems that we were facing throughout these is one, this lake nowadays, unregulated water is being discharged into it. The degradation of berries or the water systems is one of the second major issue. The government initiated one more problem in which they have started boring right next to the lake. And that water is all fluoride contaminated, and yet it has been considered as a water source. That is a third major issue. And the fourth is, as I already mentioned, caste is the major divide here. And also underlying all this, throughout Rajasthan, throughout Gujarat, there's a major issue that women and children are the main source of getting water. So therefore, the vulnerability lies more on the women and children, or that is a major concern. So yeah. So these are the results of how, so what we were studying is that how social dynamics are influencing the design, and how we can study these systems in collaboration with the societal this thing. And this is my recommendation, as we just constructed we just made up matrix of conservation, and we also have a detailed estimate of what it takes to restore these water systems. But also there are so many things in place, and we were working with the community, so there were major challenges. The proposal was for the people to put in 30% of the money, and 70% of the money can be given with the help of NGO or with the help of the government or any other bodies. So these are the recommendations that we are coming towards. And majorly, considering that while traditional systems are critical markers of historic continuity and cultural heritage, but they're largely shaped by the social hierarchies, and it is largely designed for and by the people who hold the power and the money. So that was a major challenge which has never been addressed in this level or on any scientific data. So that was a major concern of the paper. Yes.
Can I make myself heard from here?
So just 1 second. Sir, if I may just request you to have a seat, I would like the jury to finish their questioning, and then I'll come to you, sir, for questions. I'll open the floor for questions. Sir and ma'am, if any specific questions, and then we'll go on to.
I think it's a very interesting paper and the whole study, and I think it will be very useful. The question I have is, what was the age? You know, the maximum age of the people you had interviewed, because that would tell us also what, how much could they recall the past. And the second question I have related to this is, you're finding that now it is not being maintained. Between the different berries, the maintenance is not being done currently. Yes. What was the social construct at the time earlier when these different berries were being maintained? What were they doing? What were your findings as a part of your study?
So for the first question, we took a lot of interviews. The oldest person happened to be 80 years old. But also I'll tell you one more thing. In Synodia or in the whole Nagaur belt, there are not many 80-year-olds. The problem is because of fluorosis. So the 80-year-old body takes a jump of 20 years and they behave like a 100-year-old body, and so on. Like 60-year-old body behaves like an 80-year-old body. And because of that, not many males who happen to also have the power and the historic understanding or the literacy to have basic sense of how it worked, all of them happen to be males, and most of the males are not alive today. But we got three interviews who were 80-year-olds, and all these 80-year-olds mentioned that these happened through Jalsabas. Now they are being called Jalsabas. That time they had another colloquial term for it. So what happened is the Brahmins were the ones who were holding the maximum power, and under them there were individual caste heads. And all these individual caste heads used to be the ones who would dictate which berry has to be which design. So we saw all the berries have a slightly different design, although the main component for construction was similar. So they used to handle it in such a way that every person, they used to contribute in that time. The value for money is almost 100 rupees today. So 100 rupees per month, every household used to contribute. And through that contribution, the rest of the contribution would be given if needed. Most of the time it was not needed, but if needed, they would be given by the panchayat. So the deficit would be filled by the panchayat, but the initial capital was the initiative of the community. Now the problem happened over these years. Synodia did not have any place for job retention or the coming generations to hold themselves. So they actually traveled to Jaipur or the nearby cities and towns, and they started finding jobs. And that is why the Nayak berry, which is also one of the functional and safe water drinking berry, has not been accessed by anybody, because there are no Nayak members in the village. And so that berry has been locked with a big lock, and that lock can only be opened by the head of the Nayak members, who are all residing in the nearby cities or towns. And some of them are not alive. So that was, did I answer both of your questions?
Related to it is, as a part of, I mean, that nightberry is not being used now, but what about the maintenance of the other berries currently? What were the learnings you have from the previous, the way it was managed earlier? What would be the recommendations, and how do people take it today as to continue its maintenance?
So the maintenance, as I said, now in today's time, since 2022, the maintenance has been moved to another government body of water supply. That is, one boring has been started off, and that borewell has fluoride contaminated water, not a good source of water. This berry is still, the common berry still has good safe drinking water, and this water has been pumped out to a government school. And so this water is used for people from the nearby households. And as I showed in one of the mapping, the farthest place is almost 500 meters away from the lake or the berry area. And so people have to walk a little bit, but mostly all of these people have their income from animal husbandry. And so they bring their cattle and then they are pumping out water, and misuse of water is happening. On the other side, there are NGOs like Tarun Bharat Sangh and Jal Bhagirathi Foundation who are working on these village, the whole belt, and they are encouraging them to build individual tankas. So what happens is, because of the community disintegration, they are no longer able to have a community level berries like how it existed, but they are very much interested to have tankas, because those tankas are safe enough for them to drink water. And then, and they're only using it for drinking water, not using it for animal or any other purposes. And what happens here is, this water, even if they are using it economically, they can use it for more than a year. So this is a place which is water scarce, and there's no tankers coming, there's no water supply, but they're able to hold the water for more than a year. And they're even generous enough to give 3 pots a day to the neighbors also who don't have a tanka. So tankas are basically privatized berries, and yeah, so that is how the NGOs are.
I presume that Jal Jeevan Mission scheme is yet to be implemented in this village.
No, sir, it has been implemented.
But in that case, have they laid pipeline to the households?
So all these Nagaur belt are all people who live in dhanis, also known as hamlets. So it is very difficult even for Jal Jeevan
But this particular village, I think it looks to be village having houses very close by.
Yes.
So they are not in dhanis in this Sanodia, they are dhanis, means you're like conglomerates.
So this map of Jal Jeevan Mission, this is the latest map, that is February 2025. And even in that, if you see, the other areas have reached.
I'm talking about this particular village.
Yeah. So only around the 3 water taps have reached this village. So
It's only 3 households have.
Not households, sir. First, they start with the government schools, sorry. So there are 3 government schools.
No, Jal Jeevan Mission is to households. Yeah, that was old scheme where we have to provide water to the schools. So that's.
So
my
what
simple
happens
question is, has Jal Jeevan Mission being implemented in this village or not?
They have started off with the Jal Jeevan Mission, but not.
Okay, so the first thing which they do in such schemes is to identify a sustainable source. So what is the source of Jal Jeevan Mission if it has been already implemented?
This whole Nagaur belt has been provided.
Not Nagaur, I'm just talking about this particular Sanodia village.
So that is Indira Gandhi Canal has been brought, the water from Indira Gandhi and.
No, I think, yeah, I'm not clear, because you talked about a sustainable source which already exists over there. There's 5 berries.
That is a talab. That is all rainwater harvesting. It is not a river, or it is not connected to it.
That I know, but unfortunately, I'm not able to understand what's the source which they are using for Jal Jeevan Mission.
No, not at all this talab.
What's the source then?
Not sure about, but
fine.
It's
So
one of the rivers which is coming from Punjab. They have got it to Rajasthan, and that water has been provided.
They will not, unless it is a multi-village scheme, they'll not go for such rivers-based schemes, okay? Because they won't fetch water from distance. So it's very, very clear in the guidelines. So they identify some groundwater source. So, yeah. So I'm not clear at all, because if these berries can provide a sustainable source, in that case, the government should definitely use this as source of water. And then whatever, say, caste dynamics, whatever, that will get away. And that's one of the reasons. It's been clearly written in JJM guidelines that we should not say how any demarcation goes in the caste when we identify any source. Of course, it may be prevalent in some part, but they're trying to provide it. So my request is that please try to focus on that particular part. How can we overcome, and then can these berries be a sustainable source for supplying water to households?
Yes. Yeah. So, I mean, there's another paper coming out of this paper, and then we'll be working on how it can be taken into multiple house supplies.
Just request to make it a little quick, because we have a lineup of some more presentations.
Okay. This is a very topical paper, but also a worrying paper, according to me, because I see almost 2/3 of Rajasthan being affected by the fluoride and so on. Fluoride is one of the very worst kind of, the pollutant, natural pollutants. And what you're saying is by means of dilution, by from the canal, etc. But is there no technological approach for this one? Because as I know, the technique is there, and so many other new techniques. I myself experimented using some rare earth waste. Even they can trap fluoride, etc. So this way of the approach to treatment of fluoride is not actually technologically up to the mark, as I see, and it will leave a lot of this. Do you have any pictures of the people with modern teeth and?
I've not included that in the presentation, but we have.
Show that because we know what is the status of health and how badly this natural fluoride is affecting the health and community, etc. So that will be more telling and will be more so. There is an urgency about it. That's what I want to say of finding some solution. Even I think there is the electrolytic method of treating fluoride also. I think the more of technology inputs are required for this kind of solution, and not by just mere waiting for some canal water to be tapped into this and dilution. Dilution is probably the last approach I would recommend.
So this system is basically, it already existent in the, it comes from the community. So my focus was to study on how they did it. And throughout all these last 500 years, they have survived through droughts, multiple droughts actually, and through this system. So that was the focus of the study. Of course, my background does not allow me to study all the chemical part of it.
Okay.
But I was studying the design and the
No, what I mean is it should ensure health for the community.
Yes.
If that is the end of the your search game, that should reflect in the okay. Yeah, just survey.
Thank you so much, Ms. Bracy and team. Now I would like to invite the next presenter, Mr. Selvir G, who's geophysicist from Art of Living. His topic is on mitigation of groundwater exploitation through managed aquifer recharge and rainwater harvesting, a case study of Uttanoru mini watershed in Palar Basin, Kolar district, Kolar district, Karnataka. Welcome, please. Please ensure that you can finish your presentation by 7 minutes. I'm sorry, but then I would like to.
Yeah. Good afternoon, everybody. Yeah, good afternoon, everybody. I myself, Sahadev, the geophysicist from Art of Living, Bengaluru. So I am here to present a simple case study where we have carried out recently, that is Uttanur. This is the one mini watershed in a Palar Basin. So just let me show that, yeah. This mini watershed is a part of the Palar River Basin. We all know that, Palar River is passing through the 3 states and it has got a big catchment area, but we have chosen one small one, spanning an area of 32 square kilometers. And here the average rainfall is around, 800 mm. And why we have chosen this area is because it was declared as a overexploited area by the Central Groundwater Board, CGWB. That is one concern for us. And then most of they are using the main source for water, for irrigation as well as for drinking is only the groundwater resource. They do not have the perennial streams or streamlets or rivers close by their village. Otherwise, they are nearby Palar River also, right? So declining their groundwater, declining agricultural productivity and increasing socioeconomic vulnerabilities, we thought of taking this as a experimental basis also. Basically, next we'll go that. The objectives of this, this Uttanur mini watershed is to essentially to increase the groundwater potential through managed aquifer recharge systems. That is one of the unique approach where the art of living has been practicing for the more than a decade. There are so many several successful stories are there in the YouTube. You can search, like one is the Kumudvathi river nearby Bangalore and Naganadi in Tamil Nadu. There are so many things are there. For the last 10 years, the art of living is practicing this in more than 5 states of India. That we will not go into details. And going forward, this one, the idea is one is that one. And to study the impact study of those interventions in particularly belonging to this Uttanur project also. That is one of our agenda in this one. And developing a replicable models. If it is successful here, so that we can replicate this in other parts of India as well, in order to have the sustainable water supply. That is the one thing. And we here the key objectives is just it is not just applying the technology what is available. At the same time, we are interested in the making awareness in the stakeholders, in the mass people also, how to manage the water and other systems. And as you know, most of them, art of living is very strong to reach the mass people. And the other thing is, the methodology which I am going to talk is about, innovative and cost-effective and eco-friendly methodology. So this is one, yeah. Let us have what exactly the MAR. We can have a quick video. There is only 1 minute video. No sound.
ಚೆಕ್ಸ್ ನ ನಿರ್ಮಿಸಿದರೆ ರಭಸವಾಗಿ ಹರಿಯುವ ನೀರನ್ನ ವೇಗವನ್ನು ತಗ್ಗಿಸಬಹುದು ಅಂತ ಹೇಳಿ ಅದನ್ನ ಗುರುತಿಸಲಾಗಿದೆ. ಮತ್ತೆ ಅದರ ನಂತರ ಎಲ್ಲಿ ನೆಲದ ಆಳದಲ್ಲಿ ಹೆಚ್ಚು ಅಂತರ್ಜಲಾಗಾರ ಆಗ್ತಕ್ಕಂಥ ಮೆದುಶಿಲೆ ಇದೆ, ಅಲ್ಲಿಗೆ ಒಂದು 15-20 ಅಡಿ ಕೆಳಗೆ ಆಳಕ್ಕೆ ಹೋದಾಗ ಅಲ್ಲಿ ನೀರನ್ನ ಕೆಳಕ್ಕೆ ಇಳಿಸ್ತಕ್ಕಂಥಕ್ಕೋಸ್ಕರ ಇಂಗುಬಾವಿಗಳನ್ನ ಮಾಡ್ತಾರೆ. ಈ ಇಂಗುಬಾವಿಗಳು ಕೆಳಗಡೆ ಹೋಗೋ ನೀರನ್ನ ನೆಲದ ಆಳಕ್ಕೆ ಇಳಿಸಿ ಅಂತರ್ಜಲದ ಮಟ್ಟವನ್ನ ಮೇಲಕ್ಕೆ ಏರಿಸುತ್ತೆ. ಹಾಗೆ ಮೇಲಕ್ಕೆ ಏರಿಸುವಾಗ ಎತ್ತರದಲ್ಲಿ ಮಾಡ್ತಕ್ಕಂಥ ಒಂದು ಏನು ಅಂತರ್ಜಲದ ಮಟ್ಟ ಮೇಲಕ್ಕೆ ಏರುತ್ತೆ, ಹಳ್ಳಗಳ ಆಳದಲ್ಲಿ ಹರಿತಾ ಕೆರೆಗಳನ್ನ ನಿಧಾನವಾಗಿ ತಲುಪುತ್ತೆ. ಅದನ್ನ ನಾವು ಸಂಗ್ರಹಿಸೋದಕ್ಕೋಸ್ಕರ ಕೆರೆಗಳಲ್ಲಿ ಒಂದು ಕೊಳವನ್ನ ಮಾಡ್ತೀವಿ. ಆ ಕೊಳದಲ್ಲಿ ಅಂತರ್ಜಲ ಮೇಲೆ ಬರುತ್ತೆ, ಮಳೆ ನೀರು ಕೂಡ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಮತ್ತೆ ಅದು ಬಿಸಿಲು ಗಾಳಿಗೆ ತಾಗಿ ಆವಿಯಾಗ್ತಕ್ಕಂತ ಒಂದು ಪ್ರಮಾಣ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಇದು ನದಿ ಪುನಶ್ಚೇತನ ಕಾರ್ಯಕ್ರಮದ ಒಂದು ತಾಂತ್ರಿಕ ಕ್ರಮ ಅಂತ ಹೇಳ್ಬೋದು.
Those are the structures actually, when we are talking about the MAR and managed aquifer recharge systems. Essentially, those are the structures like boulder checks and recharge wells, recharge bore wells, etc. We are constructing them in the selected mini watershed. So the adapted methodology here is, in generally, it is, we first of all, we go through that, we generate the thematic maps where, through the geospatial technology, we have a in-house team also. GIS experts we do have, and we have access to the most of the the remote sensing data as well, and they are freely available now also. It's not a issue. And once we generate the thematic maps, then we will go as a team like hydrogeologist. I myself is a geophysicist, and other team we have environmental people also. So we will do the ground truth verification, then baseline survey, even because these days the sponsoring companies we are also concerned about the socio-economic conditions, how our structures are really impacting them. Besides increasing this one, and the third one, the fourth one is the geophysical survey. All these years we were doing just, geophysical information was enough to carry out these ones. But this time in Uttanur also, we carried out the geophysical survey for the particularly to look at the recharge bore wells, so that, the recharge water can reach up to the existing aquifer system, so that, the water will be available during the summer regions also. That is the one thing. Rest are very, preparing DPR, that is all fine, implementation and monitoring. And this is the implemented plan that we did within 10 months of the time. Almost 54 boulder checks we have constructed, and the recharge wells are around 70. And recharge bore wells only 6. Now we are using them as observatory wells also. Going forward to have the impact studies also, that is helping us. So that this project was, it took only 10 months of time, and it was the Tata Communications. They funded this project through their CSR funding. So yeah, this is the layout. Just short of time, I cannot explain more, but you can see this one. The impact studies, this where I would like to focus. Out of 6 bore wells, we were monitoring, we were taking the groundwater levels every quarterly. And at 6 locations we have, of course, it is too early to comment on that, but still we have a 3-4 readings also. And there in 3 bore wells, we have observed that groundwater level has been increased. But at the same time, in 2 more bore wells, it has been declined. There is 1 more bore well, there is no effect on that at all. The same level is being maintained. So that was a quick, immediate, quick understanding or observation out of the 2 observations. So that is why here you can see in the map, this is the density of bore wells. We want to consider this round ones you can think of. In each bore well, we have a designed like 500-meter buffer zone where the existing bore wells are operating and how they are, influencing on the observatory well. So that is the one thing we are considering now. It is ongoing study actually as of now. Then we will be able to tell you how was the impact on these, recharge harvesting structures. So yeah, as a conclusion, this is the main thing is to how to increase the groundwater potential in that area. And the next one is we have decided to monitor the groundwater levels now every month on a fixed date. So that we can give in a scientific manner the impact studies on these structures. That is the idea. And periodical maintenance of the accumulated silt for the recharge wells. That is also one of the challenge. For that we and the replication of this model across the water stressed regions in India can definitely help for India's water security and sustainable development goals. So yeah. Thank you so much. That's all from my side. I'm open for any questions here.
Question, what are the depths of the bore wells here?
Yeah, it says a bore well is only 20 feet. But recharge bore well, it is 300 meters. You are asking about the recharge bore well or
the regular bore wells in these areas are only 20 feet?
No, I such we have seen all now recharge bore wells are there. No recharge wells. It's a old thing. They are going up to even 100 feet also. More than that. More than 300. But what we have done, the 6 recharge bore wells have been gone up to 300 meter depth only. Where we have stuck with the aquifer systems. Actually, we using the geophysical surveys, I could able to see that where are the fracture zones are available, where at what level of depth the aquifer system is available. But maximum depth we have gone is up to 300 meters. Yes, recharge bore well. Yes, please.
Yeah, you are a geophysicist.
Yes, sir.
I can ask you a technical question.
Sure.
Say at 200-meter depth, can you identify a 2-meter thick recharge, 2-meter thick fractures?
No.
5-meter thick fractures?
That depends upon your resolution of your geophysical survey. If I could able to use the 2D ERT of high resolution, yes, I may be. But not sure. That depend upon the contrast, as you know.
Is it a correct statement that at 250-meter depth you can identify the fractures?
Yes, we have located. Actually, I have maps also. We have geophysical survey. I could see at least 2 fracture systems, fracture zones. Yes, that is for sure. That's where I was there. Actually, when it is not there, we were not constructing the recharge bore wells at all. We are abandoning that one.
Thank you. That's all.
Yeah. Thank you. Yeah, thank you.
Thank you so much, Mr. Sahadev, for sharing those experiences. I would like to invite our next presenter, Ms. Yamini, who's a student from CEPT University. She will be presenting online, and her topic would be Varsha Sanchay Yojana, Rainwater Harvesting Management Plan. Yamini, can I request you to please limit your presentation to 7 minutes so that we have time for question and answers. Thank you. You can start now.
Sure.
Yes.
So good afternoon, everyone. Today I'll be presenting my project, which is Varsha Sinchay Yojana Rainwater Harvesting Management Plan. This is a quick overview of today's presentation. And so for the background, it is evident that India is and about 34% of Indian population resides in urban area. And as we all know, only 0.7% of fresh water resources available, but only 4% of water is available for the 18% of world's population, which is India. And so with this, we identified that there is a huge water demand gap, and which has further resulted in extensive water development. So with this project, I aim to focus on enhancement of white sponge efficiency through sustainable rainwater harvesting plan for the city of Rajkot. This project has the objectives to identify the regulatory gaps and to devise a strategic zoning plan, and also to create a centralized scheme to manage and provide reliable data, and also to create a sustainable maintenance and monitoring plan for a long-term sustainability. So the methodology includes baseline profiling, where I have conducted almost 20 plus case studies internationally and nationally under these given parameters. And further, we as a team of 23 students conducted a demand assessment and supply assessment with KIIs, SDGs, etc. And then further, we proceeded to gap assessment, where we did identify technical, financial, and also institutional gaps, and with which we have come up with our own vision and strategies for the sector. And based on this, I have identified my project, which is based on rainwater harvesting, and for which I have developed a sponge evaluation framework for the city. And also further, I have come up with strategies based on multi-pronged approach. So for the project background, in particular to Rajkot, Rajkot is a city it has inadequate amount of stormwater infrastructure, low annual mean rainfall days with high intensity rainfall, insufficient water supply, but also very poor water conservation practices. And as it is rapidly urbanizing, I have intended to utilize the urban into a vital resource to harness the power of urban growth, and also to unlock the rainfall as a huge potential for sustainable, resilient future. So the part one includes a sponginess evaluation framework, where I have defined the sponge capacity as city's potential to absorb and retain rainwater, whereas sponge efficiency as the measure of city's performance, how the capacity is being utilized. And the respective colors which I have divided into is blue sponge, which includes water bodies, green sponge, which includes the green areas, white sponge, which would be the built urbanized spaces, and green sponge includes the roads. The detailed features I have given below, and based on this formula, I have calculated the individual sponge capacity for each of the sponges. And further, for the limitation of my project, I have conducted the efficiency assessment based on the parameters provided, and I came to identify that sponge efficiency of roughly 4.1%, which shows there is a huge potential to utilize the existing white sponge capacity in Rajkot. So further, I have also tried to understand the existing legal and institutional framework in terms of national, state level, and also limited to city level to schemes and missions as well. And also the findings from case study and international practices has revealed the existing gaps in Rajkot, including the system like a Bhagidari scheme, where there is a lack of long-term approach, and also data gaps, and which further led to the 5 major components and recommendation of this particular project. The first component includes institutional reforms, where I have provided it in 3 levels. Where national level, as we all know, we have only 2 indicators for service level benchmark when it comes to stormwater management, while other sectors do have 7, 9, and 10 respectively. So I have proposed new service level benchmark, 4 new indicators, and I am currently working on providing the rationale and also method of reliability assessment for these. And further, I provided state level recommendations in terms of development control regulations, and also how to make it topography and tailor-made regulation based on soil strata. And on city level, I have divided my strategies into.
Sorry, can you close in next 2 minutes? Thank you.
Sure. On city level, I have provided strategies into brownfield and greenfield, and further the bodies which shall be assisting to provide the same. And the next component includes the establishment of rain centers on 2-tier level, where on the higher level, it would be mostly project approval, whereas in these sub centers, they will be acting as the operationalization and implementation body, and how both the bodies shall be connected have also been detailed out with whichever the scheme. And I have also worked out on how long will it take to operationalize this particular institutional mechanism under which scheme. And further, I have tried to create hydrogeological zoning map. I'll quickly go through as due to time limitation. So I have worked upon geomorphology and geological strata for each walls. Further, I created a simple decision-making matrix, and I overlaid it with groundwater level development with the Raj code, and I have identified that west zone is exploited more. And further, I understood that since west zone is in the need for immediate intervention, I have proposed my pilot, particularly in west zone, where it would be creating a rain garden in the west zone, and I also provided the selection criteria for the rain gardens and the design parameters to establish the rain gardens for the same in that particular area, and also how can we make it to be a revenue generating model, like including other interactive sources as well. And I also understand that there are certain risks involved with this project, like inadequate maintenance requirement, community awareness, and data accuracy, etc. For which I have also provided a roadmap for long-term sustainable operation, like renewal of rainwater harvesting certificate, community engagement through IEC activities with NGOs, SSGs, etc. And as a part of IEC material, I have also tried to create a brochure which shall be used to create awareness in the respective rain gardens for the people, and this will be very tailor-made as per the zone and as per the built for. And this is a model which ULB can adapt for the further utilization. And with this, I have intended to capture, conserve, and conquer the rainwater for Rajkot. Thank you.
Thank you, Yami. I request the jury to post their questions again. Any questions or comments?
Hi, sir.
Yamini, this is your PhD work?
No, sir. This is part of my studio project of 3rd semester, Masters in Urban Infrastructure program.
How you have accounted the leakage from your water supply pipelines, which generally remains between 15 to 20% of the total water put into pipe, and that must be a huge volume for your Rajkot city.
As a part of this project, NRW was not calculated, sir.
You have not taken into account, it's a considerable volume. It is entering into the soil.
So NRW, yes, I understand that NRW is important aspect where there is a huge loss of water as well. But as a part of this project, under the parameters, I have considered for my assessment, I have considered the houses which has rainwater harvesting establishment,
That's a different
and
issue.
also which is.
That's a different issue. Okay, thank you. Thank you. Nice presentation.
Thank you, Ms. Yamini. Yes, and now we'll move on to the next presenter. So, the paper is submitted by Mr. P.T. Giridhar and his co-author, Ms. Ragini, who will be presenting it online. He's Assistant Professor, GFGC Department of Collegiate Education, Handal in Karnataka. The topic is impact of rainwater harvesting in farm ponds and groundwater conjunctive use, empirical insights from semi-arid regions of India. Ms. Ragini, you can start off and you have 7 minutes to finish your presentation.
Good afternoon, all. I hope I'm audible.
Yes, you're audible. Loud and clear. Please go on.
Thank you. First of all, good afternoon, all. I'm Ragini. I'm a PhD scholar from Division of Agri-Economics, IARI. Here, I welcome you all to a presentation titled Assessing the Impact of Conjunctive Use of the Rainwater and Groundwater, Empirical Evidence from the Semi-Arid Regions of Karnataka. First of all, the study has been focused in the state Karnataka since it has showed an average decadal fluctuation of 4 meter below the ground level decline, and it has been found that around 90 taluks in the state are affected by the drought in the past decades, and all the taluks were listed as drought prone. And the agricultural vulnerability index to climate change identifies the semi-arid regions of the Karnataka as very highly vulnerable. So based on this, we can say that the Karnataka is highly vulnerable to groundwater crisis, and with respect to agriculture, this crisis intensifies. In this realm, it becomes very important for this semi-arid regions to harvest the rainwater judiciously and use them judiciously for the irrigation, which helps in increasing the productivity, and it also helps to recharge the groundwater which is already declining. So coming to this, the concept of rainwater harvesting, it involves the small
Slide is not changing. Slide is not changing. Please change your slide.
Can you please change your slides and bring it in slide show mode? I think it's not moving.
It's in slideshow only. It's changing now.
Yeah, if you can use it, run it on slideshow mode.
Sorry for the inconvenience. Coming to the, I had presented the Karnataka's picture with respect to the groundwater vulnerability and the drought-prone status. Then coming to the concept of the rainwater harvesting, it uses the small-scale structure to collect the water, which can be used for either domestic use or the irrigation purposes. Thus, it also serves to convert the blue water into groundwater. So, with this background, the study has been conducted with an objective to estimate the impact of conjunctive use of the water in farm pond and the groundwater on income due to changes in cropping pattern. For the purpose, the study has been conducted in the state of Karnataka by considering 4 dry zones out of the 5 dry zones in the states, and within each dry zones, 2 districts have been selected, and within the districts, the taluks were selected based on the data of farm ponds constructed under the various schemes like the Krishi Bhagya Yojana, MG Narega, and National Horticulture Plan. And then to capture the diverse usage patterns, the data were collected from the different plots like the farms which rely only on the farm pond as a sole source of the irrigation, and the farm and rain-fed farms, and the farm which depends on the groundwater, that is the borewell irrigation as a sole source, and also the conjunctive use, that is the farmer who depends on the irrigation on both the farm ponds and borewell irrigation. And also, given the higher incidences of the discontinuance of the farm pond in the state, the survey has been conducted and on such plots also, that is discontinuance plots also, to assess the reasons for discontinuance. And then we have applied a endogenous switching regression technique because it deals with the self-selection bias, and additionally it considers the influence of non-observed factors in assessing the impact. And then the results were compiled in the various combinations to have a to have a correct impact. So the results were made in three combination. That is, the first combination is the forms which depends only on the form pond and versus the rain fed forms as a control, and then the forms which uses the conjunctive use versus the forms which depends on only form pond as a control. And under the third combination, we have a conjunctive water use against the forms which uses only the groundwater as a source of irrigation. Under these combination only we will be assessing the impact. So we have a results under these three streams. Under the first result, that is the form ponds, under the first combination, that is the form pond as a treatment plot versus the rain fed plots. Before assessing the impact, the falsification test was carried out to assess the fitness of the instrumental variables. Here we found that the visit to extension centers and the participation in the training, which we used as an instrumental variable, were found to have a positive influence on the adoption, and they found to have a non-significant impact on the non-adopters' income. So they found as fit to use them as a instrumental variables. Then then we have considered the various variables to assess the influence of the variables on the adoption of the form pond under the various heads like the household characters, social capital, and plot level characters. It has been found that the education and having a alternative source of the income and visits to the extension centers and the interaction with the peers and the friends with respect to water saving technologies, then the plot level characters like the slope of the
Sorry for interrupting.
Water runoff of the plot are found to have a positive influence on the adoption. Coming to the impact of the form pond, it has been found that the adopters of the form pond have 48,000 of the income against the rain fed farmers which had 34,000 of the income. ATT, average treatment effect, was also found to have a higher effect on the form pond. Then coming to the conjunctive use versus the form pond forms, it has been found that adopting a conjunctive use increases the income of the adopters by 37%, and it had a potential to increase the income of the non-adopters by 46%. The negative transitional heterogeneity effect is here. It is indicating that if the non-adopters, that is only the form pond adopters, if they had gone for the conjunctive use, they would have benefited more. Then under the third combination, that is the conjunctive use versus only the groundwater dependent farmers, it has been found that the conjunctive use has increased the income of the adopter farmer by 33%.
You lost your audio there.
Then under the then we could assess the. Hello. We could able to assess the impact on the cropping income due to the changes in the cropping pattern. It has been found that the cropping intensity was assessed for the various combinations. Then it has been found that the cropping intensity of the rain-fed forms were 113%. Hello.
Can you please wind it up quickly? Can you close it?
Hello.
Yeah, can you hear me?
Yeah, am I audible?
Yes, we lost your voice in between, but I request you to close out quickly.
Okay. The form pond were found to have a conjunctive use were found to have a increased cropping pattern. That is, cropping intensity were found as 154%, which is highest among all the combination. And then coming to the economic impact of the farm pond, it has been found that the land waste due to the farm pond was only 315 rupees. But the additional income due to the adoption was found as 16,363, which is comparably higher than the loss of the revenue due to the wastage of the land due to adoption of the farm pond. Then for the groundwater dependent farmers, it has been found that the land wastage the loss of the revenue due to land wastage was only 679 rupees, as against the increased income of 6400. So it all this analysis is showing the economic impact of farm pond as a having an extra source of the irrigation in the agricultural field. Thank you.
Thank you, Ms.
Hello.
Yeah, thank you, Ms. Ragini. We are just waiting for the jury for any questions on this process.
Thank you so much, Ragini, for this. You've done quite a detailed study on this. Just a basic question. When you talk about farm ponds, what is the source of filling these farm ponds?
Ma'am, source of water for the farm ponds.
That fills the farm ponds, yes?
Ma'am, rainwater.
It's rainwater, okay. And okay, that's fine. And with regard to these wells that were, they were also using well water, groundwater for filling, for irrigation.
Yes, ma'am. The conjunctive use means the
Conjunctive
borewell
use.
irrigation.
The borewell was also being used. And you mentioned that the third group of farmers were also those who were not able to use groundwater. You had the three types. Only farm
Yes, ma'am.
ponds,
Only
conjunctive,
groundwater.
and the conjunctive use. Yeah. So
Yes, ma'am.
those who were using who were groundwater dependent, they could see potential benefits with the increased. There was what is this? Conjunctive use was using both, so there are better returns as compared to those only using groundwater. Okay.
Yes, ma'am.
Ragini, I have a small question.
Yes, sir.
Your benefit that you have given 16,000 rupees per hectare, that is by maintaining the same crop, or they have changed the crop also?
Sir, cropping intensity will increase, not the cropping pattern.
Okay, cropping pattern is same, intensity has increased. Okay, thank you, thank you.
We have assessed the intensity also. That was in last slide. I don't know whether that was visible or not.
Okay, nice presentation. Thank you.
Thank you.
Cropping.
One last question, Ragini. For the water in the farm ponds, for how many seasons could it supply water? One season for the Kharif, for the Rabi?
Ma'am, Kharif it will be definitely because of the rainfall. And depending on the size, it will sustain even the next season also.
Thank
Size
you,
and
Ms.
the amount of rainfall.
Yes,
It
sure.
varies actually.
We got that. Yes, thank you so much for your presentation. We'll circle back to you later. So our next presentation would be online by Ms. Asmita Saha from WaterAid India. The topic is governing the invisible, data-driven community-centric strategies for rural groundwater sustainability in India. Has she joined in? Ms.
Hello.
Asmita, yeah, now we can hear you.
Yeah, I will just quickly share this slide.
Sure, you have about 7 minutes for the presentation, and then we would like to spend some time for question and answers from the jury. Good luck.
Just a second, I'm trying to share it. I I think Ragini's screen is still visible. So I'm unable to share my screen.
Can you try it now?
Yeah. Sorry, is it visible?
Yeah, it's visible now. You can go on.
Yeah. Hello, everyone. This is Asmita Saha, and I'm going to present my paper on governing the invisible data-driven strategies for rural groundwater sustainability in India. So I will quickly give some context about the paper. So India is an agrarian economy with 47% of its population relying on farming and allied activities, which means that their livelihoods are very directly and immediately impacted by the access of the resource. And this is why, with the increasing unpredictability of the resource access, the dependence of groundwater is increasing, especially in rural India. But there is a wide disconnect in this demand driven approach where the community is disconnected with the resource, in the sense that there is a disconnect between community and understanding the resource. And to fill this gap, various approaches, innovative approaches are emerging. And the paper specifically looks at these approaches from the perspective of understanding the type of granular data that is required, identifying sustainable and contextual strategies, and exploring collaborative approaches that can nudge behaviors change, strengthen local capacity, and encourage inclusive participation. So, the methodology of the study. Here, the literature review focuses on three types of review: reviewing government policies, and then conceptual reviews that focuses more on theoretical aspects, then empirical reviews that focuses on actual case studies, project implementations, and then there are aspects of field visits and interaction with the community, technology, and CSOs. And then finally, data analysis, the types of data that are used by these innovative approaches, the scope of adding different types of data, and how to develop a broader framework that helps such innovative approaches to be implemented. So this is a broad framework of the study. In one side, we can see broad challenges, which includes overexploitation, deteriorating quality, climate change, equitable distribution, lack of localized or granular data, and local resource constraints. Then we look at the primary stakeholders that hold the local governance, which are broadly defined into community and local governance. But the study particularly also talks about the importance of civil society organizations and social entrepreneurs and innovators to improve local governance. And the approaches that they use include these aspects of science, participation, and regulation, keeping in mind that science not only includes technical aspects but also the social to understand the socio-economic complexities of the region. So, to make an innovative approach successful, there are these three aspects. So, all these successful innovators have used these three aspects of data, interface, and community engagement. So, if we look at data, it can be broadly divided into two: collected data and analyzed data. Collected data are data related to understanding the context, assessing the risk, and also analyzing very particular type of problem that the community is facing. And then the analyzed data is location restrictive and can be generated daily, monthly, and also weekly. And there are some broad analysis which includes water demand, water supply, water balance, and there are more detailed analysis which includes rainwater harvesting and recharge sites, adopting suitable irrigation practices, crop selection, and economic and resource incentives of efficient usage. So moving next to the interface. So while developing a technology, a software, these successful software kept these following things in mind. So the outputs were language friendly, interactive, easily accessible in different mobiles and devices, and had daily, weekly, monthly updates, has repository which can be accessed online and offline, and various community engagement approaches which focused on capacity building, gender sensitivity, including women and women specific trainings, sensitizing on how to use funds, how to self regulate, how to encourage monthly interactions, engagements like monthly meetings, and so on.
Ms. Asmita, so can you please wrap up in next 2 minutes? Thank you.
Yeah, sure. So these are some of the community engagement practices that were used. And then these are some of the case studies that the paper talks about. Here, there is a case study of Aquadam and from Maharashtra. And then there is a case study of Farm Price by WOTR. This Farm Price specifically uses mobile application, while Aquadam process is more prolonged process which includes field hydrological mapping, recharge planning, and so on. So here we move on to the detailed case study. Here we can see snapshots of the software. We can see how interactive it is, how easily we can understand what is the scenario of this particular village in Chittor district. So now moving on to the recommendations. So during this study, we realized that decentralized groundwater management requires community involvement, and to make this invisible resource visible, there is a requirement of granular data, which is simple and easily accessible, and people can use to make informed decisions. And then there is a huge potentiality for startups, social innovators, and civil society organization to bridge this gap between community and science. And finally, there is a huge scope for equity and gender inclusion with this approach. So that was all from my side. Thank you.
Ms. Asmita, over to the jury for questions or responses.
Asmita, very nice presentation. When you were able to interact with the communities to know how they understood the data?
Yeah, definitely. I got some opportunity. Actually, WaterAid is working with Ekatwam and is still working in the field. So, yeah, I got the opportunity to interact with the community in this process.
How did the community, were majority of the community being able to use the data? Because I understand it's on mobile.
Yeah.
And the penetration, yeah.
Sorry, please.
So since it is on the mobile phone, and are the majority of the community being able to access the data, or is it a few who own such because I understand you would need the Android phones and they're quite costly.
Yeah. So there comes the role of CSO. So these innovative platforms make very user-friendly solutions, but how much accessible it is to the community becomes in question. This is where WaterAid came in. So there were many parts of the community which couldn't access these information. So there are the reports, the weekly and monthly reports that are generated that can be printed out and circulated, and they regularly practice weekly and monthly meetings to discuss these information. So this is how they are practicing and dispersing the information within the community, and also kind of encouraging them to go themselves and use the data, because just giving access is not the only solution. It should be part of their everyday practice. So this is where the role of CSO comes in.
If I may,
one last question related, because since you're looking at the community involvement in managing its groundwater, what were you able to observe any impacts in any of the communities managing their groundwater through the use of these technologies?
Yeah. So some impacts were observed. It has been implemented for like a year, so still very early to say. But some small changes that has happened in the community is changing in irrigation style, and also water rationing, better water rationing, and developing better groundwater recharge structures, taking the support of CSO and other sector specialists to develop it, because they also have access to all different partners now. So, yeah.
Thank you so much, Asmita. Just one last question from my end, if I may. In all these studies, have you anywhere come across the local SIRD institutions also being involved, or any academia involvement? Because that could be one good example, maybe, to bridge this knowledge gap and to provide simple kind of trainings on ground. Any such experiences you've come across in these studies?
Personally, I haven't come across these experiences, but I have explored this idea in my paper, that how research institutions and educational institutions can contribute. So, yeah.
Even government training institutions can play that role in here. So thank you so much for your presentation.
Thank you.
Thank you. So we have our next speaker also, who is already connected. We have Mr. Amitava Roy from Manav Rachna International Institute of Research and Studies, Faridabad. And the topic would be the challenges and options towards optimal management of freshwater use in oil or gas upstream industry and safe disposal of effluents. Over to you, Mr. Amitava, and please request you to kindly time your presentation for about 7 minutes so that we have enough time for question and answers. Thank you.
Yes, thank you so much. Am I audible?
Yes, you're loud and clear. Please go on.
Okay, so actually, I am oil gas explorationist. I have been in this field for the last 43 years. So I had some time. So I thought, why not tell my story to everyone? So quickly come to the topic, that these oil and gas exploration, why it is under the discussion. That is because that fresh water is only 1% in this world for our use. Out of total 3%, the remaining 2% are above the perpetual snow line. So mostly in the snow peaks and mountains, which are beyond our hold and reach. So there are many industries which are using or overusing a lot of fresh water. This is the least. That mostly the culprit is agriculture and animal agriculture. Whatever is required, it is using more than that. Energy industry, including the oil gas, where actually I am belonging, and the remaining construction, domestic, and all this. And what we require actually, it is on the right hand side. That is the test, any test well to unconventional energy, hydrofracturing, and all these water injection, And so we are looking at uh, a scenario where the present oil and gas, which has been discovered more than 200 years ago, are coming to a the an end almost, because the all the great reservoirs, they have all been produced. All the different types of giant reefs, uh, giant beach sands in Saudi or in US or in Canada, even in our own Bombay High, it is all mostly in the sixth stage or in the tertiary stage. The very last available oil is under production. But the stakeholders, because of the demand, high demand in the industry for energy and hydrocarbon, they have shifted their focus towards the unconventional energy. And for unconventional energy, two things are must. If we have to produce oil profitably, that is horizontal drilling, that is instead of, you can see this picture here, instead of the vertical well, contemporary vertical well, we'll drill a vertical well or a directional well and then go horizontally and do the fracking of the formation. I just because this is basically a forum where a lot of water scientists are there, I must tell that even in some places, in Arizona, Nevada, California, even probably in our Rajasthan desert also, there are hydrofracturing used for getting fresh water for drinking water purpose. So, because we are shifting our focus towards unconventional energy, so there are two things, two challenges here. One is how to mitigate, how to minimize the use of so much water for this drilling and hydrofracturing and water injection, which are the must for oil gas exploration in unconventional, as well as falling and depleting reserve of conventional, and the huge effluents generated in the process, especially as post-drilling wastewater or post-hydrofrac flowback and seen production or seen water injection produced water, together they are forming the effluents. They need safe disposal because they are carcinogenic, they are very toxic, and we cannot afford to pollute our environment and make our environment unsafe, especially in view of the the UN charter, sustainable development goal, charter number 6 and 7. 6 is for fresh water and 7 for clean and affordable energy. So I must tell you that conventional deposits, which you can see in the slide here, are easy deposits, and along with that there are coal bed methane deposits. But tight gas and shale gas, they are deep, and they need a lot of efforts to be produced. So this why this so much fresh water is consumed, because this hydrofracture or water injection or special drilling like horizontal drilling, they need a lot of water in million of gallons. A hydrofracturing well requires about 2 to 16 million gallons of water, and average 6 to 7. Even in India, it is required in 6 to 7 million gallons of water. And because we have to do hydrofracture, we have to make sleek water or fracture gel, which is containing lot of water, chemicals and propane, and that is to be pumped at a very high pressure to the fracture formation and open up the artificial porous rocks, and then put the sand inside so that they give us a pseudo permeability, and that allow the oil and gas to flow from there. So this again I must repeat that this issue is how to reduce or overuse or misuse fresh water, because in the euphoria to see the first drop of oil, we get over clearing the actual allotted water, and we really use water which is not required. We can do many experimental things like replacing the hydrofracturing. See the last point number 6, we are already on research and field application that we can replace the fracturing of hydrofracturing by waterless fracturing or LPG fracturing or air drilling or wherever there is gas is available by gas injection. But this is not established on a commercial large scale so that we can go all out for replacing the water. So we have to mitigate that to save our fresh water. And at the same time, we cannot pollute the environment by unsafe disposal of the effluent water into the environment. So earlier there were disposal used to be made in deep wells, but it is now not encouraged because of the high pressure and very deep around 3000 meter, more than 1200 to 3000 meter, there is some low scale seismicity which creates cracks and fractures, and these polluted water seeps or leaks or leaches into the groundwater and contaminate them. So, in conclusion, I must tell you that qualitative treatment of wastewater is costly. So, the procedure of what? We have to recycle. We have to treat and recycle these effluents through various treatment procedure, and it has to be cost effective. Because if we have to, address each of these pollutants, how to balance them, how to make them soft, lot of cost is involved. So presently, me and my guides, we are into, do some kind of meta-analysis. The process is on, and how to mitigate the use of software, fresh water, at the same time recycle, so that the recycling effluents, if we can make it into common water grade, which cannot, make the oil gas equipments or oil gas formations or reservoirs, plug plug friendly. That means there should not be any plug, there should not be any skin, so that the production is not hindered. Then we can totally replace these effluents with treatment, and we can reuse the same in the nearby wells. The three main culprits are water injection, drilling, and maximum is hydrofracturing. So we can totally replace them, and so that these two basic problems, that is, replacement or mitigation of fresh water, that is being taken care by this recycled water by reusing. I have seen that in a couple of fields, one in India and another one in Canada. So where I work also. So there is no question of any disposal because there is no effluents. All are recycled. But that was a shallow well. But in case of deep well, the cost will be involved. So that is the very first point I have written, that it has to be techno-economically viable. So to implement a lot of cost cutting. And so AI will be of help if we know that the fuzziness or the uncertainty of which one is required to balance the other one, the effluent. So that will give us this an edge over the total expenditure. So finally, if we implement some, this particular process by recycling followed by reusing, we need policy. In fact, in policy scenario, both US and developed states and India, they were poor. Rather, I would say earlier the policies, earlier than 2013, there was hardly any, federal government policy in US. But in India at that time, there was a policy of normal oil gas exploration as well in 1956, 1959. When 1956, it was Geological Survey of India who used to have a mineral division and a coal and oil and gas division. They used to look after this policy implementation, whether the drilling and their effluent is on right path. But I have joined this industry in 1981. I have not seen much of control in effluent disposal. They used to throw it to anywhere. There used to be barricade. There used to be strike, and then again something had to be managed, and then it is again started. So no longer that kind of funny and random situation exists these days. There is very definite policy. since the unconventional era has come, 2013, there is a coal bed methane policy in both US and in India. 2014, there is shale gas policy. Same again in India, Canada, US, Saudi Arabia, Australia, Kuwait, and in also a couple of European countries like Germany, Poland. So I suggest, our team suggests, fresh regulation, legislation policy, implementation, and stringent monitoring should be in place for environmental safeguarding of effluent disposal and unwarranted depletion of freshwater resources. So this way, this cyclicity of putting the water once for drilling and hydrofracturing and water injection, that will continue. And time to time, maybe we have to, because of the natural evaporation, loss through evaporation and during transportation, we have to replenish somewhere the required technical water by fresh water. Otherwise, there is if we can cost cutting is the main important. If we can do that, there is nothing involved. No other problem is involved. Like if we replace hydrofracturing with LPG fracturing, the LPG is itself very explosive gas. The whole infrastructure of hydrofracture cannot be readily replaced by LPG fracturing. Otherwise, technically, it is very good, much better than the water, but it is not so easy. Yes, air drilling. Air drilling, it is very good for uh, coal bed methane or some coal drilling, but it is for heavier rocks where there is lot of stones and boulders as cuttings are to be taken away to the surface from the underground. It is not successful. Similarly, for gas injection, wherever there is no gas, we cannot replace water injection by gas injection. So these are the hindrance to implement these in commercially in a larger field. So that's all. I think our research will throw much more light in this direction in our future research. So, but till now, this is our suggestion, humble suggestion, that the regulation and the policy should be such that the recycling procedure can be totally implemented and the reusing is done to replace the so much million gallons of fresh water. Why so much million gallons? Drilling does not require so much water, but because the focus has shifted towards unconventional to make a affordable energy, you have to have hydrofracturing and which requires a lot of water. Thank you so much.
Thank you, sir. Thank you so much. Over to the jury in case of any questions or comments.
Yeah, thanks, Dr. Mr. Roy. Excellent presentation. You highlighted importance of using water for hydrofracturing. So I know that the quality of water which we normally use for hydrofracturing, it should be good. But are there any water quality criteria for hydrofracturing?
Yes, sir. Actually, hydrofracturing, before this suggestion, I have studied, a lot of papers. I have talked to many industry people because of my association with them. But they used to do, mixing. That is the hydrofracturing flowback water. They are mixed with fresh water, and then it used to be put into the well and fracked. So I have already mentioned briefly in my presentation that actually gives the well generation of screen factor, then some the reservoir to well connection path.
Yeah, Mr. Roy, sorry to intervene. I just wanted to know what are the parameters which we need to consider for hydrofracturing. Means, do any requirement that it should not contain this much of oil?
Yes.
It should not have like this much of tedious electrical conductivity or hardness, something of that
Yeah.
sort.
Yeah. Actually, in fracturing, the fracturing company, they have a contract with the operator of the well that they will not reveal more than 10% of their chemical because that is their business secrecy. So whatever 10% chemicals are known from their thing, their given literature, as well as there are NOCs in India and abroad. They actually reveal some of the ingredients and the chemicals, but they mostly they engage, say, Baker Hughes or Schlumberger or say Halliburton for their fracture job. Mostly these companies are having a monopoly, but in India, ONGC also has got a stimulation team. So I recently visited Gujarat and Rajasthan, and I have collected some samples, and from that I have also done water analysis. It is part of another paper, but in this paper I must tell you that you see the fracture liquid, fracture gel or slick water, they are part of water, fresh water, no other water, fresh water with chemicals. Chemicals are mostly 1 to 1.5 to 2%, and about 6 to 7 million ton of propane. So what they do under
Mr.
a,
Roy, I'm sorry, I'm yet to get a response to
I'm
my.
coming to one by one. You have asked me about the
Yeah, if you can kindly be very precise, I just want what should be the, say like,
okay. So these chemicals.
listen to me first. For drinking water, we have something known as a BAIS 10500 2012. It specifies some 80 odd parameters. For drinking water should comply with these water quality parameters. Do you have like similar criteria or water quality parameters for water which we use for hydrofracturing? So if you can give an answer in so like
So
that will
I
be
have told you that if it is not fresh water, so that fresh water, it should be free from alarming TDS content. There will be possibility of skin factor developed in the reservoir and well connecting path. That means if you are actually opening the permeability path for the tight reservoir, but if you put other than fresh water, there will be skin development. That will again make hindrance to the path of oil and gas to come
No,
into the well inside.
no. 1 minute, 1 minute. Dr. Roy, what he's asking
I am Mr. Roy. Yeah.
Mr. Roy, he is asking whether there is any regulatory framework or guideline exist in India. I think no.
Yes. Yes. It is existing. Of course, hydrofac, other than this water use, they make a lot of problem. Noise pollution, air pollution,
No, no,
seismicity.
no,
So there are
no.
total
Please,
control on hydrofacturing.
please. The question is whether any guideline exists that the water to be used for hydrofracturing should be less than 500 TDS, less than 20 calcium, less than 50 magnesium.
Yes.
That's all. It is not
Yes.
there in it.
All these are existing. All these are existing. I have done 6 sample analysis, which are not part
No,
of this
no,
paper.
guidelines. You are not getting whether any guideline is existing in India. Like Guru.
Guidelines means there is a policy of how to frack under HELP, help. So it is available with the Directorate General of Hydrocarbons
Don't we
website.
have any published standards, sir, to make it easier? Any published standards, the way we have sewage discharge standards? I think
No,
that's what
madam,
we
no
are.
published, but in the
Yes.
government website of
Policy
Ministry
is
of
not.
Petroleum and Natural Gas, there is their technical hand, Directorate General of Hydrocarbons. So it is the dgh.org.in. So there you will find the HELP policy under which you can get the unconventional energy, and from unconventional energy, you can go to this fracking or water injection or effluent disposal policy separately.
Sure, sir. Thank you. So,
Or on a personal one-on-one basis, if you request me, I can also
sir, I
get
think
you one.
discussion can be taken offline. Any further questions?
One more question is anywhere in India the gas fracking has been initiated.
Yes, many, means hundreds of wells. I have attended 3, 4 in Durgapur area, Durgapur 2, Raniganj coalfield area 1, and Karanpura coalfield area 1 and 2. 4 hydrofracturing well have been taken up by ONGC, and the fracturing has been done by Slumberger. So
Okay.
there the
Thank you.
gasability was not so good. Thank you so much.
Thank
Thank
you
you
for
so
that
much, sir, for your
presentation.
presentation.
Yes. Yeah, thank you so much, the organizers, for enabling me to
Sir, just
present
one
this.
request to the jury. We have 2 more last presentations online. Should we just finish it off? We can wrap it a bit earlier. Sure, ma'am. Sure, we'll take care of it. And we have the next presenters also lined up online. So may I request for the next session, which is on enhancing water quality through nature-based solution, harnessing ecosystem services for sustainable water management. On this topic, we have Dr. Karishma Maheshwari, a research associate from Manipal University, Jaipur, who will be presenting on the topic integrated microalgae solar evaporator system, a circular economy approach to sustainable RO reject water treatment. Dr. Karishma, I would request you to time your presentation in 7 minutes so that we have ample time for question and answers. You may begin your presentation.
Am I audible?
Yes, you're audible.
Is my screen visible, ma'am?
Yes, it's visible. If you can display your presentation. Yes, Dr. Karishma Maheshwari.
Very good afternoon to all the organizers and conference presentation organizers. The presentation entitled Integrated Microalgal Solar Evaporator System, a Circular Economy Approach to Sustainable RO Reject Water Management is presented by Dr. Karishma Maheshwari. I am Research Associate in a DST WTI sponsored project from Department of Biosciences at Manipal University, Jaipur. This project is led by Dr. Monica Sogani, an Associate Professor, Senior Scale in Department of Biosciences at Manipal University, Jaipur, with the co-author of Dr. Zainab Syed, a research project staff from Department of Zoology at University of Rajasthan.
Can you please play the slides on slideshow mode? It will be easier to. Thank you.
Yes, ma'am. Is it visible now?
Not on slideshow mode. Maybe you
Is
can
it visible,
continue.
ma'am, now?
It's visible. You can continue. Thank you.
So, freshwater scarcity is becoming a growing concern due to rapid industrialization, urbanization, climate change. RO reject water, characterized by high salinity and pollutant content, represent a significant environmental challenge. The content of RO generally
Sorry, can you
represents.
also move the slides as you speak because it's just displaying the title slide.
Ma'am, there is an internet issue, I guess so, because I have changed the slide.
Okay, can you just reshare? It might help. Stop sharing and reshare again. It might help.
Okay, ma'am.
You can switch off your video to conserve some bandwidth. Then the screen might be clear if there's a network issue.
Is it visible now?
No, not yet.
Is it visible now, ma'am?
Just opening the screen. One moment. Yes, better now. Please go ahead.
Okay. So it's become a very significant issue that every country, every state, and everywhere globally, RO is adopted as a primary source for supplying of treated water without any contamination, fit for human health. And this, therefore, I have incorporated this study, and using the high salinity reject water as a development of biomass also, and simultaneously treating the reject water also. The study introduces an integrated microalgal solar evaporator system as a nature based solution for effective RO reject treatment. So I have collected the reject water from various spots which is presented in MUJ, and the objective is to study the effect of microalgal solar evaporator system, which effectively is treating this reject water. So I have collected the sample from hostel, which is situated in Manipal University itself, and characterized the water sample for analyzing TDS, calcium, magnesium, sodium, fluoride, chloride, sulfates, nitrates, alkalinity, pH, electrical conductivity, phosphates. And I've collected the samples in the same way from lab block also and academic block also, and mixed them. I've collected 10 liters of sample from all the spots and averaged them by mixing it in the feed tank. Wherein it was recorded that 1571 milligrams per liter indicated a huge salinity, and it represents the necessity for the treatment. So the microalgal system consists of the concept of the key including the key components such as solar evaporator, a microalgal reactor, and a recirculation pump which helps recirculating the biomass containing reject sample. The solar evaporator is designed with a corrugated surface which can be visible as represented in the figure also, which is inclined at 10 degrees angle to optimize the flow dynamics and improve the system performance, so that the biomass is deposited on the surface of corrugated surface. The study focuses on Chlorella soricana, a resilient and highly productive microalgal species. The growth condition were optimized to maximize biomass yield, with a specific emphasis on light exposure and carbon dioxide uptake to enhance the photosynthetic efficiency. The actual diagrammatic representation which is seen on the slide. So the selection of Chlorella soricana is basically because it is highly salt tolerant, and it can take the nutrients from reject water to grow, and will get a decent amount and proper biomass also. So I have fed this collected water from the storage tank, and it revealed a good amount of percentage removal, wherein all the contaminants were significantly removed, including the TDS, which was under 500. That means it can be repurposed for irrigation purposes and feed to animal, and before other purposes, and serving the other purposes also, like flushing and mopping. And the obtained biomass was also characterized for other analysis like fame analysis and yield of biomass, wherein I have also calculated the kinetics, wherein it was analyzed that uh, the fit kinetics of this was pseudo first order kinetics, which reveal that it is having a good solute and solution interactions. So the biomass is utilizing the nutrients from reject sample for its uptake.
So here is the FAME and profiling of harvested biomass. The harvested biomass was analyzed for its fatty acids methyl ester composition, revealing a composition of 16% of protein, 22% of carbohydrates, and 62% of lipid. This composition highlights that it can be a potential biomass for applications in biofuel production and nutraceutical industries. So, I would like to conclude this study representing that it is an integration of wastewater treatment with biomass production, contributing to the circular economy by utilizing wastewater as a nutrient source. This reduces the resilience on fresh water for microbial cultivation and promotes sustainable industrial wastewater management practice also. There were certain few challenges and limitations which I faced, that there was salt accumulation, and for that regular maintenance was required, and scalability issues were there. So I have scaled up to a pilot scale plant, and for actual applications there were scalability issues, like we need to remodify the material with which the actual experimentations was made. So there is a another renewable energy integration also for enhancing the sustainability of the system, and there is also a possibility of biomass production from harvested algal biomass, which is obtained in the solar evaporator. as as on increasing the salt stress, we'll study further, and the long term sustainability can also be explored, and its stability could also be assessed by by applying various conditions to the system. So I have concluded that then it is the microalgal integrated solar evaporator can be a nature based solution for reject management and algal biomass generation also, which is depicting its sustainability and future pathways for scalabilities also. And I would like to acknowledge DST, as it is DST sponsored project and all the fundings are supported from DST. And I would also like to thank Manipal University for facilitating me all the facilitating me with all the equipments, and also University of Rajasthan for providing me the culturing parts. So I would like to thank you.
Thank you very much, Dr. Kalishmi, for this very timely. Any questions from
Yeah, thanks a lot. Very nice presentation. You know that use of microalgae in wastewater treatment is quite well established. And there are quite a few reasons for that, because the wastewater normally contains nutrients. Okay, and you also talked about say nutrients required for microalgae production. So did you analyze these nutrients in your RO reject water? How much was the concentration? Karishma, are you able to hear us?
Yes.
Karishma, are you able to hear us?
Karishma, was that audible to you? Could you get the question?
Oh, my question was not that difficult.
Parameters.
Sorry, can you please repeat?
Yes, sir, I'm able to hear.
Yeah, we lost your voice in between. So can you please?
Yes. Sir, am I audible?
Yes.
Yes, you're audible now.
Yes, ma'am.
Can turn off your video to
was not
conserve.
able to hear the question properly.
Yeah, can you switch off your video so as to save bandwidth? Please switch off your video. Should I repeat the question, Karishma? We are unable to hear you.
seems to be frozen. We're just trying to call her and check. There seems to be some network issue on her side. If she calls, maybe we can just share the question with her. So we have the last presenter. We'll just move on, and if any questions, we'll maybe circle back and get it answered from the presenters.
Yes, yes, sir. Please repeat the question.
Sorry, she's back.
Okay. See,
Hello?
you know that microalgae has
Yes.
been used extensively in wastewater treatment and
Sir,
primary
actually, I'm not able to hear and I'm not able to do anything. 2 minutes, I'll be joining from phone. Or maybe there is some issue, I guess.
It's okay, Ms. Karishma. I think we'll
Just give me 2
maybe
minutes.
get back to you with the question and get your response
Hello?
if that works.
Hello?
Hello?
Hello, ma'am. Am I audible?
Yeah,
Yeah,
you're
you're
audible.
audible. Yeah.
Yes,
Am
yes,
I
ma'am.
audible?
Yes,
Are
yes,
you-
sir. Now you are audible.
Okay. Okay, we'll try once. See, you know that microalgae has been extensively used for wastewater treatment, and there are some reasons for its application in wastewater treatment because it has
Yes.
wastewater has carbon and nutrient source.
Yes,
So
yes, sir.
how much nutrient you could find out in your RO reject water?
Sir, actually, microalgae basically needs phosphates and nitrates basically. So the reject samples which were collected basically had uh, huge amount of nitrates and phosphates.
Can
So
you give in numbers? Huge means
yes,
how
yes,
much?
sir. So 58 milligrams per liter was there in one sample, and 49 milligrams per liter was there in another sample, and 54 grams was there, milligrams per liter was there. On an average, I got around 54 milligrams per liter nitrate was there, and phosphates was around 13 milligrams per liter.
30.
Yes, yes.
You have to check your results. Okay. Fine. Second question is that you told that microalgae is tolerant to high TDS saline water. So how much the tolerance limit?
Sir, actually, there are certain species, and as you can, as I have also seen in the literature also, like there are certain levels of salinity. Like there are chlorella, soricana, like dulalina. They can persist seawater salinity also. And chlorella is basically for domestic reject samples, like moderate salinity it can handle up to. It can absorb salts and it can absorb nutrients. It can uptake nutrients from that water.
Yeah, dulalina is
Whereas,
fine. Yeah.
yes.
Yeah, got it. So
Yes,
you're
yes.
using those species only, which are found
Yes,
in
yes, yes.
saline water. Yeah,
Yes,
but
yes.
your water was only 1700 mg per liter.
Yes, yes,
So-
yes, yes.
Third is you're shown the results also. What normally happens in case of even wastewater also, we get very high HRTs, a hydraulic retention time.
Yes, yes, yes.
Yeah. So because when you scale it up, then the reactors which you'll require will be of huge size as against the
Yes, yes, yes.
system. So do you feel that how can we economize on these reactor size?
Sir, actually, I was searching for some sustainable solution. So, I have searched it out. So, I am thinking to scale it up, integrating it with constructed wetland. This setup will be integrated with constructed wetland. Like then and there, I would be making it more.
They will not serve purpose because the typhoid all which we use in concentrated may not be tolerant to this much of high TDS. So please ensure that it Okay, tolerate. So considered wetland may not be solution. Okay, because you're using your hostel water where the TDS is, your reject water TDS itself is less than 2000 mg per liter. If you go outside, then the TDS in reject water might be 10,000 mg per liter. So
Yes,
this
yes,
type
yes.
may not be tolerant to it. So look into
Yes,
it.
yes.
So not serve the purpose. We have concerns, and then we will see that how can we use combination of technologies. So the last one is that I'm not really convinced with your electrical conductivity data and TDS. Normally it's 0.6 to say 0.4 to 0.6 times. So TDS is normally 0.4 to 0.6 times of your electrical conductivity, whereas I think you have 6 millisiemens of conductivity as again, and the TD is around 1700. So please look into it. Okay.
So
That's the
actually,
suggestion.
I have not tabulated this electrical conductivity in the table.
But you're given electrical conductivity of in millisiemens. 6.6 twice you're given 6, sometimes 6.02, whereas your TDS level is less than 2000. Just look into your data.
Okay,
That's
okay. Sir, actually, I am also thinking to integrate it with helophytic species also. Helophytic plants would also help me to tolerate that kind of salts which are there in reject management also.
good. Yeah, thanks.
Yes, sir.
Thank you, Dr. Rajma. Thank you.
Thank you, ma'am.
So we'll move to the last presentation of the day and the event. Ms. Minu TV from Manipal Academy of Higher Education. Her topic is on framework for urban aquatic ecosystem restoration using constructed wetland, linking ecology, economy, and society. Ms. Minu, you have 7 minutes to finish your presentation. Ms. Minu. The last name, yes.
Hello, am I audible?
Yes, Minu, please go on.
Good evening, everyone. I am Sminu, PhD student at ATRI and Manipal. Today, I will be presenting my research work on framework for adopting constructed wetland for urban aquatic system restoration with specific focus on Bangalore lakes. So this work represents a holistic approach that links ecological benefits with economic viability and social acceptance. Bengaluru was once known as the city of thousand lakes. As you can see in the historical sketch of Ulsur Lake from 1834, where the lakes served as the center for agriculture and associated activities. However, this legacy is rapidly declining. From over 1,000 lakes historically, only about 210 remaining today. This dramatic reduction is due to multiple urbanization pressures such as rapid population growth, encroachment on the lakes, poor wastewater management. So the most critical gap identified from literature is the mismatch between wastewater generation and treatment capacity in the city. This has led to severe water quality issues, including increasing nutrient load, eutrophication, and biodiversity loss. While about 30 to 40 lakes have undergone restoration efforts, there are still long way to go. So constructed wetlands are emerged as an effective nature-based solution for lake restoration. Research shows that properly designed constructed wetland can remove approximately 60 to 80% of the phosphorus and around 50 to 55 to 90% of nitrogen also from the incoming water. So the benefits of constructed wetland can be categorized as direct benefits and indirect benefits. Direct benefits such as nutrient removal, heavy metal and pathogen removal, improved water quality, habitat creation, and indirect benefits such as carbon sequestration, climate regulation, flood control, groundwater recharge, etc. So let's look at the specific example. In Yelahanga Lake, demonstrated improvement in water quality have been observed through implementation of constructed wetland and other interventions. So water clarity measured by the Sechi depth has improved to 50 centimeter according to ATRI Water Soil and Lab. So this is the satellite view shows urban water body with the constructed wetland interventions. Despite these proven benefits, we face challenges in scaling up constructed wetland implementation. This is because many studies is focusing solely on technology, ignoring practical implementation challenges. So to make constructed wetland viable and scalable across urban environments, we must integrate ecological, social, and economic factors. This is where our framework comes in. So this is the diagram. This is a photo. It's showing our lab scale setup for nutrient removal studies. Here I have selected canna lily, cypress, and typha for optimization of the nutrient removal in constructed wetland. Here we are optimizing the plant type, plant density, harvesting season and frequency for enhancing the nutrient removal. But to move from the technology to but here this is only the one piece of the largest puzzle. So to move from the technology to adoption or implementation, we need to translate this wetland optimization study into practical ecosystem restoration. So this requires connecting technical parameters with real-world application and understanding the broader context in which constructed wetland can operate. So here my approach is to develop the framework. So for that, I have conducted the comprehensive literature review of the peer-reviewed journals and case studies, and dimensional analysis also done across ecological, social, and economic dimension, and thematic analysis also conducted to identify the pattern, gap analysis, and cross-dimensional integration. So this is the next in slide. I am explaining the constructed wetland adoption framework, what we made across after the literature survey. So constructed wetlands are increasingly a viable solution for urban wastewater management and lake restoration, offering multiple environmental and social benefits. However, their scaling up are faced by many barriers and challenges. One of the primary challenges in constructed wetland adoption is the land availability, as urban spaces are often occupied by competing land use priorities. In addition to land constraint, misconception about the constructed wetland effectiveness, maintenance difficulties, order concern, these can also restrict their adoptions. And other important challenge is, as constructed wetland move from pilot scale to large scale, implementation faces institutional and regulatory challenges. One of the important consideration is the fragmented institutional responsibility, because constructed wetland involve multiple stakeholders like municipal authorities, environmental agencies, water utilities, and local communities. So the absence of coordinating agency often lead to confusion regarding the ownership, operation and maintenance responsibility. And other institutional regulatory challenges include the getting permission and approval delay from a higher authority. But these barriers can, to some extent, can overcome by key drivers. They are design and optimizing the technology. So design is, before I mentioned, the land availability is a constraint. However, with the prototype experiment, one can optimize the plant species, substrate material, and hydraulic retention time, refining constructed wetland design to enhance the nutrient removal efficiency while minimizing land footprint.
Minu, you have 2 minutes to wrap up. Thank you.
It is also important to conduct the baseline study of the practical side before implementation. It will strengthen the care for getting support and providing constructed wetland can fix into existing urban planning framework. Another factor is public perception, awareness, and community engagement. They are the important factors that determine the intervention can scale up or not. So for that, stakeholder survey is important to address the misconception of the community that ensures long-term sustainability. And other important factor is for government agencies and policy makers to get the support for construction. For that, we should conduct constructed wetland economic viability study. For that, it important, along with traditional cost benefit analysis approach, such as justice-based valuation framework, multi-criteria decision analysis, cultural valuation, and continuous monitoring. So it can often provide provide a comprehensive and equitable way to access constructed wetland benefits. So these drivers all are interconnected. So for validating the framework, as part of my PhD, I am conducting microcosm study. So optimizing the constructed wetland through controlled experiments. Here I am optimizing the plant characteristics such as plant type, density, harvesting frequency. Substrate and hydrology is kept as the constant parameters. After that, I have to next to move to the stakeholders engagement for to conduct focus group discussion and interview with scientists, urban planners, policy makers, and local communities, and also have to conduct the cost analysis. Okay, only one more slide. So understanding the economic feasibility of the intervention, the conclusion to develop a comprehensive framework integrating ecological, social, and economic aspect, highlight the need for design optimization, stakeholder survey, and cost benefit analysis. So future enhancement to the work, lab scale plant optimization, field survey, cost benefit analysis. Acknowledgement to MAHE, ETRI, UGC, CDD, and IISc. Thank you. Hello.
Thank you for the presentation. So.
Yeah, nice presentation. Yeah, but if you go through the literature in the past 15 years, we've done a lot of work on constructed wetland.
Yes.
In fact, there are several experimental work which had been carried out by many leading research and academic institutes. In fact, now Central Public Health and Environment Engineering Organization also is coming out with the guideline, maybe released after a year or so, in which they'll come out with all these technical criteria.
Yes.
So whatever experimentation you do, I think it's fine from your PhD point of view, but my request is that slightly move away from conducting these experiments, because we optimize type of plants and there are the studies carried out, what are the different plants in different climatic conditions, soil conditions. So those studies have also been done. So please go through the literature. I think you've gone through. I understand that there's these studies which have been carried out, particularly by academics. The data are yet to be there in public domain.
Yes.
Yeah, just concentrate more on this integration of ecological, social, and economic factors.
Sir, this is one part of my study. So after optimizing for scaling up, what are the other factors? For that, I'm doing the social survey and economic study also. So here, because as you told, there have many studies, but it's like in one study, it may conducted the plant type. In other studies, plant density, and other in harvesting. So integrating all, I couldn't find any study on there, and scaling up. Lab scale studies I have found out, but the second step I couldn't find anywhere, integrating whole this aspects.
But I've not seen many places where the community has rejected constructed wetland based on social reasons or because of order.
Community is not rejected. I have found out the study, many like ICRISAT has done the constructed wetland for the agriculture, constructed wetland in the agricultural area. So the treated water coming from the agriculture, they are using for the irrigation. But after ICRISAT designed and implemented, they hand over to the community. So after 2 years, someone has conducted the study how the maintenance work is going on. But the maintenance work is very poor. Nobody want to directly come in contact.
But that's the problem with almost all the treatment plants. So
because what the factor that identified is like because social hierarchy that's played a big role there.
Yeah,
because
this is very common across the treatment technologies. Water treatment technologies, wastewater treatment technologies, solid waste management technologies. So I'm not demotivating you to go ahead with your PhD, but unless you bring in some specific parameters, I'm sure that you'll find very difficult to add novelty to. Okay, that's my suggestion, but good work. Thank you. Thanks a lot.
Thank you.
For the presentation. So we have one more presenter who's now available, Mr. Chakrabani D, a student from School of Planning and Architecture, Bhopal. His topic is on revitalization of Uyakondan Canal through integrated urban landscape development in Trichy. Chakrabani, you have exactly 7 minutes, so request you to wrap it up soon.
Yes, yeah. Am I audible?
Yeah, you're audible. You can start sharing your screen.
Is my screen visible?
Yeah, it's visible now. Please go on.
Yeah. I'm Chakrapani. I'm basically an architect. Now I'm pursuing my landscape architecture degree in the School of Planning and Architecture, Bhopal. My topic is revitalization of Yuakandan Canal through integrated urban landscape development in Tiruchirappalli. And I'm coming to the broader picture, giving an introduction of the historical city Trichy. And the canal is basically dating back to a Chola dynasty, and it has been strategically located in the river basin of Kaveri Delta, contributes to the reviving of agricultural development also. And coming to the introduction of the canal, its origin is to by the renowned Chola king Rajaraja Chola around 10th century AD, and its vital role is to irrigate the source of the agrarian fields, and the maintenance was being declined by the days later on. And coming to what's a canal, it's a man-made water body which is used to transport goods or irrigation. And nowadays, it's been basically maintained for recreation, or some canals has been abandoned. And coming to the canals ecosystem, the suitable canals ecosystem should have a good riparian vegetation around it, like a 50-meter buffer. And there are plants would be submerged and emerged plants, and aquatic plants would be there. And it will enhance in the fish and invertebrates to have their habitats there. And the biodiversity, coming to the part, mostly freshwater fishes will be there, and the environment should clean water supply, and stable habitat will promote like a good fish like population, as well as if the water quality is good, the riparian buffer will be also enhanced, so that the bird life habitat will be also good, and it will also enhance the good quality of habitats for the birds as well. And coming to the the Uyakondan canals and its sub sewage, the sewage were the ultimate pollution carriers now, by the irrigational maintenance, sedimentation, and clogged soils. The ecosystem is being polluted, the health is being neglected. All this been going on in the canal right now. And coming to the historical context, and it's been strategically placed in the hillocks of Rockfort, and the Srirangam Urayur has been here, and the canal has been flowing towards this direction, where in the early history of Vijayanagara Empire, they started to cater this space where the floodlines of the Kaveri River is going through, and later on the soils got into the contamination started happening in the colonial era, where this cantonment and golden rock settlement has been happening, so that the ultimate flow of the canal, the streams were being into this direction, where they were started dumping the waste, and all this matter have been there. And in 18th century, the urban sprawl has been catered into this much area, where most of the wastewater, which has been not regulated into a direct stream, which has been directed towards the canal, and it leads to a excessive amount of water which is going through the monsoons. It should carry all the storm water as well as the drainage from the household, industrial, and commercial uses. And now this is the floodplain of this Kaveri Delta, where this canal is passing through in this floodplain only, and the major sedimentation is happening, the urban encroachment and lack of maintenance also happening in the canal through. And these are some of the newspaper clippings and the canal, current state of the canal, which is need to be revived and revitalized. And the major research question is to how can a landscape architecture contribute to ecological and social revitalization of the canal, and what sustainable design strategies can be implemented to revive its restore the biodiversity. how can a public place along the canal can be designed to promote social interaction and community participation also. And what role can a cultural preservative play, reconnect on the community and the canal's history and significance. And these are the methodology where I followed, like literature review, then site history, then case study of the relevant sites, and the visual assessment, then community surveys, ecological assessment, then site analysis and master plan. And these are some of the case studies I've done: the Chico Jam, the canal, and the Isar River, Germany, and People's Promenade in Coimbatore. All these were the my preliminary case studies where how they have revived the water system to its betterment, and how it can be implemented. The major points have been taken. And coming to the site part.
To wrap up, please. Thank you.
Yes. Yeah. Okay. Yeah, coming to the like bigger picture of this canal, I have taken the municipal boundary of this canal, where I have shifted to 1 and 2, 3 parts, where I have tested some of the samples of water sample, and this is the watershed map, where the canal is flowing through 3 watersheds of the river Kaveri. And these are some of the the water testing I have done in near the cantonment Fatima. This is the cantonment area. This is Fatima area. And this is Palkar area, where the encroachment and the urbanization has been coming into higher picture. And most of this water testing has been tested as high to moderate, and most of the to carry this into a good and healthy environment. This is the outcome I want to suggest it. And this is the NDVI mapping to show how the vegetation has been sprawling towards the canal. And in the zone ones, the vegetation is quite good in this part, like where the northern side has been a little degraded, and the mostly unhealthy vegetation has been seen. Where we come to the zone 2, the vegetation is very less, and because of the intrusion and the encroachments. And this is urban sprawl, this a visual analysis, and the site context of the canal. And these are the sections to show how urban sprawl and how urban encroachment is happening towards the canal. This is the site analysis of the zone 2 and zone 3, where the zone 3 is coming into the picture of both encroachment area where people are dumping waste into that, and even the agricultural runoff is also being carried to the canal itself. Then the direct wastewater. Yes. Yeah, this is the wastewater discharge. Like these green, the blue arrows have been indicating the stormwater discharge in the channel itself, and the orange arrows in which marks the the wastewater has been disposing directly to the canal without having any treatment, because some of the unapproved plots were being don't have any connection to the existing drainage system. They were directly dumping the waste to the canal itself. And these were the founded flora and fauna, and these were the so to analyze them and to cater more habitable region for the canal. And this is the site of the zone 2. In this also we can see most of the wastewater drainage is happening from this encroachment. And I have spotted some open space analysis to help the community to have a better place for any proposal to be done. And I have proposing a constructed wetland which can be enhance the natural purification process, involves in series of interconnected basin plants to retrieve the aquatic vegetation, wastewater to be cleansed. All this, like microbial breakdown, nutritional absorbent, sediment setting, and impurity, to remove the impurity. Irrigational stability is also been improved. Natural purification is also been there. Ecological health, and will have a sustainable ecosystem towards the site. And I have marked a site which can have facilitate this setup, like having a wetland and a constructed wetland to process the waste, and process the which can process the sediment, and will go to the inlet pool to have the natural cleansing process, and then it will be outlet directly to the canal. And the another intervention I have put into picture is interpretation center to educate people about how a good environment, educating about environment, like conserving the nature, and to educate people about water and their environmental impacts on water, and how a canal is very important to a thriving city like Tiruchirappalli, like for water, and how ecosystem awareness, conservation initiative, community engagements, and then immersive experience on direct access to the nature, and sensory engagement and outdoor learning as well. And these are some of the relative pictures which can depict the interpretation center, how it would be. Like interpretive trials, outdoor exhibits to show the importance of the canal, then observation deck to directly go to the observe the nature of the canal, just to access the canal, then amphitheater to educate people, pavilions and picnic areas. And coming to the conclusion, the revitalization of the Vivekananda Canal offer a promising opportunity to transform a neglected urban waterway to a thriving community asset by integrating landscape design and community engagement in ecological restoration. This project can enhance the biodiversity, improve water quality, creating a vibrant public space as well. The canal revitalization can contribute to sustainable development of Trichy and improve its overall quality of life and residence. Thank you.
Thank you.
Yeah, thanks a lot. Very nice presentation. I have only one question to you, Mr.
Yes.
Chakrabarty.
Yeah.
I think conceptually it looks very good, and that we can prepare several such plans, which are very, very impressive.
Yeah.
And you also made mention of one of the case study from Coimbatore, and have translated that conceptual plan to reality. So what is that should be done by you so that this particular plan also turns into reality? So what are your plans? Do you want to take up this as your project and MTech project or whatever it is? Are you thinking in future also that you will mobilize funds through local municipal corporation, you may do some crowd funding also? So what are your plans? Just be brief, please.
Yes, I have gone through some of the urban initiatives and some public open people, and even the PW is helping through me. And some of the data which I have gathered through a government circle as well. And some of the people, there is an NGO which has also been working with them, so that I can integrate all my design strategies and the outcomes. It is possible to get into a better picture, creating a public open space along with the wetland, which can facilitate both the which can improve the water quality as well as the urban pressure to the water.
Mr. Chakravarti,
yeah,
I have a simple query.
Yeah.
Say in your design, have you incorporated the high rainfall event? Say if the rainfall is more than 30% of the normal rainfall in an hour, in a day or in a month, how your design will go up with that?
Yes, actually, the most of that's what my main case was. I'm still yet to do the rainwater analysis to the picture, where I need to add some a GIS calculation also to get into the picture. But I have marked the major floodplain is falling into the Kaveri Delta, where the canal itself falling into the floodplain of the Kaveri river. So that the most of the water is being directed to the Kaveri and the Kollidam river, which is adjacent to the canal, and that is the major thing which is carrying forward the water, the excess water, as for now, as per the documents which I have got from PWD water. Yes.
Please listen. My point is, if your canal design discharge is say 10,000 cubic.
Yes.
If the rainfall happens so that the flow will be 40,000 cubic, what will happen? What is the contingency plan?
I never thought about that, sir. I haven't thought about that. but I need to give some backup plans to get the water into the nearest point, or giving a like a sponge or a lake to get into the percolation aspect.
Thank you, Chakrabarti.
Yes, yes.
For the last presentation of the day. Just. Yes, we are done. No more presentations. Thank you so much to the jury for spending your time with us and going through meticulously through each presentation and asking questions. We look forward to the scores, and an important announcement for all the presenters is that we'll take a few days to collate all the scores and get back to you with the final results. But thank you very much for being with us, for taking out time and traveling in some cases and sharing your studies and your work with us. Thanks again, and hope to see you soon in the next event. Thank you. Just a small thing, before leaving, there's high tea organized outside, so please help yourself to tea and coffee. Officially closure of the event, sir. Thank you again. Yeah, go ahead. Yeah.